Oh, John, I think Emily. Oh, yeah. Good morning, everybody. Buenos dias. So I hope you're enjoying the temperatures in Washington, D.C., Alaskan style. Not. Trying to kill time here. Um, I do hope that you enjoyed the reception last night, courtesy of the Alaska State Society. Yeah. I believe we do have some of the technical issues under control this morning. The program should follow much more smoothly than yesterday morning. And I believe we are ready to start with the first speaker of the morning. It's going to be Dr. Martin Jeffries, presently Director of Polar Sciences, Office of Science and Technology Policy, Executive Office of the President. And he's going to be talking to us about the Interagency Arctic Research Policy Committee and the Arctic Executive Steering Committee, Marine and Maritime Issues.
Thank you, Pablo. I stood here 10 years ago, same meeting, and I was representing the National Science Foundation at the time, where I was program director for the Arctic Observing Network, and I talked about our early efforts to initiate that program. It's good to be back 10 years later, this time representing the Office of Science and Technology Policy in the Executive Office of the President. Thanks to the organizers, particularly John and Pablo, for the invitation to speak. I've been at OSTP for 16 months. I began on the 29th of February last year. When OSTP asked me, when would you like to begin, I chose the 29th of February. You can't do that every year. So it's a date you don't tend to forget. Let's see if I've got the controls under control. So the United States is an Arctic nation. It says so in National Security Presidential Directive and Homeland Security Presidential Directive that was issued on the 9th of January 2009. I'll summarize the policy in a moment, but first let's take a look at why the United States is an Arctic nation. We have what you might call the legislated Arctic that was defined by the Arctic Research and Policy Act of 1984, and that's what is illustrated here. And you saw this map more than once yesterday. There are other ways to define the Arctic Circle, the Arctic watershed, the tree line, permafrost, and so on. But this is one particular Arctic you will see defined fairly often, but the fact remains is we are an Arctic nation because of Alaska. The 49th state, as you heard from Admiral Tukumpt yesterday, purchased from Russia in 1867 for what now looks like a very small sum of money. And as he said, as the Admiral said yesterday, it quickly became known as Seward's Folly because no one thought, why would the United States want such a distant, cold place? But it ceased to look foolish in 1968, only 9 years after statehood, when oil, very large amounts of oil and gas, were discovered at Prudhoe Bay on the North Slope. Right there. And I don't have Parkinson's. So, as I say, the Arctic can be defined in a number of different ways, but no matter how you define it, the United States is an Arctic nation. as I say, defined in the Arctic Research and Policy Act, which, more importantly than the legislated Arctic that it defined, it created the US Arctic Research Commission and the US Interagency Arctic Research Policy Committee. I'll say more about those two organizations in a moment, but let's return to the Arctic region policy. The policy is 10 pages long. If you wish to see the entire policy document, it's available online. I will summarize it as it is summarized here on the screen by these 6 points. Meet national security and homeland security needs. Protect the Arctic environment, conserve its biological resources. Ensure that natural resource management and economic development are environmentally sustainable. Strengthen institutions for cooperation in the Arctic, particularly the Arctic Council, which, as you know, the United States chaired until recently when it handed over the chairmanship to Finland in mid-May in Fairbanks, Alaska. Number 5 is involve the Arctic's indigenous communities in decisions that affect them. I think yesterday quite a number of speakers mentioned the importance of the people of the Arctic to our endeavors. And finally, enhance scientific monitoring and research into local, regional, and global environmental issues. The Arctic region policy also states that the Arctic region, and this is relevant to this conference, this is why I mention it, the Arctic region is primarily a maritime domain. And Section F of the policy states that United States priorities for maritime transportation in the Arctic region are facilitate safe, secure, and reliable navigation, protect maritime commerce, and protect the environment. So I mentioned that the Arctic Research and Policy Act of 1984 created 2 organizations, the United States Arctic Research Commission, and you heard from Fran Ulmer, the chair of the commission, yesterday morning. The commission has 8 presidentially appointed commissioners, plus the director of the National Science Foundation, currently Dr. Franz Cordova. And the Interagency Arctic Research Policy Committee, IARPC for short, from now on, has 10 core agencies and any other additional agencies as appropriate or necessary. And it is chaired by the National Science Foundation. At the risk of oversimplifying the Act, it requires the Arctic Research Commission to produce an annual goals and objectives report. Think of it as advice to the President and to Congress, based on consultations with a broad range of stakeholders that include federal departments and agencies, the state of Alaska, Alaska Natives and Native organizations, academia, NGOs, and the private sector. IARPC then considers those goals and objectives and prepares a 5-year plan, the Arctic Research Plan, also in consultation with a broad range of stakeholders. And the plan is, under the law, to be updated every 2 years. IARPC has been a subcommittee of the National Science and Technology Council in OSTP, the Office of Science and Technology Policy, since 2011. This was an important moment because it was the catalyst for IARPC to prepare and implement the first ever comprehensive Arctic research plan. That covered the period 2013 through 2017. It was released in February 13 and implementation was completed in December of 2016. The second comprehensive Arctic research plan covering the period 2017 through 2021 was released in mid-December 2016. The second plan has 9 goals. The topics of those goals are shown here. Each goal has a number of research objectives and performance elements. In the entire plan, there are 34 research objectives and 123 performance elements. The performance elements are concrete tasks that we have set ourselves to work on, hopefully complete, to demonstrate progress on the implementation of the plan. Ruth, are you smiling? I just mentioned that word. Elements of each of these goals can be connected to Arctic marine and maritime issues, although some goals have stronger connections than others. But I think I could, if I had time, make a case that each of those goals has a connection to marine and maritime issues. But here are some examples. The obvious one is sea ice, which we all know during the summertime now is receding great distances from the shore, opening up an awful lot of open water. The spatial and temporal variability of sea ice thickness, its extent, particularly in the summer, and its volume are clearly a major concern for marine and maritime activities. Glaciers, ice caps, and the Greenland ice sheet goal, very relevant to marine and maritime activities. You heard David Jackson mention icebergs yesterday, an obvious hazard to navigation. But also ice mass loss from the glaciers and the Greenland ice sheet through iceberg carving and through melting, and how that contributes to rising sea levels, not only in the Arctic but outside the Arctic, where this has implications for ports and harbors and naval installations and so on. And of course, coastal flooding impacts on communities, etc. Speaking of which, Arctic coastal infrastructure and community resilience, and by association, community health and well-being, are affected by accelerated coastal erosion. The latter is exacerbated by warming and thawing permafrost, sea ice retreat and greater open water and wave height. Wave heights are increasing in the Arctic Ocean with the retreat of the ice cover and the greater fetch. And increased storminess and storm surges. All issues relevant to everyone in this room, I would say. Goal number 9, I highlight here, environmental intelligence, which is a combination of observations, data stewardship, data management, and computer modeling, numerical modeling. The purpose of this goal is it addresses the need to expedite timely, reliable, and actionable information to stakeholders by integrating observations with modeling and effective data management. With respect to marine and maritime issues, this might, for example, include Arctic domain awareness. That's an observing issue. And also to environmental forecasting, weather, water, and sea ice, as you heard yesterday from NOAA. And all this information can enhance decision support. IARPC fosters collaborations among United States researchers and others, those numerous stakeholders I mentioned earlier, the state of Alaska, Alaska Natives, Alaska Native organizations, academia, and so on. And between the United States and overseas researchers. The implementation of the first Arctic Research Plan realized the creation of IARPC collaborations. It's both a platform and a practice. The platform is the website, which is more than a website. It's really a science social media platform where information is shared, new ideas are generated, progress is reported on those performance elements, and collaborations are fostered. The practice is US federal government researchers, program officers, and others, the feds, and non-feds, including overseas participants, working together to address hard problems through collaboration. Currently, IARPC Collaborations has about 1,300 members, about 10% are from overseas. Since the preparation of the first Arctic Research Plan and the launch of IARPC Collaborations, there's been an unprecedented degree of scientific conversation, cooperation, coordination, and collaboration, the 4 Cs, among US government departments and agencies, and between them and the broader research and related community outside of the federal government. I invite you to go to IARPC Collaborations, to learn about IARPC and the Arctic Research Plan, and become a member if you aren't already a member. Get involved. It's easy to do. You just click at the top right-hand corner of the website, and membership will be almost instant. Now I'll turn to the Arctic Executive Steering Committee, the AESC. You heard Admiral Allen briefly refer to the AESC yesterday. It was created in 2015, and the AESC provides guidance to executive departments and agencies and coordinates efforts to implement the priorities, objectives, activities, and responsibilities identified in NSPD 66 and HSPD 25, the Arctic Region Policy, the national strategy for the Arctic region, and related agency plans. Where applicable, and this will sound familiar, the AESC works with State of Alaska, local and Alaska Native tribal governments, and similar Alaska Native organizations, academic and research institutions, and private and non-profit sectors. I've already given a brief description of NSPD 66, HSPD 25. Before I say a few words about the national strategy for the Arctic region, let me just draw your attention to 5 working groups that focus on particular high priority issues. Those are groups addressing issues related to Alaska Natives and Native organizations, the people who live in the Arctic, who make it their home, community resilience, also very much related to the people who live in the Arctic, an energy working group, which I think should be energy and power, but that might be my misunderstanding, the Arctic Digital Elevation Model, the Arctic DEM as it's sometimes called, and the Arctic Science Ministerial. I don't reboot very well.
There we go. Afraid that might happen.
Thank you. The National Strategy for the Arctic Region was released in May 2013. It has 3 lines of effort you see here: advance United States security interests, pursue responsible Arctic region stewardship, and strengthen international collaboration. Note the 4 guiding principles: safeguard peace and stability, make decisions using the best available information. We heard that from Admiral Tsukumt yesterday also. Pursue innovative arrangements, and coordinate and consult with Alaska Natives. If you're getting a sense of the importance of our work in relation to the people of the Arctic, that's what point I'm trying to get across. I was at a meeting at the Wilson Center about 3 weeks ago, the Arctic Circle Forum, and a Norwegian member of parliament was on a panel, and he made a very interesting comment. He said, I go to so many talks where you see ships and landscapes and animals and so on, but no one ever puts a picture of the people of the Arctic in there. And I think we should never forget that there are people who live in the Arctic. It is their home. Each line of effort has a number of objectives. There are 11 in total, as you see here. I won't read them to you. Let me give you some examples of activities and accomplishments under these objectives, things that have been achieved so far. Okay. It stopped advancing.
All right.
So the Committee for the Maritime Transportation System has been very busy addressing objectives in the national strategy for the Arctic region, and they've prepared and released 3 reports so far. Helen Brohl, who is the executive director of the CMTS, she was here yesterday, maybe is here today, and she will be chairing a panel later today. And if you want more information about the CMTS and Arctic work, is it tomorrow? I'm sure she'd be happy to talk to you. Alison Azara was here yesterday. Alison's here, and she has played a big role in this effort too. Thank you, Alison. Arctic domain awareness. The Department of Homeland Security funds the Arctic Domain Awareness Center at the University of Alaska, Anchorage. They have a number of partners in Alaska and elsewhere. Church Key, the executive director of ADAC, is here, and I'm sure he would be happy to tell you more about ADAC if you corner him over coffee or whatever. NOAA has an ambitious Arctic navigation agenda, and you heard something about this yesterday from Craig. And you heard from, again, Admiral Tsukamp. He has quite an impact, doesn't he? He talked about the Arctic Coast Guard Forum, that the US Coast Guard is a signatory to and an active member. And the United States and the Arctic Council, as I mentioned earlier, it chaired the Arctic Council from May 2015 through May 2017 and handed over to Finland recently. And I draw your attention to 3 agreements here that have been signed, not during the US chairmanship, not all of them, but 3 agreements signed under the auspices of the Arctic Council that are relevant to marine and maritime issues. I mentioned the Arctic Council Scientific Cooperation Agreement because it is relevant to marine and maritime issues because, as somebody mentioned yesterday, icebreakers are infrastructure, and icebreakers provide access, and infrastructure and access are parts of this science cooperation agreement. I think it's important, or at least I'm going to take advantage of this forum to mention science cooperation in the Arctic. And I'll do that in a moment. Sorry, I'm losing track here. But first, let me link the Arctic Executive Steering Committee to IARPC. They are not 2 separate bodies working in isolation. The AESC has its 3 lines of effort. The Arctic Research Plan has its goals. What connects them is the objective, the NSAR objective of increased understanding of the Arctic through scientific research and traditional knowledge. And the reporting that IARPC is required to do annually to the National Science and Technology Council and biennially to Congress, this is our contribution to the reporting on progress on the national strategy for the Arctic region. Scientific research, basic research, fundamental research, curiosity-driven research, call it what you will, also contributes to national security. This picture shows a boy on the ice, and you may say, oh, shrug your shoulders, it's just another boy. And there are many of them out there each year. But that was one of a dozen boys that were deployed by an Office of Naval Research team in the spring of 2014. And they were the surface expression of an underwater acoustic communication and navigation array, part of the marginal ice zone study. And that array was supporting the navigation and communication with underwater sea gliders. They were operating underwater in the open water, and they were operating under the marginal ice zone and the pack ice during the summertime in the Arctic. This was increasing our knowledge and understanding of the ice-ocean system, but it's an ONR project, and it was therefore also contributing to new capabilities, potential capabilities, that the Navy might use in the Arctic in the future. And I come back to international science cooperation. Scientific research also strengthens international cooperation in the Arctic. Here you see scientists from 10 countries who worked aboard the Korean research vessel Araon in the summer of 2014. And there was a group of 6 ONR-supported scientists aboard that ship. I mentioned the Arctic Council Science Cooperation Agreement a moment ago. It exemplifies intergovernmental science cooperation. But international science cooperation frequently originates with the scientists themselves at the grassroots level, if you will. Indeed, I'd say that scientists are expert at developing and executing international collaborations across boundaries and borders, across oceans and continents, and between hemispheres. In so doing, Arctic scientists and the Arctic research community, they practice science diplomacy, sometimes known as soft power or smart power. Science diplomacy is the use of scientific collaborations among nations to address common problems and to build constructive international partnerships. And who do we depend on for those international science collaborations? Scientists, of course. There are no international scientific cooperation. There is no international science cooperation or collaboration without the scientists. That concludes my remarks. Thank you.
Thank you, Martin. You already cut into Simon's time, but there are a few questions, and at least I want to address one of them. Is there any chance that the current administration will revise the current IRPIC 5-year plan that was released in December, but lasts until 2021?
I do not know if there is a plan currently, but when we prepared the plan, and it's actually written in the plan that we recognized that there was an impending change of administration and that we would focus on the first 2 years, allowing time for possible changes and updates, which the law requires anyway. Our plan is supposed to be updated every 2 years. So.
And very quickly, who now chairs the AESC, since the president has not yet appointed a science advisor to replace Holden, previous director of OSTP?
The chair of the AESC is the director of the Office of Science and Technology Policy, and there is not a director at the moment. It's co-chaired by the National Security Council, and there is an executive director who Thad Allen mentioned yesterday was previously Ambassador Mark Brzezinski. He was ambassador to Sweden for a number of years, and I am currently the acting executive director of the AESC.
Thank you. Thank you for your presentation as well.
I have glasses.
Oh, yeah. I have to say that
my lips are a bit dry.
The glasses wipes have been, the bag with them has been misplaced. So if anybody has seen a huge bag with those, let me know. So we can provide one to Martin. Plenty of chapstick. I'd like to invite Mr. Simon Stephenson. He's going to be talking about NSF and its portfolio of Arctic Ocean research.
Just a sec. Has everyone who's in the back row who wanted a seat taken a seat? Because there's still plenty up here in the second row. Third row even. Excellent views. Okay.
We promise we won't bite.
Simon?
All right, sir. Thanks. The middle's laser pointer. Okay. Forward, back. And this shows current slide, next slide, and time.
Okay. All right, so that's me. And I'm going to talk about the NSF portfolio. I'm not going to talk too much about the science results, but just to give you really a flavor of the range of work that NSF supports in the as this symposium considers the impacts of a changing Arctic. Outline Arctic observing is probably where we spend most of our funds on work related to the symposium topic. Some of that work is also focused on processes and just simple discovery, synthesis, putting it together, and as Martin has talked about, we also have a program addressing humans, not just the indigenous community, but also the sort of global community. And then I will briefly talk about a new theme, navigating the new Arctic at NSF. So you can just about make out the ocean portfolio here in the blue on blue coloring. This is the Arctic observing portfolio from 2000 when the program really began. In response to a small workshop that NSF hosted, actually at NSF, encouraging us to create a program of long-term observing. As you see, the atmosphere, ocean, and sea ice make up the bulk of that portfolio, and that's sort of consistently continued through up to the present. And projects do come and go, and I'll talk about both ones that are in the past and currently going on, and some in the future. But the next slide sort of shows the portfolio in terms of number of projects. These are not number of awards, that would be higher because there are collaborative projects. But the number of projects, it's sort of stable around about 20 now. The big jump up after 2011 was actually the stimulus package going into the field. So that was quite a significant ramp up for our observing portfolio. A typical project, I can't talk about them all, but a typical project is the International Arctic Buoy Program. This is actually collaboratively funded across the international community, but also I've listed NSF and NOAA, but I think ONR and NASA also provide currently support to the buoy program. And this has really, been a fantastic program run out of University of Washington, looking primarily at meteorological and oceanography data from the upper ocean, 79 to the present. Our support kicked in somewhere in about 2002. One of my favorite stories about what scientists can do that sometimes the agencies and the international community find, or formal communities find more difficult, is during the IPY, there was a US-funded buoy placed in the ocean by a French research team off a Chinese vessel. And I can't imagine the number of agreements the agencies would have to do to put that into place. But that's what they did just by a few emails. So it's fantastic work. And so that's continuing. They're always looking for funding, we continue to support that. The North Pole Environmental Observatory was actually our earliest funding from an observing program point of view. In the left, you see the buoy drift map that the team put in. On the right-hand side is the aerial CDD chemistry surveys on a grid pattern that was coordinated not just with the awardees under North Pole, but also several other awardees looking at the upper ocean chemistry. They're particularly looking at the changing layers, the changing surface oceanography and the atmosphere above it in the central Arctic basin. And one result, this is probably the most sciencey slide I'll show, coming out of that work by Morrison and others in Nature, was showing the freshening of the Beaufort Sea. So this is an effort that was particularly focused on an annual airborne hydrographic survey, deployment of drifting buoys, and actually the maintenance of a deep ocean bottom pressure sensor that was used to calibrate satellite data. And this is another aspect, just like the International Buoy Program. There's a large interchange between the field programs and the satellite data, and this result was using the satellite data as well. Another long-term observing program is actually building off something run in the biology directorate, and that's the long-term ecological research. So while NSF is famous for its 3 to 5 year grant cycle, back in the 80s, the biology program realized that, that you couldn't actually understand ecosystem change in those time cycles, that ecosystem change occurs on longer time cycles. So they transformed the way they supported a piece of their portfolio in long-term ecological research or sites. And Ken Dunton and his team have just put in the proposal, and it's been awarded to look at ecosystem change along 3 sites along the north coast of Alaska, from Katovik over to Barrow. And so they're looking at the drivers, the forcing between the between the ocean drivers and the terrestrial drivers in the food web on the coastal lagoons. And this is critical to understand because the communities along that northern coast are primarily subsistence communities and rely very heavily on the food and in those systems. They're also looking at natural cycles and how those are changing the productivity, and also looking at how warming and thawing permafrost, the changes in the sea ice that Martin mentioned with the higher wave heights, how those sorts of other drivers in this changing Arctic are changing the system. I believe the SciSex program was discussed yesterday, but I can't really help not discuss it again, or at least touch on it. The submarine is just an amazing platform, or potentially amazing platform. NSF has been very involved with the Navy since the mid-90s. The phase 1, where scientists were on board, is over. Phase 2, we're in phase 2 now. There are challenges with the program. I think that came up a little bit yesterday. It's difficult to write a proposal to NSF if you don't know what data you're going to get and when you're going to get it. But it is possible to write a proposal to NSF if you've already got the data. So looking back on the data collection is definitely something that we're interested in doing, just as we did in the 90s with the sea ice draft profiling. So the science community have worked up a science plan, and understanding the difficulties that go along with using a platform that is actually so sensitive in its primary mission. We do encourage the science community and the Navy to continue to make SciSex available, because it is a truly amazing platform potentially for us. So that's the observing profiles. I'd like to move now to more of the process studies and discovery. And geotraces is a good example of what we expect to be in both of those sort of themes. The goal was to identify processes and quantify fluxes that control the distributions of key trace elements and isotopes. That's from the proposal. What that actually means is you'll take the different trace chemicals coming into the system from the bottom, from the ocean bed, in through the atmosphere and in through the gateways, and by tracking how those traces change, how they interact with the system, you can actually study both processes and also structure of the whole Arctic Ocean, not just the surface now, but the whole water column. And we've learned how to do this in the rest of the ocean in a relatively new set of efforts. But the Arctic remained as one of the last challenges because of the ice cover, of course. So at least 6 countries have gotten together: US, Germany, Canada, Sweden, UK, and Russia as the leads. But other countries were involved in the actual science. So this was a great program in 2015. And the results are still actually being worked up. The picture there on the bottom is the polar stern meeting up with the Healy at the North Pole to close those two transects. The U.S. transect is in the red line. The next project on discovery and processes is Mosaic. So this is to be. It's in 2019 to 2020, freezing the German vessel, the Polar Stern, into the ice pack on the Russian side and watch it drift over. There'll be sort of remote stations, support getting people in and out through and overflights from NASA and the German program. So this is to come. I'm mentioning it in our portfolio because we have decided to support some projects. Alas, we haven't funded them yet. So that we haven't yet announced what we're funding. So I can't tell you who's been awarded. There will be a few projects that we will announce in the next month or two. Some projects will also repropose or propose anew, seeing what the gaps are. And so our portfolio will join the Department of Energy, who've already decided to support atmospheric radiation monitoring with their mobile labs. So that's great. I'm not sure this next slide will actually work, but it shows maybe, yeah, okay. So this is just a sort of cartoon about the many processes that are in play that the Polar Stern will be looking at. This actually began in the atmospheric working group of the International Arctic Science Committee. This working group was relatively newly established, and they went back to first principles of what we don't know, primarily about the atmosphere. Clearly, they were interested in its interactions with the ocean and sea ice, but they were really looking at the equations of state for the atmosphere. And that was really the beginning of Mosaic back in 2011. It's come a long way, and people have sort of built off those initial questions to add in the sea ice, add in the ocean system, and because of the German leadership of this project and their strength in ecosystems, they've put that in too. Because the platform, again, just like the submarines, is such a unique platform. The last time we did this was in Schieber in the late 90s. So all of this data is great. It's coming out. It gets published in the papers. Equally important in our portfolio is the ability to put the pieces together primarily through modeling and other tools of synthesis. And so Andrei Proshetinsky some time ago proposed basically a forum for modelers and observers to get together. And this has become a very popular forum. In fact, he told me the other day he's actually going to have to limit the people going to his fall meeting because it's become so popular. However, the limitation is really just to make sure that the discussion actually happens in a manageable group of people, but the impact and the results they intend to sort of share more through a sort of social media approach. But it's to make sure that the different modeling teams are talking to the observing teams, that they're doing the reanalysis and examining different methods to do so, and exploring the different corrections for initial conditions and boundary conditions. So that's been a very successful tool funded out of the Arctic System Science Program. So I'm going to step now to sort of interactions with the people who live in the Arctic. In the 2000s, say, community-based observing became an important tool. Martin, when he was the program officer for Aeon, the first one, funded NSF's first efforts in community-based monitoring. So that's the bottom piece of this little cartoon, the person on the ground working with satellites and aircraft. And so, but in this sort of rendering, you can see that the people on the ground are supporting a bigger effort, which is often driven by agency needs or scientist needs. community-based monitoring also can be, and this was actually the first proposal that we supported, community-based monitoring for community needs, and both are okay. And so this is actually a new award to Lilla Lesser. It was funded just in time for the Arctic Science Ministerial, where we were bringing together the different approaches to community-based monitoring, including ones that are driven by agencies, ones that are driven locally, and looking at the best practices across, across that domain. Another effort funded by the Social Science Program was looking at documenting indigenous knowledge. And this is really the first step in pulling in communities to work with scientists to produce new knowledge that's driven as much by the community needs as by the scientific needs. This is a term the term we use is co-production of knowledge. And this is really sort of where I think a lot of our portfolio will, well, actually not maybe a lot of portfolio, but a considerable piece of our portfolio will head at the intersection of science and local needs. And this last slide is an activity led by Paul Berkman and others called Pan-Arctic Options. And this is sort of an example of where the social system, engineers, and policy, and the actual changing natural system all intersect. And so this was funded a couple of years ago, and it's has participation by Canadian, Chinese, French, Norwegian, Russian scientists, along with the US. It was actually funded, I think, by Russian and French funding agencies along with NSF. And so we're very excited about this model. This kind of integration is actually sort of the way we're thinking about this new activity called Navigating the New Arctic. So Navigating the New Arctic started off as a big idea at NSF. There were 10 of them developed last summer at NSF to get the agency to think more integratively across its whole portfolio. And it started really focusing in on the observing part of that scheme. But as I've just illustrated, really the observing has to be driven by the information needs and what you want to really understand. So as we've developed this activity, not just with the Arctic Science section, but with our engineering directorate, with the social science directorate, obviously with geo and biologists, and actually also the computer sciences and technology development parts of NSF. So really almost all of NSF sort of sees a role in understanding the new Arctic. And our hope is that we will be able to move this idea, this big idea, forward across the agency.
Thank you, Simon. Actually, there was one online. Thank you. WIPes have been fun. One question, online question, but your last comment actually answered it. The question was, you mentioned the Bio Directorate, but are there other significant investments in Arctic research at NSF that are outside of the Office of Polar Programs?
Yeah, so there are. Certainly it's in bio. The social science program in geo, we do have one, so it's in the Arctic. Has a lot of funding with social science, social, behavioral, and economic sciences is the full name of the directorate. We have had less with engineering. A few years ago, maybe a decade ago, engineers said, you have really interesting issues and problems, but they affect so few people that that's really not where our priority lies. That view has changed as the Arctic has become sort of more of a global problem. People in the engineering directorate have been very interested in participating, and we're getting help from them to sort of frame some of the questions coming out.
Thank you. Yes.
Simon, I have a quick question.
Give one to your friend.
Oh, my friend?
Yeah.
Oh.
Simon, that was very interesting. You mentioned the greater integration around NSF on Arctic. That's wonderful to hear. Is there a reallocation of resources across NSF or the directorate to support more Arctic research in the Division of Polar Programs, for example?
No, I don't think so. We're trying to make the case in the sort of typical budget cycle that we have a case to be made, and that's where this big idea is sort of sitting. It's sort of an informative stage, but I think we can make that case. It depends on what resources the NSF gets and how those get allocated. But I think what's been pleasing is that other directorates are sending their program offices to these navigating meetings and saying, yeah, we see ourselves in this.
Thanks. Let's leave it at that. And I was chastised yesterday for cutting on the break time. So for speakers, if we get to the 20-minute line, we're going to cut on the question period. The next speaker is Dr. Walt Meyer, formerly with NASA, presently back with NSIDC. He's going to talk about the long-term changes in the ice retreat and open water season in the Arctic, potential implications for operations in the region. And he's going to be perfectly on time.
Okay. Thanks, Pablo. I want to thank Pablo and John for asking me to present, inviting me to present. I'd like to think that the major reason for that is interested in hearing what I have to say. But as Pablo made clear at one point, was he wanted a NASA scientist to give a talk. So I want to thank Pablo and John a second time for keeping me on the agenda after I let them know that I was going to be leaving NASA shortly before this symposium. So I am now at the National Snow and Ice Data Center officially. Before I get started, I guess I will, to fulfill kind of my NASA duties as an unofficial NASA news, because I'm not a NASA employee anymore, I'll just mention that ICESat 2 is coming along quite nicely. It's on schedule for a launch next summer. And IceBridge flights are, they're doing their summer campaign right now. They just started. So lots of cool stuff going on at NASA. And so I'm going to talk here about a specific project that I started with colleagues Mike Steele at the University of Washington, Angela Bliss, who's at Goddard and the University of Maryland, and Peng Di at NC State and NOAA. And this is the goal of this is to look at some climate indicators for sea ice. So what is an indicator? Just for those that may not be, probably most people are familiar, but the definition, it's something that we regularly updated. It's something that we can kind of get a good sense of what the ice conditions are or whatever climate conditions we're looking at, provides scientific understanding, but also geared towards informing decision-making and in meeting management objectives. So it's kind of distilling the science down into ways that can help decision-making. One of the things with a climate indicator, it needs to be consistent and continuous over a long period of time, and it's important that it be of high scientific quality. So one of the most common sea ice indicator, I'd say, is the sea ice extent. That's what you see most frequently. This is on the left is the yesterday's sea ice extent and total extent for the Arctic. We're tracking pretty close to 2012 levels right now. And then on the right is the September monthly average. Again, I'm sure you've seen this many times in the long-term declining trend. So this is very useful information. The goal of our project is to see how we can expand on this and go beyond this and provide new information that can provide new insights. Before I do that, I want to comment on These are based on the passive microwave sensors, and the indicators that I'm going to be talking about next are also based primarily on the passive microwave record. And so I would just want to take this opportunity, again, many people may be familiar with this, but our passive microwave sensor record is I would say, at risk. We've had a long series of the DMSP, Defense Department satellites, the F-series, and those are now aging and getting quite old. We're also looking and using AMSR-2 from the JAXA, the Japanese Space Agency, and that also has gone beyond its mission lifetime. These usually last a fair amount of time, and so hopefully there's not any immediate threat. But if you look out into the future, you'll notice that there's really nothing much planned until the early 2020s. So we're hoping that these satellites will last. There are some other potential stopgap measures we could use, but this is kind of the foundation of our one of our major sea ice climate records. And if we lose this, we'll lose at least some of the quality of that record. So, looking at the sea ice indicators, again, the goal of this project is to develop new indicators that go beyond extent, to give us a little more detail on the sea ice cover, more insights into the seasonal evolution, give us some better indication or different indications of the weather and climate processes that are affecting the sea ice, something that has more regional and local applicability beyond just an Arctic-wide total extent, and also something that perhaps has more relevancy for stakeholders. So just to quickly summarize the data, again, like I mentioned, this is passive microwave based. We have a couple melt onset data sets, which is basically using thresholds of passive microwave frequency, brightness temperatures to detect when the surface melt on the snow on the sea ice occurs. One, the Anderson et al. Product, it's archived at NSIDC, and one at Goddard by Torsten Marcus and others. And then the sea ice concentration data set, the climate data record developed by NOAA and NSIDC. So as we developed the indicators, we kind of looked at this and looked at the summer sea ice cycle and wanted to see, how could we capture, the typical cycle. You're starting out in winter, you have the early onset of melt, the snow starts melting, then you get surface melt, then it forms into the ponds, and then the ice starts thinning and breaking up, and then you have your open water season until the late summer when you start to freeze up in the growth season. So Mike Steele came up with the idea of kind of tracking the stages of this by looking at the ice concentration. So you have an opening when the concentration drops below 80%, then what we call the retreat when it drops below 15%, which is essentially the open water definition in the passive microwave data. That's the minimum concentration that is detected. And then in the freeze-up stage, you have what we call the advance, when you first start ice forming over 15%, and then closing when you get into the consolidated ice pack greater than 80%. And so we have periods here. The range between the opening and the retreat is the summer loss of ice period, or slip. And then in the end of summer, the range between the advance and closing, the summer growth of ice period, or SGIP. And then we have open water periods. This is the outer open water period is where we have really any open water or any significant open water detected. And then the inner open water where it's essentially completely ice-free, at least as detected by the passive microwave data. And I'll make a point here, like I said, we're using the passive microwave record. There are, I won't go into the details, but of course there's limitations of the passive microwave, and there's different algorithms. And for example, the operational analyses may be somewhat different in what they detect and how they define the ice cover. But the thing is, with this method, you could use different data sets and do the same type of analysis, and that's something we're looking at doing to compare these. So This is just an average. We have these for each year, but I'll keep it simple. This is the opening. We can make maps of these. And it may be a little bit hard to read this, but this is March through December with the different color shading. So, you get a lot of the opening that is occurring here in the August period. And really, some of this it may not really open much at all. Then this is retreat, and then you end up into the advance, and then the closing. So you see the regionality there. You can see the maps that it kind of generally comes from the north or from the south to the north, and then back the seasonal cycle. But you can look at those, and then if you then look at the ranges, the slip range and the SGIP in the open water periods. Again, making these maps, you can see some interesting features. Again, you lose that somewhat of that north or south to north because you get the difference in how much the ice from when it starts to open up to when it completely starts to where it completely retreats. Like in the Beaufort here, there's this area here that basically stays around longer. The darker colors being a longer time period. The Greenland Sea, where you get some opening, but it of course usually doesn't clear out completely of ice. And so this gives a sense of how the ice cover and the variability over the ice. So these are nice, but we want to look at a way of distilling this even further to inform again decision making and something that can be kind of looked at a glance. So Angela Bliss, who's here, came up with this. I think this is a really interesting way of looking at things. Again, when we were trying to find a way to distill this down, kind of trying to brainstorm ideas, and Angela came up with this. And it's basically taking this and kind of looking at the areas that open up, and then basically plotting these sequentially. So this is time going forward in years, going up from 1979 to 2015. And then this is across the calendar year, January to December. So this is for the total Arctic. We have 3 different melt onset products, actually, or parameters. Like I said, there's 2 products, and the Marcus, the NASA Goddard product, actually has 2 melt onset. There's an early melt, and then there's a continuous. And so the early melt is when we first see any sign of melt, and then the continuous melts when it's basically going continuously. There's no diurnal effect or anything like that. So so you see that, and you'll notice that there's even the early and the continuous and the red and the green compared to the AHRA or the Anderson and Bliss, the NSIDC product. There's quite a bit of difference, upwards of a month difference, and that's something that we've been looking at. Angela has a very nice paper, Bliss et al. In 2017, that goes into details of why that is, and it's basically different sensitivities of the algorithm to the changes in the passive microwave signal. But you can taking that, you see the melt, and then you have the gap, the length between the melt and when it starts to open, crosses the 80% threshold. And then that slip period in the light blue till you hit the open water, and then you hit the freeze up where you get the 15%, and then the gray is the SGIP period. So this gives us basically in a snapshot the complete evolution, summer seasonal cycle of the sea ice. And again, this is over the total Arctic where we have open water in each year. And so you can do this over different regions. The Arctic is maybe not the most important region, but first, another way of looking at this is kind of looking almost like an anomaly where we center it on the center of the open water period, so you kind of get a sense of a better sense of how long the open water period is in kind of more of a perhaps a better relative sense. So that's 2 different ways we've put together of looking at this. But again, the total Arctic is maybe not the most interesting area. So We can do this for subregions. I got a little messed up there, but the title. But this is the Beaufort Sea. Here's the regions here. The Beaufort here in the orange. It's a little hard to see there. But you can see there's quite a bit of variability in the timing and the length of these various seasons. I think that's one thing that just shows really nicely. And that has perhaps implications for sea ice forecasting, how well you can do that. And sometimes it's early, sometimes it's late. Some of the open water period is quite long, like in '96. Sometimes it's quite short, like in '85, I think this is. So this gives us again a nice kind of a different way of looking at things. And this is the Beaufort Sea. This is the Chukchi Sea. So you can see the contrast there between the Beaufort and the Chukchi, even though the Chukchi is right next to it. Much longer open water season because of the way the ice melt and the way the ice dynamics as well plays a role in that. But again, some variability there. And then again, we can look at these from the centered. And again, you see maybe a little bit more clearly here the variability in these different seasons between the two. That's the Beaufort Sea, and then the Chukchi Sea. And again, we can do this for any of these regions here, or even hone in on even more local areas as needed. For example, if we wanted to look at just kind of the Beaufort or the Barrow region, for example, that would be something that's of relevance to stakeholders, perhaps, or certain sub-regions of the Chukchi Sea where you're maybe looking for access. And do these same types of things, same types of plots. So what we're planning to do is to implement this more fully. Eventually, we will put this out on website, probably at NSIDC, and this will be available hopefully before too long to interested users. And then we can tailor this potentially to specific users fairly easily, add on different specific regions, and so that's the goal of this. Just because I'm formally of NASA, I want to make sure I mention again, or I mention if I didn't, that this is a NASA-funded project through the Climate Indicators Program. So I'm going to switch gears just slightly at the end, take a couple minutes on another climate indicators project that I've been involved with. This is actually a special issue for climatic change. It's a special issue on national indicators of climatic changes. We have a large group of us led by Diane Stanitsky and Jana Entreri at NOAA, leading a review paper essentially of the sea ice, the existing sea ice climate indicators, and also the climate indicators that are needed and to fulfill gaps. And one of the ways to do this is to have a conceptual model and look at all the interactions in the sea ice and the rest of the Arctic climate system. Because what you're looking for in these climate indicators is not only beyond sea ice extent, but beyond sea ice, to look at Arctic-wide climate indicators and looking beyond just the physical indicators, which is what's been most commonly developed, but also the biological, social, and economic indicators to help basically tie these all together. So we have this conceptual model, which is based on an NSF report. And I think we've tweaked this a little bit more. But Martin, you'll be happy to know we do have a person in there. And that was one of the things as we've been discussing this and discussing changes. One of the things that we got to make sure we keep a human in there, because that's a key part of this indicator effort. Is we're serving the human communities and the social aspects, not just looking at physical indicators. And then also looking at global, pan-Arctic, regional, and all the way down to the community level. And so, we're kind of reviewing these, looking at what's currently out there, currently available, looking at what's in development, basically what's kind of being developed is just not quite an indicator yet. Things that have been proposed, such as the project that we're working on, and then more aspirational, where things like we really could use an indicator here, but we don't have that. We don't even maybe have the data but can we get the data, or how could we get the data? So that's the goal, basically, is this review paper will help inform that and perhaps get discussion and help spur on the needed climate indicators. So just a quick summary. The indicators are helping us summarize and synthesize complex data. They're giving us concise information, kind of distilling things down in ways that can really help decision making. Also help visualize and communicate the climate change and identify kind of the processes that are important or maybe most important and potentially help develop mitigation and adaptation strategies. And again, at the end, it's important to have these very scientifically validated data, regularly updated and continuous. And of course, the bottom line is you want it to be value to the user communities. You don't want to do something that's just for your own scientific interest or whatever. So with that, I will finish.
Thank you, Walt.
There's time for questions. And let me, my final comment here, my shameless self-promotion, since there's a lot of sea ice folks here, if you're thinking about submitting to AGU, if you only submit one abstract, I would highly recommend that session that I'm co-convening.
My final comment to you is no questions for you.
Oh, okay.
But if anybody wants to, they can catch you at the break.
Okay. Thanks.
The next talk is going to be by Dr. Son Niem from NASA JPL. He's going to talk about the geophysical contradistinction between Arctic and Antarctic sea ice change. And Son, we're already running 5 minutes behind, so.
All right, sir.
Another 5 minutes to that.
All right, sir. Forward, back, laser pointer.
First, thank you, Pablo, for the introduction, and good morning. So I would like to acknowledge the contributions of my colleague to this research, Ignatius Rieger from University of Washington, Pablo here, Don Perovich and Chris Polosensky from Corel, Greg Newman and Peggy Lee also from the NASA Jet Propulsion Laboratory. So the objectives is really simple here. The first objective is we want to examine the differences between Arctic and Antarctic sea ice change to address the sea ice paradox, which is why the Arctic sea ice has been reducing, not just reducing, but reducing drastically, whereas the Antarctic sea ice has been stable or even slightly increased. And the second science objective, I think, which is also important, is to identify the factors that can be the basis that allow sea ice forecast and prediction. So with that, let's take a look at the Arctic sea ice. You see here the synoptic sea ice class, which is our hypothesis to say that its change is actually a double jeopardy for the drastic reduction of the Arctic sea ice. So in the Arctic, we have primarily two types of the sea ice. One is the perennial sea ice, which is the old thick sea ice that can survive at least one summer, or you can understand this include both the second year ice and the multi-year sea ice, that it can be thick and it is important to the ice mass and the ice pack stability in the Arctic. The second type of ice is what we call seasonal ice, that kind of ice that grow and melt seasonally every year. And then it includes the marginal ice at the ice edge, which is a feeble kind of ice, which is thin and weak and easily melted and decreased. So let's take a look here. What we show here, the white area, which is the perennial sea ice, and the bluish area here, which is the seasonal sea ice. And this is for 2001. And you can see just a few years after that, it reduced tremendously. And then if you look at the long-term change of that perennial sea ice, and by the way, we show here is the condition in March, which is the transition into the springtime. The data that you see in the open diamond here is from the TRIF-H model. Actually, it is a data simulation from the buoy measurement that with the buoy tracking, you know how long the ice has been staying in the Arctic, and then this model would kind of use that information to determine whether the sea ice stay in the Arctic long enough to call it perennial ice. So in the 50 and 60, you don't see any discernible change, but in the 3 decades after that, from the 70, 80, and 90, the decrease of the perennial sea ice extent in March is about 500,000 square kilometers per decade. But look what happened in the 2000, which is the first decade of the 21st century. You have a precipitous decrease, which is triple the loss rates in the previous decades. And it is verified by the observation from the NASA scatterometer data, which is the black square in here, so it's validate the result from the TRIF-H model using the buoy data. And the reason why there's such a loss, because in the 2000s, there's more and more of that dipole pattern in the Arctic. Basically, it merged the wind together and accelerate the polar drift that pull the Arctic sea ice along the direction. And if you look at the bathymetry of that, you can see that is this along the Lomonosov Ridge and the Gecko Ridge. So you think of it as a channel, and the wind blew on it, and then it just pushed the ice out of the Arctic, and then it went down to the Greenland Sea, where you see that the warm water from the Gulf Stream come up and melt it. You can think of it this way. You go to your refrigerator, right? Take the ice out of the refrigerator, put it on your kitchen sink, and pour hot water on that. That can be a very effective way to lose the sea ice. So it's not losing the sea ice in space, in place, but it's the dynamic that caused that loss, right? And why is it a double jeopardy here now that is more dominated by the seasonal ice? The seasonal ice, by definition, is the younger ice, a thinner ice. So you start with the thin ice already. But then on top of that, the seasonal ice is flat. So if you take a cup of water, pour it on your table, the water spread out very quickly, immediately. And is the melt pond. And the melt pond has a lower albedo, which allow more solar heat absorption. Whereas for the perennial sea ice is typically rough, so these water pull it in a smaller area but deeper. Therefore, the albedo of that cannot reduce that much. So with that, I show here one example from the satellite observation with the high resolution data. And you can see here, this is the smooth seasonal sea ice. It looks darker. It's kind of like you wear a hot, black shirt, go out in the sun, and you stand in the sun for 5 minutes. You know how hot it's going to get, right? And then the perennial sea ice, you see here, it ponded into a smaller area, and therefore it's kind of like you wear a white or gray shirt out there, and so it can get kind of warm, but not that bad. So with that, what I want to discuss here is that you see here, this is a from the National Climate Assessment Report, which is a showing here is the model for the representative concentration pathway with the 2.6 watt per meter, which is slightly heating to 8.5 watt per meter, which is a very strong heating. And even with that, it cannot explain the record of the total sea ice extent in the September period, which is at the end of the sea ice season. And you can see here, none of this, it doesn't matter how you put the heat in there, it cannot explain this trend. So why is that? If you took at the March condition that I showed earlier, you can see here is that it really captured that trend. Let me push back and forth a little bit here, that you can see that. So why is that? Because in March, it already show you how much of that Arctic sea ice composed of the perennial ice, which is kind of like wearing a white shirt, and how much of that, which is more dominant by the seasonal sea ice, is like wearing a black shirt. So in March, you already know beforehand how much you're going to get warm by wearing the black shirt. And that would dictate how much of the solar heating that would be absorbed that. And with that, you can kind of capture the decrease trend in the total sea ice extent in summer. So I flip back and forth for you to see here. So it captured that very well. Another very important factor is actually the warm water discharge from the river. And this, I have not heard anything from the previous talk since the last 2 days, how the terrestrial heating through the river discharge interact with the Arctic sea ice. And here I show one example. You can see this is the mouth of the Mackenzie River, and it's released a massive amount of hot water go into the Arctic and then melt the sea ice. But remember, warm fresh water is lighter, so it stays on the surface, and then it can melt sea ice very effectively. The way it works is very interesting. Before the warm water can be released by the river, there is a land-fast ice that cover the mouth of the Mackenzie River, and it is again controlled by the bathymetry. So the bathymetry holds this ice back as a barrier, and more of the water, which get warmer and warmer as it go into further into the spring and the summer season. And then once it's break away from that land-fast ice, which was controlled by the bathymetry, then it's released a massive amount of heat that go into the ocean and melt that. And then if you take a look of the entire Arctic region, in here there's a 72 river that discharge into the Arctic. And I published this result in a GRL paper, and the estimate of the total heating energy that released into the Arctic is about 10 exabytes exajoule per year, per 1 degree above freezing. So probably you are not kind of imagine how big this energy is, but let me put it in this way. This is equivalent to 2.5 gigatons of TNT per degree per year above the freezing. So if you take like the amount of warming just like as cold as the wine that you chew in your refrigerator, multiply this number by 5 or 10 times. Now let me give you a very interesting homework, and you can actually do it right now. Go to your Google, right? Search how much TNT equivalent that the Hiroshima bomb is. And then you take this number, multiply it by 5 or 10, divided by the Hiroshima number. You will shock yourself to see how many Hiroshima bombs that the river put in the Arctic each and every year. All right, but then let's take a look at the Antarctic. There's no such a river. It's basically a frozen continent. And that is one of the stark contrasts between Arctic and Antarctic. So with that, we take a look now at the Antarctic sea ice. So you see here the polar sea ice paradox, saying that there is a stability in the Antarctic sea ice, or even slightly increasing. So to address this issue, we need to look at a number of science questions that are interrelated. First of all, what is it that produced that the Antarctic sea ice so effectively? If you make a lot of money, you go to Las Vegas, you spend all of that, then you still have nothing. So the second question is that what is it that protects the Antarctic sea ice cover? And then those factors has to be sustained there in the Antarctic. If you have a protecting factor, sometimes it's there, sometimes it's not, and it's not very effective. So why is it sustained there? And then what caused the regional variability? Because in the Antarctic sea ice, also the overall trend is stable or slightly increases, but regionally, some region you have a decrease, some region you have a very stable, and some region you have an increase a little bit in the Antarctic sea ice extent. And then whatever reason you explain all of that, it has to be consistent among all of these factors, because if can explain one part of it but contradict to another part, then it still doesn't work. What is also very important is that the same physics, because physics is physics. I mean, if you use it for the Antarctic sea ice, it has to be applicable to Arctic sea ice too, but then why they have an opposite trend in the Antarctic and Arctic sea ice. So this is what we are looking at. So to, okay, somehow it's not. All right. So there has been a number of explanation or hypotheses trying to explain that. One of which is that there is an ozone change that somehow make the region cooler and increase the Antarctic sea ice. However, there are counter arguments that is not effective enough. There are other hypothesis says because of the lower salinity density in the near surface that weaken the mixing or the enhancement of the thermohalocline stratification. Basically the meltwater, which is fresher, that go up to the surface and then make it fresher, and they're easier for the sea ice to freeze. However, as you know, if some of you already go into the Antarctic, you know how strong the wind over there, so the mixing is not a very effective, the requirement for the quiescent condition is not very effective because of the strong mixing there, and some other hypotheses saying it's because of the wind intensification. Anyway, let's take a look at what kind of ice that we see in the Antarctic. Here I show the 10 year of data in the September period, which is the maximum extent of the Antarctic sea ice. So Antarctic sea ice is almost come and go every year. So it's kind of like a seasonal ice, only very little that can survive that. But then you can see here, we can even classify that into different kind of ice. You see that the darker cyan color here is a younger ice, and the thicker, older ice is at the outer part of it. And you see in all year, it formed what we call the frontal ice zone that surrounded and encapsulated the Antarctic sea ice cover. And it acts like a protective zone that protect the internal sea ice. So what happened here is, I show here, that's how it looked like over there, is the total opposite of the marginal ice zones in the Arctic. And then you can see here that in the internal of the sea ice, right, then you can see that because it's thinner, so it can grow pretty effectively, and then it can produce a lot of ice in this way. And what driving that is the wind. In here, there's this paper that show that if you look at the wind, it's basically controlled by the topography of the Antarctic sea ice. And then you can see that the Antarctic topography would shape the wind direction, including the katabatic wind. And you can see here there's a split in the two-way in the Rossi. So let's take a look at this sea surface temperature. Another factor that control that is the okay, let me see here. Is the boundary between the warm and the cold water, which is called the Southern Antarctic Circumpolar Front, is determined by the bathymetry that you see here. So the bathymetry would control where the hot and the cold water is, and that would determine where the sea ice is. And then you can see here that if you look at the Kerguelen Plateau, you can see a trough there, and it's actually the sea surface temperature follow that very closely, even squeeze through that trough. So if you look at the Antarctic, basically is encircled by the bathymetry that protect the sea ice by determining where the hot and the cold water is. except for the area here that the Bellingshausen Sea and the Amundsen Sea, you don't see any feature, so the bathymetry lose control, and therefore it's allowed the climatic factor to affect this, and this area can lose the sea ice because of that factor. So in general, the Antarctic sea ice is controlled by both the topography and the bathymetry, which are geological factor rather than climatic factor. That's why it's so stable. When we address this, we inadvertently solve another mystery, which you see here. There are two islands, the Bouvet Island and the Heard Island. Both of them are in the Southern Ocean, and both of them are about 1,000 miles away from the Antarctic continent shore. But the Bouvet Island is covered by thick glacier, and it has sea ice surrounded each and every year. The reason is very simple, because it's in the south of the boundary in the cold sides of the ocean, whereas the Heard Island, you have a vegetation cover, and the sea ice never reach it because it stays in the north of the boundary in the hot sides. So if you take a look at it in terms of the sea ice property, the Antarctic circumpolar ice is surrounded by the thicker, older ice, whereas the opposite in the Arctic, where it's, you have the marginal ice near the ice edge, which is very easily to be decreased when go into the melt season. If you look at the atmospheric forcing, the Antarctic wind actually create the ice factory that I explained earlier, and then recirculate that ice versus in the Arctic wind that cause the sea ice loss. That, like I say, that it pull the ice out of the Arctic, like you take the ice to your kitchen sink and melt it. In terms of the ocean forcing, you see the Antarctic bathymetry constrain the location of the boundary between the hot and the cold water, whereas the Arctic bathymetry is responsible for mechanism that actually aggravate the sea ice loss. For example, the way that it control the release of the river discharge, as well as the Lomonosov Ridge and the Gecko Ridge that kind of shape the direction where the ice can be exported out of the Arctic. So with that, I can take questions, or if you have more questions, you can always send me an email at this address.
Thank you, son. We will send you an email. Okay, I failed. I believe that the break is going to be short, and I just wanted to remind you, if you haven't gotten your tickets for Seablind, do so for the lunch break. And also, if you haven't looked at the updated program, we have switched General Key's time slot with Congressman Young's time slot. So if you want to listen to Don Young, make sure that you're here at 11:05. You may want to listen even to Church Key. So I'll see you all back at 10:25 sharp. That's for the panel. All right, please take your seats. We're ready to start.
If the box comes up, just let me know and I'll reset it.
Okay, I'll say it in English. Please take your seats. We're ready to start. Scientists. All right, the next speaker is Dr. Larry Mayer. He's the director of the School of Marine Science and Ocean Engineering and the Center for Coastal and Ocean Mapping at the University of New Hampshire. And he's also a commissioner of the USARC Research Commission. He's going to talk on the status of the extended continental shelf activities in the Arctic.
Thank you, Pablo. And I guess several of the speakers yesterday and even this morning mentioned the extended continental shelf. And what I'm going to try to do is to very, very briefly summarize or update you on the status of the U.S. activities in terms of extended continental shelf mapping, but also try to touch upon the activities of the other coastal states. And it goes without saying, but I'm going to say it anyway, that I present my comments in a personal capacity and I don't at all represent the United States government. When we talk about the extended continental shelf, we're really talking about a part of the Convention of the Law of the Sea. This is a remarkable constitution for the oceans. And in particular, we're talking about one little article of it, Article 76, just 617 words that have this remarkable power of changing the definition of the continental shelf. Geologists know what a continental shelf is, but the lawyers have stepped in here and defined now a juridical or legal continental shelf. And that juridical or legal continental shelf offers a coastal state the opportunity to extend its sovereign rights over resources of the seabed and subsoil to ranges much, much further than the geologic continental shelf. They provide a very kind of complicated formula to do that, a set of formula to do that. Basically, if we look at what the continental shelf looks like, if a coastal state has a continental shelf, a geologic continental shelf that extends beyond 200 nautical miles, Article 76 provides these mechanisms that then let you find what they call the foot of the continental slope, move outward from there 60 nautical miles, or, and it's an and/or, determine the thickness of sediment on the continental margin and find the foot of the continental slope and find the point where the thickness of sediment is 1% of the distance back to the foot of the slope. Very, very complicated. You can mix and match these to whichever is to your advantage and then apply some constraints or what they call limit lines where you basically look at either the 2,500 meter depth contour plus 100 nautical miles or, and it's an and/or again, 350 nautical miles from the baselines, basically the shoreline. And again, the article provides a complicated way to put all this together, and at the end of the day, you come up with the limits of your extended continental shelf. It's very complicated. You don't have to worry about it. What you have to remember, though, is that in order to do this, we have to map the seafloor. We have to determine where the foot of the slope is. We have to determine where the sediment, what the sediment thickness is, where the 2,500 meter contour is, and where 350 nautical miles from the baseline is. As we've all know and have heard many times, the U.S. has not acceded to the Law of the Sea Convention yet, but many years ago, 2002, 2003, Congress came to our lab and asked us to start the process because we have always hoped that we would accede to the treaty, and so start the process of collecting the data needed to establish the limits of the continental shelf. We also in the U.S. recognize the Law of the Sea Treaty as international customary law, and in that context too, we're establishing what those limits are under international customary law. And so since 2003, our lab has been mapping all around the world where the U.S. has a potential for an extended continental shelf, but what you can see is that by far most activity has taken place in the Arctic, where we've had at least 8 cruises doing this mapping since 2003. Globally, we've mapped more than 2.6 million square kilometers, collecting new high-resolution, what we call multi-beam sonar data, very high-resolution data, and I'm very proud to say those data are made available publicly as soon as we finish collecting them. We have concentrated so much on the Arctic because the Arctic is a very special case in terms of an ocean basin. 52% of that basin is geologic continental shelf, and I think the next highest number is something like the Atlantic with only 17% geologic continental shelf. And if we start off with 52% of the basin as geologic continental shelf, much, much more of that is going to be extended continental shelf belonging to somebody in the region. So it's an area where most of the basin will be extended continental shelf. As we know and have heard, it's an area that is resource rich and also, of course, an area with a very, very fragile environmental conditions, and the Law of the Sea Treaty allows you to extend your protection of that environment through the extended continental shelf too. It's very interesting in as much as there are 5 Arctic coastal states that have a potential extended continental shelf, and they're all opposing. They face each other. So inevitably, there's going to be tremendous potential overlap in where their extended continental shelves will be. It also, of course, presents a tremendous logistical challenge. How do we map in the ice? Because even though we've seen, and as I'll mention in a minute, it's been tremendously to our advantage in terms of mapping. The only thing that it's probably good for the degradation of the sea ice, particularly in the summer. Most of the areas we map still are ice covered, and we have to figure out how to do that. We've heard also about the very small number, 1.5, 2.5 maybe, icebreakers that we have. We're fortunate that our Arctic icebreaker, the Healy, though, is equipped with a very sophisticated mapping system, one of these multi-beam mapping systems, and so we've been able to learn how to break ice and map at the same time, and we've done this over the years. We're not the only ones who've done this. There are now probably about 5 other relatively large icebreakers equipped with multi-beam sonars. Most of those equipped because of the desire of a coastal state to collect data in support of Law of the Sea issues. And some of them, like the German Polarstern and the Odin, have been used by other nations, by some of the coastal states, to help their ECS mapping efforts. Interesting, and to put it in the context of this meeting of diminishing ice, none of that mapping would have been as easy to do as it has been. It has been that easy, but it would have been much, much difficult 15 or 25 years ago, and that's because of these curves we've seen of the diminishing ice extent, minimum ice extent in typically September, a decline of about 13% per decade, and I saw that Walt actually showed that picture to where we are. This is as of 2 days ago. We're on track for the record minimum of 2012 right now. Using the Healy, we've mapped about 442,000 square kilometers in the Arctic. You can see most of that mapping is done with individual lines because we're breaking ice. We can't do the kind of normal mowing the lawn we do in open water. But in 2012, we were able to get complete coverage in this area because, believe it or not, despite the fact that almost every year we run into the ice margin at 75, 76 degrees north, in 2012 the ice margin was well above 80 north, and so it was really quite remarkable. And we can't go into an unexplored ocean like this and start mapping like this without making a number of new discoveries. On our very first cruise, and you could barely see, this is what the existing map looked like. We ran over an 11,000-foot high seamount, now called Healy Seamount. We've mapped many more undiscovered seamounts since then. We found fields of pockmarks on Chukchi Cap indicating gas effusion, probably, and also home to interesting habitats. We saw what we call megascale glacial lineations. These are not just iceberg scours. These represent the presence of an ice sheet way high up on Chukchi Cap that has totally rechanged our understanding of the presence of ice in the Arctic in past ice ages. And as Senator Murkowski mentioned, we have done some dredging in terms of trying to understand the geologic continuity of the features we see there. And these dredge results have really changed our understanding of the geologic evolution of the Arctic. And we'll be seeing a series of papers coming out about that very, very soon. So to look at a summary of the U.S. activities over the last few years, we have the EEZ, the U.S. EEC marked off here. From our desktop study way back in 2002, with the little we knew about the morphology, the shape of the Arctic basin at the time, we assumed we would find the foot of the slope, which is that point we measure everything from at a spot like here, and then just with a simple exercise from that, assume that we would have an extended continental shelf, which looks something like this. Not insignificant, something like twice the size of the state of California in terms of area. What we've learned since then, though, is that the foot of the slope actually continues way up here, and this has changed our view of where the extended continental shelf is. This is something that's being worked on right now by what's called an ECS task force, and we will have indeed an extended continental shelf at least as large as this and maybe larger, but it will inevitably overlap with Canada, whose extended continental shelf comes out this way. So we will clearly have some negotiation with Canada to do. This is an area where we still have a dispute over a boundary in the EEZ, let alone the extended continental shelf. The one place we also have a tremendous overlap with is with Russia, but in this case, we already have a negotiated maritime boundary, and the Russians have respected that boundary in their submissions, and we respect it. And so there is no issue in terms of overlap with Russia. That's a negotiated boundary that exists already. And let's look at what the other nations have been doing. Russia was actually the first nation to make a submission to what's called the Commission on the Limits of the Continental Shelf, a commission that adjudicates the submission and sees whether it's in line with the treaty. They made a submission back in 2001, and that submission was turned back to the Russians. It was not accepted by the Commission, saying that they just didn't provide enough of the underlying data. And so since that time, the Russians have been remarkably active, mapping all over the Arctic. They've acquired a multi-beam system on the academic Fedorov. They've been working with both nuclear icebreakers, leading the multi-beam ship. They've been using research submarines. They've been using drilling platforms, a tremendous effort they've made, and they have put in a new submission now supported by a lot of data that, again, covers a very, very large part of the Arctic, but of course respects that negotiated maritime boundary with the U.S. So this is the state of the Russian submission right now. It's being adjudicated by the Commission and should hear back maybe within a year or two on that. Norway has had a small area where it has a potential extended continental shelf. They worked very hard and very early. They made their submission in December of 2006. They've received what we call positive recommendations, meaning that the Commission agreed that their limits were in accordance with the treaty, and so that's been all established. But one of the very neat things, and one of the real advantages of the treaty in general, is that the Commission is not allowed to look at a submission if there is a disagreement over a maritime boundary. The Commission has no jurisdiction over maritime boundaries. So if one country says we have a dispute over maritime boundary, it stops the process. And so what has happened is, as countries make submissions, they work very hard to negotiate any kind of maritime boundary dispute. And so this little area in Norway led to the resolution of a 40-year unresolved maritime boundary between Russia and Norway, which was resolved on June 8th, 2011 in the Barents Sea. And so this is, we see this all over the world between nations that have unresolved boundaries. They're trying to resolve them so that their submissions will be looked at. Canada has two areas in the Eastern Arctic and the Western Arctic. In the Eastern Arctic, which is in the Lincoln Sea, this is one of the ice-thick areas. Even in all the diminishing ice, there's still tremendously thick ice. The last bits of the multi-year ice still sit in the Lincoln Sea. And so they've been working with Denmark, who share, again, a boundary through Greenland, on looking at the Lomonosov Ridge. They're doing this mostly from ice camps, from helicopter-deployed single sounding measurements. Some of the most amazing measurements in the world, $17,000 for a single depth measurement, but that's the value to the nation as they send helicopters out to make a measurement and been trying to put together a picture there. In the Western Arctic, Canada has been working in close conjunction with the U.S. We've had, despite our overlaps, we've had 4 wonderfully collaborative cruises. You've seen this picture yesterday from Admiral Zunkoft. What he didn't show you is this picture, and maybe he hasn't seen this picture. This is the Healy freeing up the Louis Saint Laurent in thick ice, and at this point the Healy is backing down. And you can tell, you probably can't see it here, but you can tell this is a Canadian ship here because they're wearing their uniform with shorts in the Arctic. Canada had collected what they thought was all the data they needed for their submission because there had been a decision to establish limits that did not include the North Pole. The night before the data was sent to the Commission at the UN on December 2013, the press released this picture of what were indeed an accurate representation of what the Canadian submission would look like. And the then Prime Minister Harper said, no, the North Pole is part of Canada. He withdrew the Canadian submission and has since that time, Canada has spent about $60 million buying multi-beam systems, equipping them, having two icebreaker cruises over the last 3 years to try to collect data in that region to demonstrate that the North Pole is indeed part of a Canadian submission. And we'll see Canada will be making their submission, that revised submission, in 2018. Denmark, working through its Greenland territory, has again been working very hard in this area. They have been the ones leasing Russian icebreakers, leasing Swedish icebreakers, German icebreakers, working collaboratively to try to collect data in this area. In their initial documents, and all the initial indications were that their submission would be in this region here, just going up to the North Pole. But when the Canadians withdrew their submission and said, no, they would be making a submission that included the North Pole, the Danish, when they made their submission, turned in a very, very aggressive submission, and this has now been turned in December 2014. That included not just the North Pole, but extended all the way to the Russian boundary up to Lomonosov Ridge. And so this has led to a very, very interesting situation of tremendous overlap. The red is the Russian limits of their submission. The gold is the Danish limits, and we have yet to see the Canadian limits, which will inevitably come in here too. So we're leading to a very, very interesting situation. And so to try to just wrap this up and looking what the situation is right now, a very complicated picture, but let me just try to make that a little clearer. We have, in terms of a U.S.-Russian, there will definitely be overlap, but we have a negotiated boundary, so there just is no issue between the U.S. and Russia in terms of the limits of the continental shelf. There is a tremendous issue, and it's wonderful that scientifically we've worked together for so many years, and now we leave the trouble to the diplomats and the lawyers, as Canada and the U.S. will have to work out how their overlapping submissions are going to be divided. We have each written letter saying that we allow the Commission to look at anything, but we will resolve bilaterally those boundaries. There's a small issue. Iceland has protested Norwegian and Danish region here, and that will get resolved in the next few years. But the big issue, of course, will be the Danish, Russian, and Canadian overlap. And that will be lots of work for maritime lawyers and diplomats. And first, we have to see what the Commission says. And as this is, again, a very personal statement, as I see it, I think most of their submissions will be upheld by the Commission. So they are entitled to those areas. It's a question of how they're going to divide it. And so let me end there. I promised Pablo I wouldn't go over time. Did I go over time?
No.
No.
By 1 minute.
By 1 minute?
By
well,
5.
you know, that's a, and thank you all for your attention.
Thank you.
I especially wore my glasses today.
No, if anybody has questions for you, they could address them directly. We need to move forward with the program so that we stay on time. The next presentation is going to be by General Churchkey, U.S. Air Force retired. He's the Executive Director of the Arctic Domain Awareness Center, or ADAC, and he's going to talk on reflections on advancing science and technology in support of the Arctic operator.
Let me know when you're ready, sir.
Go.
You're going to start with the movie? That's the movie. Are you going to start with the movie?
But no music.
Oh, you want music.
I didn't pay enough.
Oh, okay.
I asked for the AB guys.
All right.
It's okay. Has a really cute, good music to go with this, so you just kind of visualize it going with, but nonetheless, let it play out.
I have some salsa here.
That no work, GI. Like a silent movie.
Yes, sir.
Okay, thank you. And again, this goes forward and this goes back, right?
Yes, sir.
Okay. Thank you. Retired General Officer, I require special handling by commissioned officers, and lieutenant rank is the perfect rank for me to work with, so bear with me. Good morning. It is a privilege to present to you today. I also have the privilege of serving as Executive Director for the Arctic Domain Awareness Center. ADAC is one of a constellation of centers of excellence from the Office of University Programs at DHS, U.S. Department of Homeland Security, Science and Technology. Is that better? Okay, thank you. ADAC is hubbed at the University of Alaska, split between University of Alaska Anchorage and University of Alaska Fairbanks. We, of course, have an array of research that's conducted via fellow universities, industry, and other research entities. I will quickly review some reflections how we in ADAC are trying to respond to the needs of the Arctic operator as we seek to provide solutions that may help advance awareness and improve mission effectiveness for one of the most challenging regions that maritime operators face on our planet. So we in ADAC seek to accomplish an array of science and technology that corresponds to increasing understanding of the physical environment of the Arctic. Investigate and conduct specific research needs that are driven by the Coast Guard operator. Accordingly, we in ADAC are oriented to understand the mission and requirement in order to conduct the most relevant research to support the operator. We also want operators to drive the research agenda. We seek to understand the concerns of Coast Guard operators at the headquarters, at the area, specifically in Pacific and Atlantic areas, and at the district level, specifically District 17, and then work with science technology, Office of University programs to develop and then conduct operational focused research. And then, of course, we also conduct dedicated forums where we get below the topical level of ideas with operators and help them help us drive the research agenda. We seek to conduct both fundamental and applied research. While we're oriented towards applied research, we submit there needs to be a strong aspects of fundamental research as both are needed in the portfolio. We also believe it's important to think both in near-term and longer-term views on what the Arctic operator will need. And certainly we understand that, and we look in the near term, how does that drive the longer term perspective? We seek to understand the Arctic as presenting itself and research ways to reduce risk to the operator. Ultimately, our researchers need to investigate, develop, refine, deliver, and transition capabilities that can be used by the operator. This is not easy stuff, but it is the expected outcome of our sponsoring agency at DHS, S&T OUP. In ADAC, we understand the principal focus of the U.S. Coast Guard is about safety and security, preparedness, and response in the Arctic maritime domain. Accordingly, this focus is oriented to the Coast Guard prosecuting missions in humanitarian assistance, search and rescue, waterways management, disaster response, major response operations. This includes things such as coping with a disabled cruise vessel, and law enforcement activities such as illicit trafficking, illicit resource extraction, such as illegal fishing or illegal taking of marine mammals. These mission sets, coupled with a very difficult environment, vast distances and limited response forces, provide a daunting challenge that day-to-day is a problem enough, but then when you couple it with some of the more severe conditions that the Arctic can deliver, it results in both the operational force and the command echelons facing staggering levels of risk. Therefore, any means can be used to reduce these risks by leveraging science and technology makes sense because it can make the difference between safe mission accomplishment or the loss of life. As stated earlier in the conference, the diminishing ice environment in the Arctic is a key enabler to human activity, increased human activity across the Arctic maritime domain. Whereas sea ice once served as an effective barrier to people operating substantially across the Arctic for essentially nearly all of recorded human history, the continued seasonal decrease in overall volume of sea ice is opening up many opportunities for such as destination tourism, maritime shipping, and then, of course, resource extraction, just as Larry mentioned in his previous discussions. Whereas many of the commercial activities, those folks doing commercial activities, understand the concept of being able to provide for themselves and ultimately help their own response, at the end of the day, those costs are fairly substantial and sometimes serve to be an inhibitor, specifically when you look at folks that are not there routinely, but perhaps the occasional visitor to the Arctic. In this aspect, some of those costs then are unwittingly or unknowingly often transferred to the Coast Guard to have to pick up the slack or deal with the consequences when bad things happen. A diminishing ice environment also means these decreasing barriers also provide an opportunity for illegal activities. And certainly the remoteness of the Arctic provides, quote, the unlocked, unopened back door to the approaches to national borders in the Arctic region. This is, of course, not a comprehensive list, but does provide a fairly decent sampling of many areas of concern of the Coast Guard being able to prosecute an array of missions in the Arctic region. Many of these operator concerns can be linked to the Coast Guard Arctic Strategy or the Arctic Strategy implementation plans as well. Again, not a comprehensive list, but get you something to start with. As someone who is relatively new to the Arctic research community, as a former Air Force guy, it is remarkable from my vantage point to see the genuine level of participation and collaboration amongst the community of Arctic researchers. To me, this number of committed people and essentially bringing their own resources to the table to think through the challenging problems is an innovative way to find low-cost solutions, which, of course, we are all mindful of the cost aspects in the Arctic. As somewhat of an economy of force theater, if you think of it as context, compared to perhaps some of the things that are more commensurate with pressing problems in lower latitudes. And accordingly, and no doubt this is fairly obvious, solutions to problems provided by the Coast Guard and other operators can best be addressed by continued partnering and collaborating. And teaming, of course, will provide better solutions. As a small research enterprise, we in ADAC are striving to help. And ultimately, we will offer a few of the snapshots of you of our current research and some previous research for the next course of minutes, because these are our contributions supporting the Coast Guard, the Arctic operator, and of course, also to support the public good. These are a couple examples of the next few moments. One, of course, is an Arctic oil spill modeling project where partners at Texas A&M University and our colleagues at University of Alaska Anchorage and understanding what's happening from the seabed all the way to the surface, interaction, how oil not only comes from the seabed up, but then how it interacts with the sea ice. And our products in this aspect go into NOAA's general plan to go into NOAA's general modeling environment. We have a long-range autonomous underwater vehicle that's being conducted in partnership with Woods Hole Oceanographic Institution, as well as Monterey Bay Aquarium Research Institute, to provide essentially a Tethys platform that can go up to 600 kilometers under sea ice to be able to do 3D mapping of essentially an oil spill under ice, and being able to be handled without special, provided no special handling equipment. Our high-resolution modeling of sea ice currents leverages satellite information, essentially get to a 4-kilometer resolution pan-Arctic, and then much higher resolution routinely at 2 kilometers, and then even more so increased levels of precision as you get to a more focused region. And this is a product that we've been able to get into our colleagues at NOAA's Office of Response and Restoration in their Arctic IRMA, their Environmental Response Management Application product. A new project we hope to have underway by the end of the month is leveraging ship data to help essentially create a set of potential surveying, if you will, of areas for prosecuting what's most rational for near coastal areas in bathymetry. A big problem, as we mentioned multiple times through this conference. Another project we hope to get underway at the end of the month here is seeking to create a series of products that are enabling the decision maker and leveraging weather forecast and crisis response to really help the decision maker cue a risk managed set of decisions in order to send forces really more wittingly equipped to deal with the crisis on scene, and ultimately for both the operational force and the command echelons at Sector Anchorage and District 17. We're about 10 months underway into an ice condition index product that's really trying to leverage weather forecasts, lake ice conditions, and then vessel classifications on the Great Lakes regions to really help both U.S. Coast Guard District 9 at Cleveland, Ohio, as well as Great Lakes mariners to be more witting in dealing with their shipping decisions made for routes of steam in the Great Lakes region in the winter months. We're about 3 years underway in trying to leverage what local citizens are doing, or can see and do and help contribute to appropriate decision making at both the Sector Anchorage and also in District 17 on seeing something, saying something, and sending something, and what gets sent is actually useful to those folks standing the watch on those respective Coast Guard headquarters or Coast Guard operational entities. In this context here, we're seeking to try to figure out what does right look like for creating a community-based observer network that's really of service to provide it to the Coast Guard, and where citizen science can actually help, if you will, inform those folks charged with the Arctic operational missions. We're also trying to conclude a project, or getting a project underway, getting the last of the details pulled together for essentially conducting a satellite-derived bathymetry project on Arctic Alaska, but specifically looking at the near coastal areas and finding what does right look like based on Arctic shipping and really Alaska coastal shipping in those regions. We are actually now also underway preparing a request for proposal to elicit really solutions to address Coast Guard operational needs in Arctic information fusion. This is separate and distinct from our prior works effort in Arctic information fusion capability. And ultimately, we have this project, we have an RFP queued up and ready to go, just waiting the research questions coming in from Coast Guard. We're hopefully maybe as early as today, hoping to get a decision made by Headquarters Coast Guard in a separate basic ordering agreement project that coming to us, where we partner our colleagues at University of Alaska's Alaska Satellite Facility with Coast Guard Research and Development Center to really advance the ball in Arctic communications focused on those needs that help the Coast Guard, as the commandant mentioned yesterday. These are a couple of recently concluded projects. One, of course, in integrated ice hazards, where essentially we created algorithms that were focused on both shore and ship-based radars to really detect the movement of sea ice. This project is now concluded. We're seeking a commercial application with the shipping industry. We've also just concluded a low-cost sensor project for essentially secure detection. We're now getting ready to publish the results of this and potentially seek an alternative sponsorship for this work. We've just completed 3 years of work in developing courseware for mariners, both watch standers, first mates, and captains, to be compliant with the IMO Polar Code. The last project, which is really for first mates and captains, is both courseware and simulation materials to be actually used by the shipping industry and also the mariner academies. And right now we're getting ready to bundle that packaged work and send it to the Coast Guard Office of Navigation for certification. Some prior concluded work for us is both using chemical isotopes to detect oil and sea ice formation, and also smart camera research, and these are going into various respective trade journals in those communities over the course this next year is something we intend to get published. Workshops, of course, are the big deal for us. This is where the operators really tell us what matters to them, and again, at granular levels. We have essentially two forms. One, an Arctic Incident of National Significance workshop is a near-term venue. The other one is an Arctic medium and long-term environment workshop, is really a longer-term aspect. We've done one workshop on ions, if you call it in simple terms, that was focused on a cruise ship disaster in the Arctic regions. We're getting ready to do another one this coming fall. It's going to be an oil spill-focused event. And we're actually happy to announce this Arctic Ions in the fall oil spill event is actually going to be sequential heel-to-toe with the Office of Naval Research's International Collaborative Exchange for Polar Policy Research, or ICE paper. We're going to conduct this last full week in October in the University of Alaska Anchorage. Our Arctic medium long-term environment workshop is really, we just concluded one in May that was focused on Arctic in the 2030 timeframe. That was actually partner of the colleagues at U.S. Coast Guard Deputy Commandant for Operations Future Concepts, or the Evergreen team. One of the cool things about a university enterprise is the fact that we have students and a remarkable ability to tap into this invaluable resource. To no one's surprise, of course, these are folks that really can get some innovation to us, and we're leveraging these students while also helping prepare them to be part of the Homeland Security enterprise. So, in sum, this slide simply serves as a recap. Perhaps we can label as truth self-evident. In sum, where the challenges are focused in the Arctic, really where we can bring science technology to bear to reduce the risk for the Arctic operator and the missions that we just described makes sense. Smart investments in this area, but also smart partnerships. And ultimately for us in ADAC, letting the operational community drive the research agenda kind of makes sense, and we're honored to be a part of that. Ultimately, at the end of the day, we know we're one part of this overall research enterprise. The more we can connect with others out there that are doing like and similar work, the better chance we can have to reduce wasted effort and maximize the synergy of partnerships. So those are what I want to offer to you. I'll take whatever moments Pablo will give me. I can now take a breath and then see what questions you might have.
Actually, I'd like first to take care of an online question, and if there's a minute or so left, then we take a...
The free fire zone. You go ahead and give me what you got.
All right, let me see. Why do the stakeholders come into play during phase 3? They should be included beginning in phase 1. The components in phase 1 impact the people of the Arctic.
We're going to need the rest of the question here. You're missing something here. Which project are we talking about?
You ask.
What I can do is I'm going to take that for the record. If I can get, in the interest of time, the other questions I can answer quickly.
I have a question about your upcoming project regarding vessel tracking data.
Okay.
If I understand correctly, you're planning to base bathymetry charting needs based on where the vessels are going, right?
Right, where vessel traffic is high, so we're trying to essentially use some efficiency here because satellite-derived bathymetry is expensive. So we're trying to say where does it make most sense based on where the traffic is highest. And what through a community approach of where people are doing the shipping industry, asking them, okay, where are you going? We can leverage AIS data. You know, Ed Page is here, and he's a partner in this endeavor. So his AIS data gives us kind of a cue, but then also asking where others are at, making sure that we got the rational approach. And when we do SDB, it's oriented to where the needs are highest and potentially the risks are greatest.
I agree. What I would maybe suggest, though, is that considering that ships will not go where there is no adequate charting, maybe going beyond just tracking data and going to the stakeholders directly and see where would you go if there were some good charting. That would be a good way.
Question, a good reflection. And in this case here, I know adventure tourism is a big driver. And, you know, as a potential customer of adventure tourism, I want to go where it's really interesting and I can get the best photo, right? Well, sometimes the best photos where the risks are really, really dangerous and I get stuck on a rock. And being stuck on a rock when it's flat calm, no big deal. But that same rock sticking is a big deal when you get 30-foot seas come up out of nowhere with a 40-knot wind. So to us, knowing where they're interested in going certainly matters. Ultimately, in the day, we'll be driven by the decisions made by our project champion, headquarters Coast Guard, and saying, okay, this looks about right. We've got the input from the customer community. Then ultimately, they will help give us our left and right limits and working with them to make sure we got the right application to meet their needs. But that's a very good point.
Thank you, and we can stop here.
I've been given the hook.
Yeah.
Well, give me my glass wipe thing and I get off the stage.
Oh, you're
Because I use them.
It is a real honor to, for the second time, say welcome to Congressman Don Young to this symposium. Representative Young has served as Alaska's lone representative. He's the congressman for all of Alaska to the U.S. House since 1973. It's interesting to point out that he remains the only licensed mariner in Congress, and I'm particularly proud of Congressman Young because he recently visited Puerto Rico supporting the monitoring of voting that took place there, relating the issue of statehood. I also want to note and acknowledge the presence of Mrs. Young with the congressman. Thank you for being here. And I'll leave you all with Congressman Don Young.
Thank you, and I'm a little bit in awe. That was a great presentation. Let's give him another hand, all right? I'm excited about what he had to say for the state of Alaska and this nation. The University of Alaska is doing outstanding work. I'm a little disappointed in the state legislative body. They cut them by $8 million, and they shouldn't have done that at all. They'll hear about that later on. But it's crucially important to recognize, and I know all of you in this room do, unfortunately the major population of the United States is quite still unaware of the Arctic. And I don't know exactly how to get that message across anymore. I talk to the people on the floor of the House, and they look at me like I'm talking about a lot of different things that they don't understand. They know about polar bears because the Coca-Cola ad. I don't drink a Coke, by the way. They know about a lot of activity development try to do. They know about they say they shouldn't do it, but they don't know the potential for this world and this great nation of ours, the Arctic. And I've said, and you've heard me say it before, it is the future of our society and world society. If I was a dictator, I'd probably be shot, but if I was a dictator, I would create a new Arctic nation. Take all the countries that are above the Arctic Circle and create a new Arctic nation, because we are working together very well. We did in the past, even with during the Cold War, but we are doing it now through science, the universities' cooperation with one another, because we have an understanding better than any place in the United States and the rest of the world. And I say this because I'm a little concerned about the hostility that's created between the larger forms of government than the communities that are closer to really the action. If we could have a nation with just dedicated to peace and development of, and adapting to. This is something I've been frustrated with over a period of time, is the alarmist. The world's coming to an end. Oh, woe is us. We have to cease existing, period, now. We're not going to change anything very quickly, even if we were to stop living right now. I think we ought to think about adapting, recognizing what the potential is. And I will say I'm a little bit of a quasi-geologist by self-education, which is always dangerous. There's a tremendous amount above the Arctic Circle of all the resources humanity will need in the future. It's not in the south, it's in the north. The minerals we'll need to consume as population grows, the power, the fossil fuels which we will consume. Not necessarily in transportation. I think that may be on the downside, but it'll be in other products. If you look around this room and think about it, what was made from fossil fuel in this room? Just about everything you have. And we have to recognize that's one of the feeding components to the future generations. And we have to adapt, and how is it developed? And the one thing I'm excited is we lose this ice cap, so we're talking about it. And if we lose it as rapidly as we think we are, we're going to need any icebreakers. That sounds kind of strange, but I do support icebreakers. I did get enough authorization in the defense bill, because this is a defense issue also, national security, for 3 major icebreakers and 3 minimum icebreakers. We have 1 now, as everybody knows. Other nations, as you know, the numbers they're awesome. Building, Finland has always been very active, Russia's extremely active, and now China. So they know the future, and it's about resources. And we're still behind the 8 ball. We're also behind the 8 ball, and I do appreciate the previous presentation, because we are making some progress in mapping the seas. To not only worry about ice, but we really don't know what's under the water and under the ice. This is very exciting for me to get done as an old mariner. As they said, I am a mariner captain, but I only take and dealt with the rivers. You know, I'm trained for the oceans, but I hate the oceans. I don't like it when I can't see something. I like the big rivers. It's exciting for me. And nothing to do with the ocean other than the fact we are having new ships built, different ships around the world, but we still have a large fleet of very outdated, antiquated ships. They're potentially dangerous. And IMO knows that, but we have a lot of, I call them bandits, still carrying cargo. That's a potential danger to the Arctic as far as oil spills go, contamination. It is not the drilling for oil which is going to occur. It's going to be a shipping unknown charter, and I'm hoping we'll be able to identify the channels that are necessary. And we have a system put in place for traffic, just like air traffic, because that's what's going to protect the waters of the Arctic. We go into the fishing arena, which to me is another exciting aspect for Alaska because it's close to the shores of my great state. And as the water temperature changes, acidification might be occurring, is occurring. Are the fish going to be different? Are they going to move further north? Is the food capability in the north adequate to maintain fish? I think it's more than adequate. I think if you study the biology about the Arctic, it's tremendously loaded with plankton and cetras which keep fishes alive. So that means we have an industry that will be actually in competition from primarily China, Japan to some degree, and some other nations also. We have to be aware of that and implement the 200-mile limit, the Magnuson-Stevens Act, making sure it goes forth and carries on, because we always really thought about the Bering Sea as further north as it went. Now we're going to be much further, and that to me is a part that I look forward to. I probably won't see it. I'll be the first one to tell you that, but I will see it if I'm above or below. Remember, that below is non-charted area. Above is pretty good, but we don't know. But I just want everybody, I just wish I could get people to the vision of the Arctic, the resource capability, and the adaptation by man to the actions of ice loss. And again, it was mentioned by the presenter previous to me, the communication with the Alaskan Native people along the coastal areas. I am a little discouraged in a sense. I still have some of these people that know everything about the environment, and they keep saying it's going to affect the people of the Arctic. And yes, it will, but they have not communicated with the people of the Arctic, and do they support this research? Do they support the development of resources? Do they look to the future and not just the past? And if you'll talk to those people, the people of the Arctic, they'll say, we want the future. We want to be part of the adaptation to our future. We want to be involved. We don't want to be ignored, but we're not saying no. The no's of the Arctic and keep putting their heads in the sand are doing a disservice to the people of America and this great world of ours. We have to, as human beings, recognize the importance. Again, I keep stressing that. Congress, again, has a responsibility for the icebreakers. But we're not putting the money in the research that we should, because most of our money for research goes to the Antarctic, which really has very little other than research. The northern part of this globe, well, every Arctic nation is where the future lies. And I think the Congress should become more aware of that. I know it's a difficult time for everybody because of financial reasons, but if we're going to have that available to the human beings of this world, we have to do our research. Now, I don't know how much time I have or what time I can have. I will answer any questions. For those that haven't heard my background, I'm an individual that left California 63 years ago. Best thing I ever did. But anyway, I went north to I actually was raised on a ranch, I forgot to tell you that. And my father worked us very hard, and bless his heart, I love him for it. I didn't think so at the time because it was 110 degrees. And we moved, I hated the heat. I kept dreaming of the place where it was cold, no snakes, no poison oak. And I got drafted, and during my time in the military, came back and got my coaching degree out of college, coached for 1 year. It was still hot. So I went home and told my mother my father had passed away. I'm going to go to Alaska. And she says, what are you going to do in Alaska? Nothing but a bunch of savages up there. You'll get lost. I said, no, I'm going to go up and mine gold. And I am going to trap fur, and I'm going to drive dogs. And I did that. I went up there, the coldest part, and we have my good friend over from Fort Yukon also. The coldest part of the state of Alaska is the year I went up was 64 below zero for 60 straight days. Forget climate change, that time was really cold. I mean, there was no steaks, and there was no poison oak. And I was in heaven. And then along the line, I married a local lady, and she was my sweetheart, but she said, patted me on the head one day and said, I want you to run for office. And I said, I don't want to run for office. I got my tugboat in the summer. I'm trapping. I'm just having a ball. And she says, nope, the politicians come in, pat us on the head, give us a lollipop, and ask for our vote, and then we don't see them for 2 years. So I ran and lost. Okay. And I won't tell you the whole story of that, but time went by. I eventually got elected to Congress. I came to Washington, D.C., where it's hotter than hell today. And there's all kinds of snakes in Washington, D.C., but they got 2 legs. I like that 2-legged snake bit. And lots of poison ivy. So I went from heaven to purgatory, and but I'll serve my time, and I'll take care of it. But the Arctic is in my heart, the greatest state in the Union. And it's to me, if we don't spend some time and effort and money, research and development of and adapting to what's occurring, we've done ourselves a great disservice. So I want to thank all of you, and I'd answer any questions. My presentations are always short. You notice I don't read anything. It's all from right here. You got the heart for something, you can do most anything. Thank you. God bless.
Thank you, Congressman. I'm going to start with an online question that we already have in. How can we work together to avoid the big budget cuts proposed to essential Arctic research at NOAA and NASA?
And one thing, this is what I'm going to call a constitutional lecture. I've had 45 budgets presented to me in my lifetime, with 9 presidents. And I've never listened to a president yet. No disrespect. Our job under the Constitution is to write the budget, to raise the money and to spend the money. It is not the president's responsibility. He can present his platform or his philosophy. That's fine. I've listened to them all. What we have to do, and what on this issue, that Congress has to be made aware, and that's part of my job, of how important NOAA is. I have a little argument about nymphs once in a while, but about important NOAA, and it's about fisheries. They're studying trout instead of the ocean. That made me upset. But it's our job, and I think we're going to come out fairly well. Will we be able to expand? Probably not. You know, we're $20 trillion in debt. And the rate we're going right now, we will be $25 trillion in debt by the year 2025. If you look at what's happening. That's not good for the nation. It's not good for any of our programs. And it's primarily because we have not utilized what God has given us, and that's our resources in the United States of America. That's what creates real wealth. All this technology, everything is well and good, but it serves something or somebody and is created from the resources of this earth. Our job is to adapt to how do we develop them. What is the best benefit for the human race and for the globe as far as environmental issues go? But don't say no. The no's are hurting this country. Let's say, how do we do it? How do we work together? How do we achieve the solution to a problem? That should be our job. So, no, don't get too excited. I think you're going to be okay. All right.
Okay.
What else?
Well, this is a personal question. If Puerto Rico becomes the 51st state, would you and your wife consider relocating?
Yeah, my wife is all for it. I will tell you, I'm going to promote Puerto Rico. It should be a state. It's wrong what we've done. We can't solve their problem, and we should not be ignoring 3.5 million people. It is a great state to be in and to visit. Better water, great beaches, and fantastic fishing and friendly people. So instead of going somewhere else, go to Puerto Rico, all right? All right, what else
Thanks
we
for
got?
the plug. Any question for the congressman from the audience?
Thank you all, and I do...
Congressman, we do have one more, and I think you have a few minutes, couple of minutes.
Oh, it's up to you.
Then
you know,
please.
you get me in front of a mic, you got problems.
First of all, we want to thank you for joining us. I'm Marie Green, and I live in Kotzebue, Alaska. And one of the comments you made, Congressman, is the need to educate our Congress about the Arctic. What is it that we can be doing more to help with that? This is real critical, as you already stated, and we want to help in any way that we can to educate the Congress.
Yeah. One thing, you being from Kotzebue, you know one of my biggest challenges now because of the need for a good port in the Arctic, or ports. And you happen to have one of the better ones that we developed the road, which we've been promoting, the Blossom Road to Blossom Point. A very deep natural port. Of course, other communities want a port, but we have to look at the utilization of ships, etc. And you know what you can do for me, and especially from Kotzebue, and from Barrow, and from Kraftovik, and Point Hope, and Wainwright, all those communities, there are people that come down here and say they represent the Alaska Native people, and they do not. They're actually paid by interest groups to come down and make testimony saying it's their land. And I will listen, because I have to represent the whole state. But I will listen to those that live in close proximity to any development or any shipping or any other lane before I'll listen to somebody that's 400 miles away. Is that your responsibility? It's my responsibility at your herd. So I don't know how we're going to do it. If I would make a suggestion, we would get the NANA and the Arctic Slope to put on a program nationwide, half an hour, called something like I Live in the Arctic. And put on a program every week. It's so exciting, you get people to watch it. You ever watch the Alaskan programs on TV? Most of them are bullshit, pardon the French. But people watch them. I'm amazed. I got the Yukon men, which always tickles me. And I know most of the guys in that show. And oh, we're going to starve to death if we don't get our moose. I said, what do you mean? You can go right around the corner, there's a store. But people love watching it. And I call them up and say, why are you doing that? You know that's not true if they pay good. So that's what we need, a factual... I happen to have the privilege to go to Jacques Cousteau's family's movie of Jacques Cousteau the other day. He brought more information to the ocean, to the average public, than any other person I know of. And that's what we got to get people that walking the streets or watching that boob tube that say, okay, I want to watch I Live in the Arctic. And every day, you know, you can run one show, not make it dramatic. This is what it is. This is the wildlife is here. This is what we're trying to do, and this is why we should be doing this. Da 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 da. I just think it would work. Now it's going to take money. That's the sad part. Unless we can get one of these guys with deep pockets to pay for it, it's going to take money. Now there's probably enough money around to do that somewhere. But education of people through the media is crucially important nowadays because nobody reads anymore. One of the most discouraging things I have, I love to read. I read junk, I read good things, I read bad things. But I read. I hate the television and Nels Cage wrestling is on. You didn't catch that? You haven't watched that show? Shame on you. But we need the utilization of the TV tube, much as I dislike it, with an educational film. That's how I do it, you know. I'm about out of time, I believe. Yes,
you are.
Thank you. There goes statehood. I thank you all, and God bless you. Take care.
Thank you. Following that advice from the congressman, our next speaker is Professor Vladimir Pavlenko. He's the Vice President of the International Arctic Science Consortium, IASC, and Director of the Federal Arctic Research Center of Russian Academy of Sciences in Arkhangelsk, Russia. And he's going to speak to us on Arctic research in Russia. Professor?
First of all, I would like to thank U.S. Arctic Research Commission for invitation to participate in this symposium. It is a great honor for me. The beginning of Arctic research in Russia by the 14th century and was connected exclusively with the prospects of exploring of new territories and resources. In this connection, it was necessary to shape the direction, investigations, and infrastructure. The first explorers in our country is rightly recognized as a Pamor people, who lived on the territory of the modern Arkhangelsk region. Main government organizations which respond for Arctic research in Russia is Russian Academy of Sciences, Federal Service on Hydrometeorology and Environmental Monitoring, Ministry of Education and Science, Ministry of Healthcare, Ministry of Natural Resources and Environment, Federal Services of Fisheries. Each of these agencies has its own network of research organizations focused on the Arctic. However, the largest number of scientific organizations, No, it's okay. Oh, excuse me. I would not repeat my report. Thank you. No, it's okay. I put it in the computer. However, the largest number of scientific organizations and specialists connected with years of study fundamental and applied problems of the Arctic are concentrated in the Russian Academy of Sciences. Validity of this approach is determined by the nature of the solution of specific research and development tasks. This was especially evident after the unifications of Russian Academy of Sciences, Russian Academy Medical of Science, and Russian Academy Agriculture of Science. The richest the research tasks combined are unsolved, in particular for the Arctic, has risen sparely increased. Each of other government agencies has its own scientific programs of Arctic research. For example, Roshydromet solved in particular the problems of modernization of the network of observing stations in the Arctic coastal zone, Ministry of Natural Resources, mineral exploration, Ministry of Health expanding the network of modern hospitals on the base of the research organizations of the Russian Academy of Sciences in Arctic, Federal Agency for Fisheries, search and estimate of resources for industry, Ministry of Science and Education, Russia, formation of a research base in the Arctic universities, Ministry of Defense of the Russian Federation realize this tasks similar for those that we discussed yesterday, Chief of Naval Research, Admiral David Hachen. The joint efforts of the scientific organization of all agencies is a rule in the framework of the state research programs and projects. This include, for example, can be attribute of the federal scientific programs like World Ocean, Materials and Technology for the North and others. Main regional clusters, Russian Academy of Sciences, of the Arctic research in Russia is located in a different part of our country. You can see in a map and title of this scientific center. For example, Kola Scientific Center is located in the Murmansk region. Karelian Scientific Center located in the Karelia Republic. And Federal Scientific Center in Arkhangelsk region, of course, this is European part of our country. Komi Scientific Center is located in the Komi Republic. Tyumen Scientific Center is located in West Siberia. Krasnoyarsk Scientific Center is located in East Siberia. Yakutsk Scientific Center located in the Republic Sakha of Yakutia and East Siberia as well. And Northwest, Northeastern Scientific Center located is Magadan, it's Far East in our country, and Kamchatka Scientific Center is Far East in Far Eastern part of Russia as well, in Petropavlovsk-Kamchatsky. You can see that the center like around the Arctic. The regional scientific clusters of Russian Academy of Sciences in the Arctic research include more than 7,000 scientists and 43 research institutes. 21 standing center departments of basic and applied research, laboratories and tests sites, doctorate courses in over 40 disciplines, scientific journals and publication facilities, scientific archives and museums, United Information System and e-libraries, social infrastructure and a number of scientific stations, advanced network of international cooperation. Nikolai Laverov Federal Center for Integrated Arctic Research, Russian Academy of Sciences, is a new scientific organization, was established in April 2016 by special decision of Russian government. Objective foundation of the center to establish on the territory of the Arctic zone of the Russian Federation a research institution specialized in integrated specific support of balanced social economic development and improvement of life quality of population of the region of the Russian zone, of the Arctic zone Russian Federation. Today, Federal Scientific Center for Integrated Arctic Research includes 7 institutes and 2 separate scientific stations, which is located in Arctic zone. Main function our center to be integrated Arctic research in Russia. Direction, fundamental and applied research, Federal Scientific Center include problems of Northern Sea Route and coastal zone Russian Federation in Arctic, ecological impacts, climate change and biodiversity, balance between infrastructure and social development, biomedical issues, including indigenous people, ethno-social and cultural process, international cooperation in the Arctic and others. In one presentation, impossible to introduce scientific programs each from 43 institutes, and I combined them into groups of field of science. For example, problems of Arctic geology, geochemistry, geophysics, mineralogy, mining, petrology, geology, oil and gas deposits, health, physiology, processing of mineral raw materials is include in the scientific programs 7 scientific centers in Russia. Problems hydrology and hydrophysics of the Arctic and subarctic water system, marine science, include in the scientific programs 5th scientific center. Excuse me, I read not. Problems of ecology, ecosystem, and bioresources of the Arctic and subarctic regions and seas, industrial ecology, northern and Arctic forestry and agriculture, including scientific program on 7 center in Russian Academy of Sciences. Main areas of economy, infrastructure, industrial development in the Arctic and northern region include in program 6 scientific centers. Social and humanitarian issues of the northern development, human health in the Arctic include in the program, scientific program, and 7 scientific center, our Academy of Sciences. Financial and logistical support to the Arctic research at the Russian Academy of Sciences provide not only state budget and Russian Foundation for Basic Research, Russian Scientific Foundation, and other sources, Russian and international foundation, private funds, commercialization of intellectual property. In this connection, I would like to emphasize a program of basic research of Presidium of Russian Academy of Sciences, which call Basic Scientific Research for Benefit of Development of the Arctic Zone of the Russian Federation. Participate on a competitive basis around 100 institutes, including located in the Arctic Zone, Russian Federation. Thank you for your attention.
I think Vladimir gets the medal for timeliness. And I was so scared all along. Fantastic. We have a few questions for you, Vladimir.
Yes, please.
Okay. The amount of research in Russia is very impressive. What obstacle to closer cooperation between the U.S. and Russia on Arctic research can we overcome, and how? Any obstacles between closer cooperation?
You mean some of example of our cooperation? Examples?
What obstacles are there to closer cooperation between the U.S. and Russia on Arctic research, and if any, how can we overcome them, and how?
We have
okay, obstacle in Russian, it means difficulty. Difficulties.
We have not difficulties with the connection with our partners from other countries, including Arctic countries as well, in Arctic research. Maybe very interesting problems with the connection with white border in Arctic Ocean, which you discussed before. I would like remark that about maybe 5-7 years ago, Vice President Academy of Sciences, Akademik Laverov, create small scientific group, and I was involved from Academy of Science in this group, and we discuss about ideas which will be a base for create borders Arctic countries in the Arctic Ocean. And this model we create during 2-3 years maybe. We're creating models about reconstruction. Create modern Arctic zone, and we start from time 150 million years ago. And during the next several years, we have rather close contact with our colleagues from Arctic countries in framework different scientific conferences in different countries and discuss about methodology use this model for create borders our country in Arctic. And this is idea was is a base in our application to the Commission of United Nations.
Thank you. Any other questions?
It's not so difficult. It's just our view for connection, for collaboration.
Yeah, obstacles could be opportunities. So, any other questions for Professor Pavlenko? If not, thank you very much.
Thank you.
Okay, I think we're right on time for a lunch break. I'll see you all at 1:15. Thank you.
So,
2-minute warning. Just so you back, and we're going to start. Yeah, give to John.
I've got it set. So all you need to do is you click you go click to the right. So it says manual timer. Can you read that?
No, not right now.
Manual timer.
Okay.
And then you press enter and then start, and then it should go straight to red, and it would be red for 2 minutes, and then you repeat.
Okay, I appreciate it. Welcome back. Before we start, I know that we have been given glass wipes to the speakers, but I think somebody actually got excited and forgot his glasses. Anybody? So check with lost and found. This afternoon, we're going to start a very interesting session leading to the first panel on marine transportation. The first speaker is going to be Miss Elizabeth E. Pierce. She's the CEO of Quintillion, and she's going to be talking to us about a very, very exciting new project, Arctic broadband install along the North Slope. I think that's going to provide some incredible capabilities to Alaska and other regions in the Arctic. Elizabeth.
Forward, back, laser pointer. Time to display here. Next slide. If I have any questions, I'll be right there.
Thank you very much. Oh, thank you. Can everyone hear me okay? Great. Thank you for your time today. It's an honor to be here. I just point out one little thing. In my bio, I do not work for Alaska Communications. I have in the past, but I do not now. So just a little correction there. I'm going to move fairly quickly and leave time for questions at the end. I'm just going to hit the high points of the Quintillion project, where we are, what we're doing, and what that means for the Arctic. So I think most of you know that communications in the Arctic can be incredibly challenging. Most of it's satellite. There's some microwave, limited capacity, high latency, delays and disruptions largely due to environmental conditions, storms, solar flares. And the absence of fiber optic cable infrastructure leaves the communications systems exposed to all of these risks and challenges. Additionally, the costs, especially in Arctic Alaska, are incredibly high. What you would pay in sub $10 for in the lower 48, we pay over $1,000 for in Arctic Alaska. That impedes everything that we do and everything that your organizations try to do, whether it's research or security. It's all affected by the cost and the quality of the communication service. Nome is a major hub of marine activity every summer during the open water season. We know this. We spent a lot of time there last year, right, Denise? And there's many vessels in and out of that port and in and out of that area. And communications are challenging. Even with satellite and microwave at Nome, there's just a limited amount of capacity and it's expensive. One of our team members working in Nome was trying to download a simple Word document. It took 16 minutes to download a one-page Word document because the system was so congested at the height of the active season. We talked to a gentleman in Wainwright, Alaska, further up the coast where Shell had operated out of when they were exploring in the Chukchi. 36 hours to download a Microsoft application update. So these things are not conducive to some of the operations and some of the activities that need to happen in the Arctic. Homeland Security, Custom and Border Protection, our international proximity present challenges to all of these. Alaska has the largest, longest unprotected border in the country. Safety in an emergency response with the ever-increasing vessel activity is another major concern. There simply aren't the resources to respond effectively if there's an event. September 11, 2015, as the emergency responders in the community of Denbero, now Utqiagvik, were having their September 11th parade, a foreign cruise ship was sitting offshore and unloading passengers, foreign passengers, no border patrol, no emergency response capabilities. The front inflatable in this picture actually flipped and dumped those people into the water. It's all kind of snowy looking because it was snowing. We were having a blizzard. These are the real conditions in the Arctic, and we're not really prepared for what we have to deal with. Communications and quality, affordable communications are essential to this. What Quintillion is doing is advancing that. We have a multi-phase project planned, and we're just completing phase 1 of that project, which is around the coast of Arctic Alaska from Nome through to Prudhoe Bay and connects at Prudhoe Bay to a terrestrial system that we just completed construction of. We turned up service on the terrestrial system in April. Nome, Kotzebue, Point Hope, Wainwright, and Barrow, Utqiagvik, will all have high-speed broadband service on or before December 1 if our schedule holds. And right now we're on schedule. Weather permitting, it'll be before December 1. We're completing a 2-year construction project to install 1,800 kilometers of subsea fiber optic cable with landings into those 6 locations. That's phase 1. Phase 2, we plan to go out to Asia from Nome, and we're looking at additional landings into Alaska in concert with that, or separate from that, what we call phase 1A and phase 1B. And then in phase 3, we'll head into Arctic Canada through the lower Northwest Passage and through to Europe. And that will arguably take another long construction cycle. Constructing in the Arctic is challenging. This is just a closer up on phase 1. Everything in red is what we're completed construction on and getting ready to turn up commercial service. We've actually been operating the network in test mode since November. By the time we turn up service, we'll have a full year of operation in test mode, so we'll have proven the reliability and the resiliency of the system for this phase. We've been through a whole cycle of ice breakup and those associated risks in another full season of marine vessel operations. Our design and our construction had to take advantage of a very short open water window and, shorter as you move north, just a matter of weeks in the high Arctic in the Beaufort. We had 14 vessels operating last year, 4 separate marine installation operations installing the cable. We had to work very quickly. We had to work in parallel over multiple segments of the system to get it in that short build window. And arguably, 10 years ago, this couldn't have been done. It's actually that diminishing ice pack and the absence of multi-year ice that allowed this to happen. We built this system to be resilient. This has a 25-year design life, but these systems, easily we could get 40 years out of this system. So we built it with resiliency in mind. It's buried. Every landing has a deeply assessed risk profile, and the installation is designed to mitigate for those risks. We installed steel conduits from the shore using horizontal directional drilling technology so that the shore landings are 60 to 80 feet below the seafloor, protected in steel conduits to protect from human activity, shore erosion, any kind of implication to the security of the cable. Anywhere that there's any kind of exposure to risk, whether it's ice gouging, which was a very well-explored topic, and right through to any future shipping or fishing activities that could happen, oil and gas, mining off the coast of Nome. Frankly, the gold miners that operate in the seafloor off the coast of Nome scare me more than ice, right? Humans are unpredictable. We explored for every one of those risks. We planned for, designed, and built to mitigate for those risks. And what we have is a system that is very resilient, very hardened for the environment. Two of the vessels that were in Alaska last year were the Ile-de-Saint and the Ile-de-Bréhat. They are custom vessels designed for cable installation. They use special equipment, special technology for this installation. This is a picture of the Ile-de-Saint where they're deploying the plow, and this is the plow that created the trench to install the cable in the seafloor. In other locations, we used water jet technology. This year, they're back with a sister vessel called the Ile-de-Bats, and that vessel is inspecting the cable that we installed last year, ensuring that there's no issues with any of that installation, deepening the burial in some areas, installing mattressing. This is a mattress, which is just a network of concrete blocks over areas of equipment to protect it in the seafloor. So while building was very challenging and required a lot of planning and a lot of work in a very short window, the opportunities that this system brings are immense. It's not just education and healthcare to the communities that are really deprived. Talking to the hospital administrator in Barrow, they medevac about 300 times a year at about $100,000 per medevac. Not because they don't have state-of-the-art equipment, but because they don't have bandwidth to send the CT and X-ray images to be read. So they take the image, they put it on the gurney with the patient, and they fly the whole thing to Anchorage at $100,000 a pop. That really delays treatment, and that really adds to the cost of care. Half the time, they didn't need to. They could have treated locally, but they had no way of knowing. They had no way of validating the information. Education is challenged. Access to curriculum, especially post-secondary education. If you don't have a good high-speed internet connection at an affordable price, then education is just off limits. We have one study that says a family has to pay $300 a month in overage charges just for a high school student to complete their curriculum. The books and the materials all online. And their internet subscription with the data caps isn't enough for them to be able to just do that work without that additional cost. But of greater importance to this group is scientific research, communications, emergency response, coastal defense and protection. All of those things matter. Last year, there were nearly 300 vessels in the waters off the coast of Alaska. Who knows what they were all doing there? The Alaska Marine Exchange is a great system for tracking all those vessels, but we don't know what they were all doing. And we don't know what their interests are, and we don't we are certainly not prepared to respond if there's an emergency. We just don't have the communications or the resources. These things are all important because Alaska is a gateway to the Arctic. It is the U.S. gateway to the Arctic, and other countries are far more engaged and interested in what Alaska presents for their national interests. I've read Japan's Arctic policy. It's far more developed than ours, and they have a very aggressive agenda where Alaska and the Arctic is concerned. So underpinning all of these interests is the need for high-quality communications. And the great thing for all of you is Quintillion, a completely privately funded project, is delivering that with plans to deliver more. One other data point is we get a lot of inquiries about connecting to international cables, and we have parties from all over the world that have designs for the Arctic and Arctic connections. And our thought is that St. Lawrence Island, sitting there with that jewel right at the entrance of the Bering Straits, is an ideal location for a nice, secure international meet-me point for cable systems. And so as you hear about parties talking about wanting to interconnect with the U.S., our design is on developing St. Lawrence Island for that purpose. So happily for the city of Nome, things are getting better. Recently, the Nome City School District went through an RFP process to renew their services. They were paying $120,000 a month for 40 megabits per second of bandwidth. And they will now have service from a provider using Quintillion's network at $95,000 a month for 100 megabits per second. A long way from lower 48, comparable, but a vast improvement over what they had. And we'll keep moving the dial in that direction. As the volume on the system grows, as customers use more, the prices will get better. That's the dynamic of the demand. So that's the high points of my presentation. If anyone has any questions, I'll be happy to take them now.
Thank you, Elizabeth. I'm going to start with the online questions, get them out of the way. Do you know if Russia will be installing a similar broadband capability in their Arctic, or does one already exist?
So there are some fiber systems serving parts of Russia, but what is this, the Siberian region, the Kamchatka Peninsula region have been more challenged. I know that they've had a subsea project going on with plans to connect some of the Kamchatka Peninsula region. I'm not sure the status of that. We have been contacted by many parties on the other side of the Bering Straits that would like to connect, and that's where we think St. Lawrence Island might provide an interesting opportunity for that connection and still meet our national security interests, which do exist for these cable systems.
On the other side of the table, how do you keep resellers from setting prices too high?
We're pretty bold about communicating with the market where we are generically in pricing and when we're moving on pricing. And so we keep a lot of pressure on our resellers because we are a wholesale provider. We sell to the whole telecom industry. We don't provide the last mile services. There's enough of those in the market. What they all needed was backhaul. And so we put a lot of pressure on them through our communications and through competition. There is competition between the resellers for the most part. Where that doesn't exist, we have other mechanisms to address inflated pricing.
Thank you. Any questions from the audience? Larry?
It's a comment and a thank you that I want to present to you, because I believe that Quintillion has made the survey data from the cable routes available to NOAA.
Yes, we did that.
And that's a really great thing to do, and I just want to express our appreciation.
Our pleasure.
Any other questions from the audience? Microphone, please.
Last time I was on the Dalton Highway, they were installing a big cable network. Is that you guys?
That was us. Yeah, we've completed that section. But yeah, we connect now down the Dalton Highway. At Fairbanks, we connect to existing other cable systems and extend our service all the way to Seattle and Portland.
There's one more question online. Let me go with this one. It's kind of perhaps a bit philosophical in the sense that you may not be able to directly address it, but how can we use this privately funded project as an example to potentially increase public-private partnerships to increase rural broadband in other areas of America with little access?
Well, you know, that's a really interesting question. First of all, it takes a view of the market and the industry that is different than most of our traditional peers have. And, you know, I've debated quite often with colleagues in the industry about the view of the market. And we have to stop looking at rural markets the way we look at urban markets. They don't operate the same way. They don't have the same driving dynamics. And so the first step is stop trying to do it the way they do it in urban centers. It doesn't work. And that's why we'll never get there. Second is understand what investors need, want, pre-develop, make it easy for the investors to understand and step in. And in terms of public-private partnerships, we need to stop thinking that the only form of private-public partnership is grant money. You know, the government is a huge consumer of communication services, and they buy those services all over the world, and they need those services. And sometimes just being an anchor tenant customer is the simplest way to go. You're already spending the money. You can get better quality, more capacity for the same spend, yet the contracting rules make it difficult to go there. So we need to look at how can the government become an anchor tenant customer on these kinds of systems in a much simpler way that doesn't call for new money, but makes better use of money that's already being spent. And I will tell you, I have peers in the industry who won't want that to happen. But really, we have to keep moving forward.
Thank you. I know there was one more question here. Hopefully.
Hi, I'm from Canada. I was up in Inuvik a couple of weeks ago and saw the kind of farm of satellite download systems, and also they've just opened broadband from up to Inuvik. Mm-hmm. It made me think about NORAD and renewal of the North Warning System, and I'm wondering if your system will contribute to that in some way. That was my first question. Second question is...
We're really out of time. Is that your main question, or is your second question?
That was the main question. How flexible will you be?
We're very flexible. We work very closely with customers. Even though we may not provide the end services, we work very closely with end service customers. I know the NORAD system well. I worked on it for over a decade, both in Canada and Alaska, so I'm very familiar. And it's those kind of customers that we will definitely be looking to work with as we extend the system.
Thank you, Elizabeth. And feel free to ask Elizabeth off.
Thank you. Thank you.
Thank you. I'd like to call on Commander Kelly Taylor, Deputy Director, Task Force Climate Change at the Office of the Oceanographer of the Navy, to talk to us about the U.S. Navy Arctic Roadmap update. It's not the first time that she has addressed the symposium. She was the commander of the National Ice Center, and as such, she also has co-hosted this symposium. Kelly?
There you go. Forward and back there.
Thank you very much. I'm so pleased to be able to spend this time with you this afternoon, and want to thank the Arctic Research Commission and the National Ice Center for extending the invitation to the Oceanographer of the Navy, who is the actual director of Task Force Climate Change. Could not be with you today because he is actually in the midst of turning over with our incoming oceanographer. So the incoming oceanographer of the Navy is Rear Admiral John Ocon, and their change of office will be at the end of July, so in a couple months, or excuse me, a couple weeks. And I do want to say, as I was in attendance of the 6th symposium, it's really great to see everyone here again. You know, I'm so pleased that we have the support. There we go. So I'm going to take some time today and discuss the perspective on the Navy and the world's oceans, our strategic drivers, and how we are executing the Navy's Arctic Roadmap in the context of our national Arctic policies. Oh, yeah. Excellent. Okay, so why maritime? Why the Navy matters? What's so critical about understanding, anticipating, and being able to operate in the maritime environment? So if we look at the numbers, 70% of the world is water, 80% of the world lives within a few hundred miles of the ocean, 90% of the world's goods are shipped across the oceans, and 99% of the telecommunications occur within underwater cables. These numbers are telling, and they speak directly to how world prosperity and security depends on free use of the seas. As the U.S. Navy, we must remain agile, flexible, deployed around the world, and uniquely positioned to defend our nation's interests every day. Compound this with the unique and challenging environment that is the Arctic, and we have not only an opportunity, but a necessity to plan for assured access where we as a Navy can support and protect national interests in the region, either independently or in conjunction with other U.S. agencies and partner nations. So if we look at the oceans, only 5% of the ocean's volumes have been explored. 20% of the seabed has been mapped to modern standards. And in addition, it's changing. The Arctic is changing at the most rapid rate we've ever seen. Twice the rate of any other location on the planet. Regardless of the reason why, we as a Navy must be prepared to assess these changes we are seeing and evaluate the impacts on our operations. As I just mentioned, sea ice in the Arctic has been in steady decline, as all of you know, since the satellite record began. Many times it's talked about in terms of extent, but we heard also this morning that the volume has decreased. So the implications in these graphics show that we must anticipate the continued decline throughout the next 20 to 25 years and the changing accessibility of the Arctic. There are increased concerns not only for the U.S. Navy, but for other Arctic nations. Part of the Navy's Arctic Roadmap effort included a detailed mission analysis and an assessment of how ice coverage will change in the Arctic. This graphic is a depiction of the predicted ice cover of the Arctic in 5-year increments in the next 20 years, overlain with the sea lines of communication. As you can see, there is no anticipated reversal in sea ice decline. The Navy is not newcomers to the Arctic, as we have over 6 decades of experience operating in the Arctic with our submarine forces. But we recognize the changes that have been taking place in the Arctic and are planning accordingly. In taking the Northern Sea Route, for example, it is expected to have approximately 6 weeks of open water in 2025, compared to approximately 2 to 3 weeks now. The number of international vessels completing full transits of the Northern Sea Route remains low, but is increasing. Comparatively, the Suez Canal had about 16,000 annual transits during the same period. So we're not seeing a complete rush to the Arctic, but there's increased interest, and we only expect it to grow, especially as we've heard with respect to additional commercial interest. So the Navy will continue to reevaluate our preparedness as the region becomes more accessible. This slide depicts the phrase 4+1, and that's the framework with which the U.S. military uses to discuss Defense Department requirements and our national defense strategies. This framework guides not only prioritization of countries and groups, but also the kinds of capabilities and flexibilities the U.S. needs to prepare for challenges this century. So to tie this all together, strategic military drivers and the Navy drivers, we've discussed climate change, or the environmental change. We've discussed the other factor, Russian resurgence and buildup of forces, and also the commercial and recreational activity. The Navy recognizes the strategic importance of the Arctic region and the national security implications of an opening Arctic. This underscores why we're taking a deliberate, measured approach to the Arctic, as outlined in the Arctic Roadmap. So discuss a little bit about Arctic strategies. This slide depicts all of the different strategies that we are operating in the framework of. So the national strategy for the Arctic region, most recently updated in 2016, lays out 3 main lines of effort. You can see security, stewardship, and international cooperation. And these themes are pervasive throughout all of the other strategies. The Department of Defense's Arctic strategy, which was first published in 2013 and most recently updated in December of 2016, outlines 2 supporting objectives to the national strategy: ensuring security and supporting safety, promoting defense cooperation, and the second being prepared to respond to a wide range of challenges and contingencies. In the third column, the cooperative strategy for 21st century sea power is not specifically an Arctic strategy, but it informs naval force employment, describes a force that balances warfighting readiness with our nation's current and future fiscal challenges. The Arctic language found in the March 2015 strategy includes assessing Arctic access and presence needs, improving maritime domain awareness, and pursuing cooperation to enhance maritime safety and security of the region. It aligns direction for our nation's 3 sea services, that's the Navy, the Coast Guard, and the Marine Corps, and in a sense acts as the bridge from the Department of Defense strategy through the CNO's lines of effort. So you can see we have depicted here the CNO's design for maintaining maritime superiority. And within this campaign design lays out 4 lines of effort. They focus on warfighting, learning faster, strengthening our Navy teams, and building partnerships. As the CNO describes, this guidance frames the problem and a way forward while acknowledging that there is inherent and fundamental uncertainty in both the problem definition and the proposed solution. Accordingly, we will make our best initial assessment of the environment, formulate a way ahead, and move out. But as we move, we will continuously assess the environment to ensure that it responds in a way that is consistent with achieving our goals. The Navy's strategic objectives are laid out in the Navy's Arctic Roadmap, and as you can see, they align with all the other previous strategies. They address U.S. Arctic sovereignty, homeland defense, ensuring ready naval forces, and preserving freedom of the seas. So ultimately, the Navy's Arctic Roadmap is the actionable plan to execute the CNO's intent with regard to the Arctic and in line with our national Arctic strategies. So let's talk about the Navy's Task Force Climate Change. As background, in 2009, the CNO directed the Oceanographer of the Navy to establish and lead Task Force Climate Change, or TFCC, supported by all offices of the Chief of Naval Operations and the Office of Naval Research. The goal of TFCC is to develop a comprehensive approach to guide our future public, strategic, and policy discussions. The primary deliverable is a holistic, chronological roadmap for future Navy action that is synchronized with a science-based timeline, provides a framework for how the Navy discusses the Arctic, and includes a list of appropriate objectives tempered by fiscal realities. Thus, it is an enterprise-wide approach to support, coordinate, and communicate Navy action regarding the Arctic and climate change. The bullets below each of the CNO's lines of effort, which run down the left-hand side, are taken directly from our implementation plan from the roadmap. Thus, the intent of our Arctic Roadmap emphasizes targeted investment, long lead activities that position the Navy to meet future demands. We make informed, focused, and deliberate investments in Arctic capabilities based on combatant commander requirements, keeping pace with the opening of the Arctic Ocean. We will also focus on continued research, navigation, charting of the Arctic region, and communications connectivity. These efforts will provide us with a better understanding of the changes taking place in the Arctic and the operating environment. Our implementation plan lays out a measured approach to achieve strategic objectives and missions in the Arctic over the near, mid, and far term. Executing the implementation plan has been a team effort with our Coast Guard and international partners. You can see for the near term, which encompasses the present through 2020, the environmental conditions are on par with what we have witnessed in the past several years, the decline in sea ice, major waterways becoming increasingly open. Shipping remains light, though still in challenging conditions. During this time, the Navy will continue to operate as we have, primarily with subsurface and air assets. Focus on specifying requirements for operating in the Arctic, for which our Northern Command, or U.S. NORTHCOM, has the lead. We will build experience and expertise and update concepts of operations and tactics, techniques, and procedures. In the midterm, which encompasses 2020 to 2030, the sea ice within the Arctic expected to continue to melt, with not only the Bering Strait and the Northern Sea Route becoming increasingly open, but also greater accessibility of the transpolar route. During this time, Navy will focus on improving operational activities through increasingly complex exercises, training with regional partners, while working towards the ability to operate deliberately for sustained periods when needed. And missions may include search and rescue, defense support, civil authorities, and freedom of navigation. In the far term, 2030 and beyond, environmental conditions are expected to support even greater and more reliable maritime presence in the region. Looking ahead to these increased periods of ice-free conditions, the Navy will plan to develop capabilities to support combatant commander objectives. Talk a little bit about recent Arctic activities. This slide depicts some of the conditions associated with ICE Exercise 2016. ICE Exercise is a Chief of Naval Operations sponsored biennial submarine force ICE exercise, during which this camp, which is set on a piece of multi-year ice, actually had to be vacated at an accelerated speed due to the rapidly changing ice conditions. These conditions were also experienced in the previous ICE exercise in 2014. So it reinforces the data that the Arctic is changing and the Navy needs to adapt. As you have previously heard, Office of Naval Research is working to better enable the predictive capability that we can utilize to characterize the environment. This includes the recently discovered Beaufort Lens, a submerged layer of warm water from the Pacific that creates a sound channel that penetrates into the Arctic Ocean. Efforts are underway to characterize the sound speed within this layer and the implication of the acoustic properties of the water column, as it just amplifies the change that we've seen. Slide, please. Future Arctic activities, Navy will continue to participate in various exercises, gain experience operating in the Arctic, and continue to maintain an active Arctic research portfolio. As an example, the United States Department of Defense Arctic Care Innovation Readiness Training, or IRT program, in partnership with the Kodiak Area Native Association, is free medical, dental, optometry, and veterinary services program to the communities on Kodiak Island for a 2-week period that happened this past March. Services were tailored to the individual needs of each rural community, so it was a way to support the community and also gain experience. Other examples include Exercise Northern Edge, Exercise Cold Response, and ICE Exercise 2018, which is coming up next March, and will provide an opportunity for readiness evaluation of Arctic warfighting capability and multilateral engagement. All of these partnerships demonstrate our commitment to increasing Arctic knowledge, interoperability, and partnerships, and show that recent and future activities will be relevant throughout the far term of our implementation plan. This concludes my brief. Again, I'd like to thank you for the opportunity to be here on behalf of Rear Admiral Gallaudet and ask if there are any questions at this time.
Thank you, Kelly. Please wait for the phone, for the microphone. It's just a small phone.
Hi, Commander. Thanks for the brief. Question I have is part of the NDAA assigned Secretary of Defense to actually do a study as far as security required and to determine what the infrastructure is needed in the Arctic. There was supposed to be a report out, I think it was in June, but I know it was delayed. And I was just curious because there were other people that were supposed to be part of that group with defense. Who has the lead on that, or do you know?
So we have not been directly tasked with that yet, but if tasking would come down as part of Task Force Climate Change, and I mentioned across all operational Navy codes. N4 has responsibility for logistics and infrastructure, so we would work with their office in order to respond to that report or information.
You know, it basically came out, and I think a lot of people we've all been sort of chomping at the bit to try and support it, but there's been nothing defined as far as who has the lead from defense to do that study or to make that determination. So.
Thank you. There's an online question. So there was an update to the strategy and roadmap. You know, what's new? What changed?
So actually, the update is coming in fiscal year 2018. So Department of Defense updated their strategy this past December, and there was not really any change from the previous strategy in 2013. So stewardship, security, and cooperation were still the themes throughout the Department of Defense's strategy, and is translated throughout ours as well.
Thanks.
Mm-hmm.
Anyone else? If not, thank you again.
Thank you.
The next speaker is Admiral Niels Olsen. He's the defense attaché at the Embassy of Denmark here in Washington, D.C. He's going to be talking about Danish perspectives on ice-diminishing conditions in the Arctic.
Or this one. And you can do that one, whichever you like, sir.
Good. Well, thank you for the introduction. In fact, Pablo asked me to say that we are melting the Arctic because you use so much aircon in this room. So is it not a bit ironic, in fact, that we are talking about the Arctic and it is 90 plus degrees outside and I am standing here in my summer white? Or maybe it's not ironic. Maybe it is symbolic for what is happening. Although I really, really do not hope that we need to introduce summer white in Greenland. This is the Kingdom of Denmark, and I guess why I'm here and why I've been asked to give a Danish perspective. The fact is that the ice is shrinking. This winter did not grow ice, and as it says in the program, we have the lowest January extent in the 39-year satellite record. It might not be as dramatic as this forecast, but the ice is melting fast, more than 40% in 30 years, and it will be a dominant factor, and it will be a game changer. The northeastern sea routes and later also the northwest passage could open up for serious traffic. And in some of the more grim predictions holds true, maybe even a marine highway directly across the North Pole, as Kelly also just showed. This could reduce the sea voids between Rotterdam and Shanghai by 37%, maybe even over 40%. And one thing is certain, for every year, the competitive advantage of going north is increasing. And as Kelly also said, 90% of all trade goes by sea. I really like your 70, 80, 90, 99. That's a really good slide. I have to remember that. But imagine that if just some of this heads north, it will have serious implications. It could lead to a massive increase in traffic and a complete transformation of sea transportation. A new Silk Road. China has already made the Arctic a prime part of the One Road, One Belt. And let me present you with a very simple extrapolation, which is certainly not rocket science, just a very simple equation. When the ice cap decreases, human activity increases. It's my prediction, but I think it's quite good. We already have a lot of cruise ship activity in uncharted waters, and again, as we heard yesterday, less than 10% of the Arctic is chartered to modern standards, and some predict that the cruise ship activity is going to boom. And not all of them will be experienced. Many of them are, in fact, already taking risks and taking chances, unnecessary chances, and we also see that they don't all come as prepared as Crystal Serenity. We might see serious merchant traffic, potentially a lot going north, and eventually, maybe not in the short term, but eventually we will see more exploitation of fossil and mineral resources, while the Arctic may hold more than 20% of Earth's resources. And we will see economic development for better or worse. Is it really annoying when I flip the pages, or is it okay? Oh, you have to get used to it anyway. I'll flip them anyway. So how fast is this happening? I think I've tried to make a scale here. I think we have only seen the beginning, the tip of the iceberg, if you can say that. And one thing is certain. It will happen, and it is happening. It is documented by real life. And this might not, this trend might not be linear. This is not a problem of a distant future. It might be happening very quickly and, in fact, outpace our capabilities to cope. We risk falling even more behind the curve, so we better scale up. As Admiral Sukonft said yesterday, we need to catch up. Maybe I can also use another famous quote. If you fail to prepare, you prepare to fail. We need more surveillance, more presence, more survey capacity to ensure safe navigation, more search and rescue resources, and more emergency response resources. So our national responsibilities will increase, as will our common responsibilities. So what are we doing? What is Denmark doing? In general, we strive to increase our surveillance capabilities, also to include satellites, with the aim to improve domain awareness, and through cooperation come closer to a recognized maritime picture and a recognized air picture. In fact, already here in a month's time, in August, we will send up a Danish-built satellite named USARC, which means star in Greenlandic, and it will be a combination of optical and electronic measures. One will also cover AIS. We always have 4 Arctic patrol ships 24/7, 365 in Arctic waters, and during the most busy season we boost it to 5. They are able to negotiate 1 meter of solid ice, and they are shown here in the first 2 pictures up there. From 2018-19, we will increase our presence with the periodic deployment of one of our high-end frigates, shown to the right. Our Challenger patrol aircraft and our C-130s will deploy on an increasing basis. Furthermore, we have conducted combat aircraft proof of concept trials, and we will increase the range of our sledge patrols via short takeoff and landing air mobility. The Seahawk MH-60 Romeos are now operational and will greatly increase range and capabilities of our ship-borne helicopter resources compared to the Lynx. I've included a small map here where you can see where it almost doubles the range. And as you also might be able to see, it's a bit dark. We have also been operating our land-based Sea Kings from our ships to extend the coverage. Finally, we have set up an Arctic response force of military and civilian capacities, and this has now been validated and also used recently in real-life operations. But last but certainly not least, we need more cooperation. It is critical. It's not nice, but neat, and a prerequisite in addressing the challenges. Real problems need real solutions, and real solutions need real cooperation. That is my own. But I also fully support the slogan of the Finnish Arctic Council Chairmanship, common solutions to common problems. Let us make the Arctic an area of cooperation. In the words of the Commissioner of the Canadian Coast Guard, with a twist, the Arctic, the last place we destroy, or the first place we take care of together. A good special operations soldier can sleep anywhere, so can I, and so can a good sledge dog, as you can see. It's a bit blurred, but there are two sledge dogs there. They are sleeping in a STOL aircraft, and maybe also a couple of the audience, I don't know. But I still have a minute, I guess, of speaking time. That's good. May I be so bold to pose a question to the audience as well? Thank you, Pablo. Oh, well, that's good. No, but I have a question for them. I was once asked what keeps a Danish sailor awake at night in the Arctic, and what keeps us awake is a major cruise ship disaster. Or in fact, it should keep the passengers awake. Because if they really knew how few resources we have to respond, they would maybe not go there. And if an accident, or maybe when an accident happens, I think we can expect a lot of finger pointing, especially because the public tolerance for time and space is not present. The police car will be there in 5 minutes, but not up there. Are we good enough in telling them, our public, what they can expect? That we'll be at an accident in 2 days' time, and we'll be totally unable to save all if they have survived in the first place? I think it's a good question. So if you can answer that, that would be nice. But otherwise, I stand ready to take any of your questions.
So is there anybody that volunteers to answer that question? There's one volunteer here. Microphone.
Thanks, Admiral. I'm Mark Everett with the Coast Guard, and I live in Alaska. And I have found that the public is motivated primarily by two things, crisis and self-interest. And unless you can generate one or both of those, people will not pay attention to what's needed in the Arctic.
I guess you're right. And we have, as you see, we have 6 ships up there. It uses up a lot of our resources, but in fact it's nothing. The Arctic is so, the distances are so vast. Alone Greenland with surrounding waters is the size of Western Europe, and it would be the same as if there were 6 police cars patrolling Western Europe. It's not a very good coverage, so to say. So the resources are really, although it takes up a lot of money, they are not there. And I think we simply need to step up to the plate and do even more.
There are a couple of online questions.
Yeah, I'm ready. I think so.
Can you provide more details about how your civilian capabilities support your mission?
Well, I think the military and civilian capabilities have to operate really, really close together in the Arctic. We cannot do stuff alone, as the civilian capabilities cannot cope on their own, as countries cannot cope on their own, in fact. For example, in this Arctic Response Force, it is a combination of our military capabilities and civilian capabilities, for example, from our civilian emergency response. And we used it very recently, a month ago, when the tsunami hit one of the townships. So we flew them up and put them in operation immediately. So I think we have to work extremely close together because the challenges are simply so big up there.
Well, there's a special relationship between Denmark and Greenland, and there's an interesting question here. What Arctic maritime issues does Denmark, which is responsible for Greenland, have that are unique compared to other Arctic nations?
That's a good question. I don't think we have anything unique. In fact, I think we all share the same challenges. In fact, what is unique is maybe that we are such a small European country, but sort of maybe big Arctic state due to Greenland. So we don't have enormous amount of gold, I have to say. So that might be what is unique, that we are a fairly small country, but it's not. Therefore, I argue that we have to cooperate. We simply do have to cooperate in the Arctic. Nobody can do this alone.
Well, it would help if Greenland stopped producing icebergs, for a while.
Yeah, sorry about Titanic. It wasn't
unique.
our fault. So we've been sorry ever since.
There's a question up there.
Hi, thank you for your presentation. I was curious, as Greenland moves towards becoming an independent state, will Denmark continue to support them in a naval sense?
Yeah, as you know, Greenland now have self-rule. They have moved from basically nothing in the past to home rule, and then now self-rule. And there is also a push for independence. Of course, they know also themselves that there are only 55,000 inhabitants in 2 million square kilometers, and it's a bit maybe difficult to sustain. But there is a push for independence, and due to the very, very close and historic connection, we will of course continue to support Greenland if they want our support.
Thanks for the question, but I would stay away from political issues like that. Maybe not. There's an interesting comment. It's a comment, but you may respond if you feel so inclined. It goes as this. I think we have done a better job communicating the risks of going to Antarctica, as the Arctic is still very much a new frontier for tourism. So basically, people think more in terms of how risky it is to go and work in Antarctica and going to the Arctic. It's just, a walk in the park.
It's certainly not a walk in the park. We see we have really, really many cruise ships up there. It's not one or two. There are a lot. And Crystal Serenity was very, very well prepared. But not all of them are, and not all of them are experienced in navigating up there. And they sail quite naturally. They sail very, very close to the icebergs, go into fjords that are uncharted, and they take a lot of risk. And if there is a major disaster, the risk of survival is very, very slim. So it's not a walk in the park, I can assure. I've been sailing up there for some years, and it's not a walk in the park. It will take some years until maybe we wear this up there, then it might be, but it is still a very harsh environment.
Yeah, I think we all agree. Any more questions for the Admiral? Yeah, there's one more up there.
Thank you. Just to piggyback on the previous question, would you care to comment on the degree to which the Chinese are willing to cooperate and collaborate with the Danes and others so that we don't have incidents?
I think they are willing to cooperate. I don't think we have seen in the Arctic anybody not willing to cooperate, as that includes also Russia and China. We have an interest also in keeping the Arctic as a low tension area, and I think it works. We have seen sort of no problems with the Chinese, maybe apart from them having a bit more money than we have, and have also been trying to buy up stuff. In Greenland, there is the second largest deposit of rare earths outside China, and it could, of course, be nice, sort of, for them to have a monopoly. But we haven't sort of seen any sort of move from their side, not in a big way, at least, and we haven't seen any unwillingness to cooperate. Not that I am aware of.
Well, thank you, Niels. And later on, I'd like to ask you some questions about where you get your white shoes from. So, all right, I think we're right on time now, and I'd like to introduce the next speaker. Is Admiral Richard West. He's a retired U.S. Navy and former oceanographer and navigator of the Navy, in fact. He's going to speak to us about the National Academy's Polar Icebreaker Cost Assessment Study. Dick?
Doesn't work? Then why are you giving it to me? This one here is the forward. Yeah. Okay. All right. Thank you. First of all, I have to say it was a real honor to chair this committee. I also had a few of my pals say, "How the hell did you qualify to be chair of this distinguished group?" And there's really two reasons why I'm qualified. One is Secretary of State Seward and my hometown are the same in upstate New York. One qualification. The second one is I'm a loyal member of the Royal Realm of the Blue Nose. That's enough, correct? Last fall, Congress asked the Academy to take a look at the nation's requirement for icebreakers. The task list was very long. In fact, it was 2 pages long, and it's in the report, and I won't go through all that. But what it boiled down to is to focus on, it's a cost-based study, and focus on the acquisition strategy for the acquisition and operation of icebreakers for the United States. Our report's available. Here's a website, and nobody's to go to it to find a question for me. Because there's 147 pages in this document. Our report's only 20 pages, but we validate everything we say in there with the rest of the document. This is the very distinguished group, and Mark Hutchings, who is our study coordinator from the Academy, is here, and I have to give him a lot of credit for getting us through. This was a 6-month study. It was a very difficult study to do within 6 months, and thanks to Mark for guiding us through. He didn't know at the end that the review process over the last 4 or 5 weeks has been very extensive. But this is a very good crowd. We lost one gentleman last month, Dave Prokowski, who was nominated to head up TSA. So we left a very distinguished crowd to go to a much more distinguished crowd, we think, and we wish him well. The way we approached our study, because of the confined time, was the first 2 meetings were going to be gathering data. The first being who has an interest in the polar regions. Tell us what your interest is. And then the second meeting was going to be with shipbuilders and folks that are familiar with building ships. For some of you, I know Ruth was there. Martin Jeffries was part of it. We gathered data on the federal agencies and what their interests were in the polar regions. In our second meeting, we met with shipbuilders and architects, the folks that built the Sikuliak, et cetera, so to gain interest. But you can see from our committee makeup, we had a lot of expertise, a lot of years of building ships on our experience. On the third meeting, we actually went out to Seattle because all the ships were there. This is your fleet. Somebody said yesterday, this is not a fleet. It is your fleet. This is your post play. And there's 3 ships there. 2 of them work. 1 of them doesn't. One of them is a parts bin for the other one. The Polar Star had just gotten back from the Antarctic, so we had a chance to talk with the crew, have lunch, talk to the skipper, which to me, having driven ships all my life, was fascinating to talk with a skipper who's done this all his career, bumping into things where I was always trying to avoid them. So if you ever have a chance to have a beer and talk with him, it was a great experience. But anyways, every time it comes back, it has to go into dry dock. It's that old. It's 40 years old. It's got CP controlled pitch propellers, which are problematic for that ship. So every year it has to go back to get fixed up so it can go back the following year. So it's not going to last much longer. The Healy is a great ship in good shape. It's only 17 years old, probably through about half of its life, but it's not a big one. So you have basically 1.5 ships as your polar icebreaker. As a huge maritime nation, you've heard this, I'm not going to repeat it all, you've heard it the last day and a half. How the hell did we ever get ourselves in this position with all the opening up and the access to the polar region? So hopefully this will be the final report that the folks to be will need to get on with building icebreakers. I bring this up, one of our recommendations is when you bring the Polar Star back, because we're going to need, you have a gap. Even if you start building icebreakers tomorrow, it's 4 to 5 years before you get your first one. So this is what we've got for the next 4 to 5 years. And there's not much out in the market. We've had some problems trying to get international support for the Antarctic in the past. We were told to look at what's available out there to buy, lease, sell. There's none. So this is it. So one of our recommendations is an enhanced maintenance program for the Polar Star when she comes back. In addition to the corrective maintenance that she gets every year to go back, do a little preventive maintenance to keep her going for 5 to 7 years. Our major recommendation is buy 4. Buy 4 heavies, common design, for lots of reasons. And if you go into our report, it's in excruciating detail why we think that's the way to go. There was 2 reasons for 4. One is the acquisition strategy. One was the operational concept for our polar icebreakers. The Coast Guard is on record with 3 heavies and 3 mediums based on a high latitude study. We did all of our homework. We do think that this is the minimum amount that you do need for the operational requirement is 4 of the common design. Obviously, common design reduces your maintenance, operating costs, crewing, et cetera, sort of the Southwest 737 concept. So, and we've also found during the costing process, which you'll see in our document was pretty exhaustive, that the 4th big one would actually be cheaper than the first if you started a whole new design for a medium class. Now, there is a place out there where the curves cross that if you want to build 6 or more or something like that, and they want to be a different class, they may at some point be equal, but initially the first design of a new class would be much more expensive than a 4th or 5th ship of the large one. Our 4 was based on a continual presence in the Arctic, and I think after a day and a half, you'll know why. We want one up there. It's if you want a 1-0 presence, you need 3 ships. That's the Navy knows that, the Coast Guard knows that. So you need to rotate. So there's 3, and you need 1 for the Antarctic. That's 4. So we think that's the bare minimum that you need for the mission. Another thing we were told to look at is who should operate them. We looked at a lot of models, lease, buy, MSC model, all sorts of things. And the lease versus buy was done exhaustively, and you can look in our report on that. It's much cheaper for the government to own it, by 19% by our calculations. So that was up front. There's new regulations by OMB that if you do lease, you have to put money up front for them, and there's lots of reasons why buying was the best way to go. We looked at manning, et cetera. We want the Coast Guard mission. We want 9 of the 11 Coast Guard missions can be done by a polar icebreaker. We want that white ship with a red stripe up there in the Arctic. So that was another discussion we had. The block buy strategy, unless you're in the acquisition management, it's rare to do, but this is the perfect operation to do it when. They're all the same kind. They all do the same mission. There's a lot of technology and design out there available to do them, and this is the most cost-effective way to build these 4 ships. And we detail in great detail in the report how to do this. You got to use the international technology. We have not built an icebreaker in 40 years, but there are lots of them being built around the nation. Scandinavian countries have design. You can go get that design to help you. So we highly recommend that they do that. Commercial off the shelf, international standards, ABS, Polar Code, etc. And we recommend minimizing the mil-spec requirements for their vessels. This was a more emotional issue. It's the science capability, but it was one of the tasks we were asked to look at. Should the new polar icebreakers have a science research capability? And the answer that we came up with, if you're going to send a ship that goes in a place where no other ship can go, to a place where we don't know a hell of a lot about it, you got to have some science capability while you're there. And so we came up with a concept that you should be able to make a science-ready ship if you design in space and weight for that future capability in the original design. And so our guys went off and costed that. We were surprised that you could put the original design for what we call a science-ready vessel for about 10 to 20 million in addition. And this is in addition to roughly $900 million for an icebreaker. So that's what we recommend. And if you want to outfit it, and we did a lot of homework with the folks that did use Sikuliak and everybody else that outfits oceanographic ships. At one point, if you have this in the original design, you can go ahead and put your oceanographic over the side handling, your conics boxes, whatever, for about 10 to 20 more. That would be on top of it, but it's a significant reduction in cost rather than going back and retrofitting a ship later on. The other compromise, of course, is if you want to go to sea for science, you don't design an icebreaker, and vice versa. If you want to go do research, you don't design an icebreaker. So there's got to be some compromise, and that's something that's going to have to be dealt with. Did I do my 10 minutes? Where's Pablo? I want to make sure I got my gift. Okay. The other thing that there's a lot more to this than I had to go over, but these are the main points, and I encourage you, if you're interested in details, to go to our report. But the whole thing about infrastructure struck me. It's hard to put infrastructure up there, as we've heard. A large icebreaker there all the time is a lot of infrastructure with a lot of help that's there immediately. And once in a while we'll get a question of, why the hell are you building an icebreaker? The ice is going away. That's it's not this group, I guarantee you. But the answer to that is, that with everything that's going on up there, if you can guarantee me exactly when you'll need the capabilities of a heavy icebreaker painted white with a red stripe on it, then fine, maybe we can just go with 1 or 2 in certain times of year, but we can't do that. And with the Navy and all sorts of other, you can come up with scenarios where I may need that ship there right now, and we don't have that capability. So, happy to answer questions.
Well, good news is we have some time. Bad news, we have a lot of questions. So, see how you can handle them. I'm going to start with one that it's one of my favorites. So, probably anonymous is me, but I didn't even know I was asking this question. Why doesn't the U.S. give serious consideration to the constructing of, I guess, nuclear-powered icebreakers?
Cost, for one. Mostly that. Cost.
Okay, I'll take your word for that.
Does anybody want to argue with that? Okay.
All right. Is there any way to
That's why the Navy stopped. We used to have surface nukes, and they became, our carriers and obviously submariners, but surface ships are no longer.
There may be a fire sale in Russia, so. Is there any way to shorten the time from commission to use?
No. That's all laid out in the report too, and we're talking. I learned a lot about shipbuilding, by the way, with some real experts on our committee, and it's 4 years to build a ship. So even right now, the Coast Guard has got proposals, I think, for 5. We got Coast Guard in here. I think you're funding 5 contractors to come in with initial design and estimated costs. I think it's due next month. They're going to down select from that to a design. So you won't get a design out there for proposal till probably 19, probably early 19 or so. And so by the time they get back and you add 4 years conservatively to that, we're talking about 23 or 24 before you have your first ship. And so we've got a huge gap problem here. And so one of the things we were asked to look at is what happens if we have a problem, and then it's hard. It's going to be hard. There's not much out there. The Australians are building one that's going to be in commission here pretty soon, another year or so, and they're friendly, I think, still. I never know lately. The Canadians are building a different backer, but that's 3 or 4 or 5 years out too, I think. So the resources for icebreakers are pretty thin.
I'm going to continue with the online questions because they're quite interesting, and I believe a lot of coasties are out there furiously typing them. Having 4 new icebreakers is one thing, but what needs to be done? What needs to be done to properly staff and operate these vessels? I'm concerned about human capacity.
I guess I understand the question. One of the challenges when we talk to the crew out there, if there's only one ship, you kind of don't have a lot of diversity of crew, and there's not much of a career pattern and rotation and all that stuff, which is really hard, by the way. There's some frustration there, and we think with building a fleet, I think four bigs are a fleet that you can have some career rotation, some promotions of career and expertise. I'm not sure. The skipper of the Polar Star was telling us how he gained his expertise. He actually went to, I forget where it was. Mark, do you remember? Went off to Finland or someplace and operated with an icebreaker there for a while. Then was up on the Mackinac and in the Great Lakes. But there's no pipeline for this whole career pattern, and we think that's another missing piece here that can be well served with a fleet of 4 large icebreakers.
And a follow-up to that question, where would these, particularly the 3 Arctic icebreakers, be stationed? In the Arctic itself?
We had some long discussions. I'm not going to get cross-threaded with the Commodore where he puts his ships, because I understand there was a little bit of an issue about where they were on the West Coast. But no, in our report we talk about you can do dual crew manning. We've always tried that. The Navy still does it with some ships. There's some problems with that. You can home port the one down south. There's some real logistics and people problems with putting one down, say Australia or someplace like that. But there are options of doing that. But that's clearly up to the operational concept of how the Admiral would like to deploy his ships.
Yeah, and back to human capacity. Why not establish and support a civilian cadre of ice pilots to serve on U.S. Coast Guard icebreakers? They will have a lot of knowledge and experience as specialists.
I would say the skipper of the Polar Star, and I wish I could remember his name because I really enjoyed chatting with him. He's a nice pilot because he's done it all his life, but there's not very many of them. And as far as the Coast Guard, and here again, back to the career pattern, where you have a JO. I think one of the junior the OODs on the Polar Star, I think only one of them had ever punched ice before. And so that whole cadre comes back, and what happens to them for a year, and then, so there's really no career pattern. The Coast Guard should develop their own, and so, yeah, I don't know if that answers it, but.
I think so. One more online, and if there's another one here in the audience, we still could take it. I really like this one. Did the National Academies consider a dedicated science or hydrographic capable icebreaker that could be added to the NOAA fleet to advance NOAA's hydrographic and science mission in the Arctic?
We kind of did. Of the 4 ships, we're recommending that because of the timing, that 4th ship should be outfitted with the extra $20 million worth of gear, because that's when the Healy is going to come offline. And so that, as far as going to NOAA does not have any ice-hardened ships, as I know. By the way, there's a hell of a difference between ice-hardened and icebreakers. We found out there's things called ice pushers too. That just kind of push things out of the way. Icebreakers actually ride up and smush down on them. I didn't know that when I started this. So, but no, I doubt very much if NOAA's reinvesting or recapitalizing its fleet. I had a chance to co-chair with Bob Winokur here the recapitalization of the NOAA fleet here this last year. So no, there's none in NOAA that I know I mean, the Skuliak, as you heard from Ryan, yeah, is an ice capable. Yeah. And they're capable, so if they bump into something when they're in the region of ice, it's not going to punch.
As long as we can use the Coast Guard icebreakers, that'll be fine.
Well, there is a, and I'll bring up a sore issue with me personally as I went through this whole thing. There is I want to go research on that ship. No, I want to go a Coast Guard mission on the ship, and there's this sometimes a little bit of tension that you're trying to do both. I think you can get over that. I think you should. I think it's a people thing that can be solved. Like I said, an icebreaker is not the ideal research ship. If you want an ideal research ship, we have those. Skuliak, ORCRVs, etc. So,
all right. I think we do have a question here. I may not have much time. Let's see
one other quick we briefed the Coast Guard last week. We've briefed both the House and the Senate authorizers last week, and we're testifying in front of the House Committee, Transportation Committee next Tuesday. The Coast Guard has advertised that their icebreaker will be around $900 million over the last 2 or 3 years. Our detailed cost estimate comes up, it's pretty close, about $983 for the first one. And as your learning curve goes down, the last one's about $671. So the average for about all four would be about $760, somewhere in that area.
We have about 3 questions in 1 minute, so 3. I'm sorry.
Hi.
Yes, no, yes.
Denise Michaels, Nome, Alaska. I have a great place to park one of those once my deep draft port is built. Question in regards to self-rescue, what was the thought on just one for Antarctica? And then also looking out in the future at Alaska too may want to have ice-breaking service just like the Great Lakes do. We are part of the U.S., as a lot of folks don't remember. So.
Well,
thank you, but no more compound questions.
Well, I think the answer to both those questions is the same. It's an icebreaker presence there all the time. That's your SAR, that's your icebreaking capability, that's your emergency anything, it's your law enforcement, et cetera. So that's why, another reason why we think it should be a Coast Guard icebreaker.
Admiral, excellent question for you. It was the idea to build these vessels in 1 yard or to spread the industrial capacity to 2 yards?
It'll be a competitive bid handled by the Coast Guard. Like I said, they're going to get 5 estimates, I think, next month. They'll use the best of those to come up with a proposed, an RFP with that design. Anybody can compete. As you know, not every shipyard is going to be able to build. These are big ships with a lot of unique technologies, and the Coast Guard will pick, what yard it'll go to.
Very quickly, Brad. Very quickly. Microphone.
Wait for the microphone. Let's say you build 4 and they're 4 science capable. Have you had the conversation with NSF to support that science operation?
No, that's not our call. We stayed away from individual agencies' budgets. We're talking on behalf of the investment of public money into what we think is important for the nation. I don't care where the money comes from. If it's important, somebody will come up with it. So no, there was some issues about I don't want science capability, so I don't have to pay for it. Fine, but we think there ought to be a science capable on a.
Thank you very much. Thank you.
Did I qualify for my?
The next speaker is Mr. David Raboy. He's the Budget and Execution Manager at the U.S. Coast Guard Headquarters. He's going to talk on status and outlook of the U.S. Coast Guard Heavy Polar Icebreaking Program.
Back, laser pointer.
6 icebreakers instead of 4.
So thank you, Admiral West, for getting everyone excited about icebreakers. I see there's a lot of interest, so happy to be speaking here and hopefully answer some of those questions and tell you a little bit more about what the Coast Guard is actually doing to acquire these new assets. So the last 3 presentations have set up this one very well. In fact, they've probably said a lot of what I'm about to say, so hopefully I can say it in a little bit better way, a little bit more interesting way. But it also, you'll hear that assured access, presence. Right now, the Coast Guard is the office that supports that mission with surface assets. So when we're talking about Arctic access, the Coast Guard is the one that does that. We're looking to make sure that we have the right number and the right type of assets to be able to do that in the future. So I'll be talking some about the mission need, the status of our current fleet, which we already touched on just in the last presentation, but I'll talk about a little more, and then our progress, the progress on our effort to acquire new heavy polar icebreakers. So icebreakers are needed for all the reasons that you've been discussing in this symposium. With the reduction in sea ice and opening of the Arctic Ocean, the national interest in safe and responsible use of this region are expanding, and the Coast Guard intends to have a robust maritime presence. The U.S. is one of 8 Arctic nations, and the Coast Guard is the lead agency responsible for providing assured surface access through its polar icebreaking program. By providing assured Arctic access, polar icebreakers support national security, sovereignty, resource protection, and fulfillment of international commitments for emergency response. New heavy polar icebreakers will allow the Coast Guard to meet mission demands as Arctic activity rises. Just a few weeks ago, the Coast Guard medevaced a cruise ship passenger from the Crystal Serenity. I think the last couple of presentations have mentioned that ship. A 1,600 passenger cruise ship that transited the Northwest Passage last year from Alaska to New York, and is planning to do that again this year. Obviously, we want to be able to respond if something were to happen, and we want to make sure that we're prepared when this sort of activity increases. The Coast Guard operates icebreakers in the polar regions to conduct statutory missions that protect national interests. Coast Guard icebreakers are multi-mission platforms. Admiral West just mentioned we conduct 9 of the 11 statutory missions, including defense readiness, coastal security, in addition to ice operations. Icebreakers are critical for accomplishing Coast Guard missions in the polar regions. We don't break ice just to break ice. We break ice to access regions other ships can't in order to conduct our statutory missions. And that's something that some people don't fully understand. We don't just want to go up there, find ice to break it. We go up there because we want to be able to perform the missions of the Coast Guard and support missions for the nation in regions that other ships cannot access. So we currently only have 2 polar icebreakers that are active. Polar Star is our only active heavy polar icebreaker, and Healy is our medium polar icebreaker. Polar Sea, which is Star's sister ship, is not currently operational. She's been in inactive status since 2010 when she suffered a catastrophic engine failure. The Coast Guard is working to recapitalize and strengthen our icebreaker fleet. We're looking to acquire a total of 3 heavy and 3 medium polar icebreakers for year-round assured Arctic access and to meet national strategic objectives in the polar regions. Our first priority is heavy polar icebreakers, and we are currently in the process of acquiring new assets. So a little bit about these 2 vessels. Our newest polar icebreaker was commissioned in 2000. That's our newest icebreaker. She weighs 16,600 tons, has a diesel-electric drive capable of 30,000 horsepower, which allows her to break 4.5 feet of ice at 3 knots and up to 9 feet backing and ramming. Healy will be conducting 4 operational science missions well north of the Arctic Circle on her upcoming patrol. The first mission will be in support of the Coast Guard Research and Development Center, where they will conduct Coast Guard operational exercises. The second mission, in support of the National Oceanic and Atmospheric Administration, will include water and bottom sampling. And the last 2 missions will be in support of the Office of Naval Research, retrieving subsurface mooring deployed by both the Healy and Sikuliak last year. The Polar Star, as I mentioned, is our only operational heavy polar icebreaker. She was commissioned in 1976. In 2013, the Polar Star was returned to the fleet following a multi-year reactivation. She weighs 13,000 tons with a combined diesel, electric, and gas turbine propulsion, producing 75,000 horsepower which allows her to break 6 feet of ice at 3 knots, and up to 21 feet of ice backing ramming, so 2 stories of ice. The Polar Star conducts Operation Deep Freeze, breaking out a channel so that resupply ships can reach McMurdo Station, the United States Antarctic Research Center. This is an operation the Coast Guard has been supporting since the 1950s. This past year, that mission required clearing a channel through a nearly 70-mile ice field to reach the base. Polar Star is currently undergoing an annual dry dock maintenance period in order to be ready for the upcoming Operation Deep Freeze. She's proven to be a very capable ship, but I think many of you will agree that it's time to recapitalize our fleet with modern heavy polar icebreakers. So a little bit about the acquisition program. So in 2013, at the same time that we completed reactivation of Polar Star, we also stood up a program office to acquire new heavy polar icebreakers. In 2016, we took a hard look at our acquisition schedule and were able to move up the planned delivery of the lead heavy polar icebreaker. Later that same year, the Coast Guard and Navy committed to establishing an integrated program office to take advantage of the expertise in both organizations. Through a great collaborative partnership with the Navy, the Integrated Program Office awarded 5 industry study contracts in February of this year to identify approaches to further reduce acquisition cost and production timelines. Those are the 5 contracts that Admiral West was referring to. In these contracts, our industry partners are conducting iterative design studies, including looking at technical aspects such as hull form, propulsion, and electric configuration, and cost and schedule estimates for the design and production of heavy polar icebreakers. These studies support our goals of ensuring affordability, managing producibility and technology risk, and maximizing reliability, maintainability, and supportability of these new assets. We will use the inputs from these design studies and analyses to refine the heavy polar icebreaker system specification. We have already made great progress. We are leveraging existing designs and mature technology to mitigate cost and schedule risk and ensure timely replacement of our one operational heavy polar icebreaker. The heavy polar icebreaker requirements were developed by a 46-member, 11-agency integrated product team, including representatives from NOAA, NSF, the Navy, and others. These are what we consider the most important characteristics for the new heavy polar icebreaker. Cutter must be able to break at least 6 feet of ice at 3 knots, must be able to remain underway for at least 80 days without replenishment, and it must be able to operate and communicate with our federal partners. The new heavy polar icebreaker will also have a helicopter hangar capable of storing 2 H-60 helicopters or similarly sized assets, and it will have survey capabilities and multi-mission spaces that can accommodate science. One of the challenges for the heavy polar icebreaker is that it's expected to operate worldwide and therefore will be exposed to extreme environmental conditions found in the tropical, temperate, and polar regions. Not only does this pose challenges regarding the temperature, but the hull form must be able to blend ice-breaking characteristics with stable open water performance so that it can not only break ice, but transit in open water to reach the polar regions. And this is something that industry has made a lot of progress on since the 1970s. So ice-breaking technology has changed substantially, most notably regarding hull form and propulsion, since the Polar class was built over 40 years ago. On the left is a picture of the Polar Star with 3 propellers and a single rudder. On the right here is a picture of the Mackinac. This is our Great Lakes icebreaker. And it has azimuth thrusters, as you can see here, which are common among modern icebreakers. Our industry study teams are currently looking at a variety of propulsion configuration and hull forms. A modern hull form will likely require less power and therefore less fuel to achieve the level of icebreaking that we desire compared to our current asset, the Polar Star. Through an international collaboration with Canada, we're currently conducting model-scale ice testing to help validate some of these assumptions. This is the current schedule for the Heavy Polar Icebreaker program. So we're currently working on those five industry study partners who have contracts for industry studies to examine cost, schedule, and performance trade-offs. This information will inform the government and help ensure affordability. We're also continuing to work through a series of affordability trade-off analyses through a joint Navy Coast Guard process to analyze the requirements and identify efficiencies which have already led to cost reductions. Following this period, there will be a separate competition for detailed design and construction of heavy polar icebreakers, which will be awarded to one U.S. shipbuilder. And I just want to clarify that these are separate contracts. The information that we're getting from industry studies is to help inform the government. The detailed design and construction contract will be a separate request for proposal for that design and construction of the vessels. We're currently planning to award that detailed design and construction contract in 2019, with the lead ship being delivered in 2023. We've made a lot of progress in a short time. We've already achieved significant savings and moved up the schedule by multiple years. Polar icebreakers are critical national assets that will help us meet mission demands in the polar regions. And we're working hard to make sure we acquire them in an efficient, affordable manner. Thank you, and I welcome your questions. I also want to mention
that previous slide was a very nice one.
Thanks. I also want to mention that my colleague here, Captain Mary Ellen Durley, she just came back to DC from a tour as the executive officer on Polar Star. So if there's certain operational questions, she's here to answer those too.
Thank you again for that. Any questions from the audience?
You're saying here 3 heavies and 3 mediums, but the previous speaker was saying 4 heavies. So, I mean, this is very new. I mean, where are things at right now?
So 3 heavy and 3 medium is what the Coast Guard's been working towards. It's what our latest study called for. The NSF, I think you're referring to the NAS study as being the new study. So obviously we're taking a look at that. We continually relook at our needs, and that'll be one more data point for us to consider as we move forward.
In the course of the many years in the construction and the number of icebreakers, has the Congressional Delegation for the Great Lakes come forth, or are these ships completely inappropriate for the Great Lakes breaking ice? I'm saying that, I'm thinking, why wouldn't the Great Lakes congressman say, well, if you're making 4 of those icebreakers, make 1 more for us?
So the program that we're talking about is specifically for the polar icebreakers. One of the, I guess probably the main problem is that these ships probably would not fit in the locks to get to the Great Lakes. So they're fundamentally different ships with different capabilities, different operational profiles. So we're not talking about Great Lakes icebreakers, at least as part of my presentation.
There's an online question. Has there been any cost estimates done to replace the engine on Polar Sea to help cover the gap until the new HPIBs become operational?
So we took a look at that. Congress asked us to take a look at that, and we found that it was cost prohibitive to bring back the Polar Sea. It's not just a problem of cost. It's a lot of these parts don't exist anymore, and a lot of the parts that do exist we're using to keep Polar Star going. So we could almost, not quite, but almost buy a new icebreaker for the cost of bringing back Polar Sea, a 40-year hull. So the Coast Guard had found it, through that study, found it not to be cost effective.
Any other questions? Again, you're lucky that we have time.
So what about propulsion on the heavies? Has anyone been so bold as to say go nuclear?
So for the same reason as Admiral West mentioned, nuclear is not considered a viable option for us at this time. It's too expensive. Not only is it too expensive, but the Coast Guard does not operate nuclear ships at all. and so wouldn't have the capability to even maintain those ships.
There's money expensive and there's politically expensive, so in many ways. Any other questions from the audience? If not, thank you very much.
Thank you.
Oh, I forgot you do have glasses, so. We have plenty of time to introduce the next speaker. I may even feel like reading his bio, but I won't. Okay. Next speaker is Mr. David Miller. He's the Vice President of FUGRO Incorporated, and he's going to talk on Arctic information infrastructure, what's new, what's next.
Okay. Thank you very much. It's indeed a pleasure to be invited to be here and speak to you today. I appreciate the opportunity to share some ideas that are coming from the private sector, and I'll be focusing primarily on hydrography and bathymetry in my presentation today. Some of what you'll see is a bit redundant, so I apologize in advance. The good news, I guess, is that I'm not at the end of the day tomorrow, in which case I would have no material left to show. I'm going to challenge you today to think about infrastructure to actually include data and information. So beyond the ships, the icebreakers, beyond the telecommunication and submarine cables, beyond the deep water ports and harbors, think of those infrastructure projects as also including data and information that are required in support of those infrastructure implementations, as well as the information and data required for us to make informed policy and management decisions. So you've heard this already multiple times. The Arctic Ocean, like all of the world's oceans, is inadequately mapped. The Arctic Ocean comprises of almost 16,000 square kilometers of water, of which only 6 to 7% of those waters are mapped to modern survey methods. And looking at the U.S. Arctic waters, there it's only 2.5% where it's been adequately mapped to modern survey standards. Senator Michalski yesterday, I think, mentioned that's up to 4% now, but still we have a little work to do. These data are used to support maritime safety, inform ocean policy, guide sustainable use, improve ocean and coastal models, weather models, and identify future research, exploration, and development objectives. Looking specifically at the Arctic Ocean and the bathymetric or hydrographic data that exists, Larry showed some vessel track lines earlier today. This is from JEBCO. It's all of the data holdings in the Arctic, and you can see various ships that have been acquiring data, some single beam acoustic data, some multi-beam acoustic data, and clearly there is coverage. However, if you were to zoom in, you can see that they're largely single line data and by no means full bottom coverage, and as a result we do have these significant gaps in data, and as a result the low percentages of mapping that we have heard. Another slide that has been shown already is the opening of the Arctic shipping routes, and you can see on the left there that the traditional or historic shipping has occurred on the north slope of Russia through the Arctic waters. However, with the changing ice pack and opening of the waters in the Arctic Ocean, it is anticipated that in 25 years that a substantial portion of this shipping will occur through the Canadian archipelago and through the north slope of Alaska. You may have heard that we've mapped Mars better than we've mapped our own oceans, and in fact that is very true and sadly true. If we look at the world's oceans, most of what you see in the maps and the charts have been derived from satellite altimeter data. So it's remotely sensed data that is of very low resolution, 5-kilometer resolution, which means you have one sounding every 5 kilometers. So that's best case scenario. In many cases, it's 10 kilometers or 15-kilometer resolution. What's even more disturbing is that the absolute depth of that sounding could be an error by plus or minus a kilometer. That's true in deep water, obviously, but in deep water there can be errors on the order of plus or minus a kilometer in the bathymetry data that exists globally. Comparing to Mars, that data has been acquired from stereo cameras, a 20-meter horizontal resolution, so you only have to go 20 meters before you get another elevation. And the vertical accuracy there is plus or minus 13 meters. So dramatically different. And the reason, of course, is that it's impossible to map the ocean floor using radio and other electromagnetic waves. So this is just the physics. It's a challenging problem, and here we are. We have not much accomplished and a lot to do. Fugro was involved with the search for Malaysia Airlines MH370 in the southern Indian Ocean, and I think this graphic kind of conveys the problem that we have, or the challenge that we have. The left is the existing bathymetry that has been derived from satellite altimeter data. And you can see some features there, but they are muted, not particularly resolute. And that was a real problem and challenge when it came to this search. It was actually impossible to commence a search for the airline and the aircraft prior to first doing a reconnaissance survey to understand what was the absolute depths and what was the topography of the seafloor to actually facilitate a high-resolution search of the seafloor. So that occurred over several months, and in the bottom right there is a graphic of the same area, and you can see just dramatically how different the resolution is. You can see features on the seafloor that you couldn't see before, and identify features, and in shallow water, of course, similar, you could identify hazards and obstructions. The good news is that there is a global push to map the world's oceans. This has precipitated quite recently. There is a JEBCO Nippon Foundation program called Seabed 2030 that was precipitated in June of 2016, but recently announced at the UN Ocean Conference in New York in June 2017. And the goal of Seabed 2030 is to map the entirety of the world's oceans to a 100-meter resolution by the year 2030. And that's a pretty bold endeavor, of course, and it will require tremendous resources and tremendous coordination and collaboration between scientific community, governments, NGOs, and private industry. Since the precipitation of this idea last June, Fugro has been involved with doing what it can in terms of at least getting the ball rolling. Fugro operates 50 vessels globally to support our engineering and survey activities, and we have started to collect multi-beam data, which is a sonar-based system on board our ships, and we've been collecting data as we move our ships from project to project and from continent to continent with the goal to make this data available to the source. The challenge that we have on many of our projects is that we are working for customers who own the data, and it's their data and it's proprietary. So we have massive data holdings already, but most of those data belong to customers who own the data and will not allow us to share it. So we have also initiated dialogue with those customers and trying to communicate the importance of Seabed 2030 to those customers and explore their level of interest in releasing data that could be at a decimated level, so a lower resolution than it was acquired, or maybe temporarily delayed, such that the proprietary nature of the data and the sensitivity of the data might be minimized. So those discussions are in the works, and it's hoped, I think, one of the goals and objectives of Seabed 2030 is to firstly identify where does data exist. It's not just within private industry, of course, there's a lot of governments and navies that hold data that aren't necessarily sharing them yet also. So step one, to find and to try to then extract that data, and then fill the gaps with new mapping. The new mapping itself, of course, is not trivial for the reasons I mentioned already, and that leads me to the Shell Ocean Discovery X Prize, which is another global initiative. X Prize, if you're not aware, is a nonprofit organization that manages and runs competitions that spur innovation and technology development, really for the benefit of mankind and humankind. Very interesting organization. They have financial support from Shell on this project, and the goal is to try to develop new game-changing technology to more cost-effectively survey the oceans autonomously and in very deep water as well. So I think we'll see some very interesting technology coming from this program. Fugro is involved as a partner with X Prize as well. We're providing the ground truth data to test all of the 20 teams that will be competing for the prize. There are regional strategies already in place for closing the data gap, and within the U.S. government at least, the mantra "map once, use many times" has been heard for the past decade and has been highly effective. Bathymetric data has numerous purposes beyond providing accurate depth measurements, and these examples include marine habitat characterization, inundation modeling, environmental baseline mapping, and resource evaluation and cataloging. There's also increased interagency collaboration. Very significantly, we see much greater collaboration and cooperation between federal agencies. By sharing the existing data sets, new acquisition priorities, and available funding, government agencies can better serve the public by meeting tomorrow's data needs with today's dollars. And I can say this program is even expanded to include private sector participation as well. So we are involved in terms of communicating some of our larger projects and extents of our projects to government, and making it, in many cases, even making introductions between government and our clients, such that hopefully that data could be extracted and brought into the U.S. government holdings and ultimately into the public domain. And the quintillion cable system that was referenced earlier by Elizabeth is an example. Fugro did the survey for that project, and we made the introduction between NOAA and quintillion, and the data has now been transferred to NOAA. Private sector partnerships. The private sector has a proven track record of teaming with academic and government partners to deliver technology innovations in acquisition, processing, and deliverables. I have three partnership examples here that might be relevant and of interest. The first there on the left is seabed sea punting. Here we are actually utilizing some technology that was developed by NOAA at the University of New Hampshire. It's multi-beam backscatter, and this technology is being used by the oil and gas companies in frontier exploration areas. And we're using multi-beam data, both the bathymetry as well as the water column and the backscatter data from these surveys to find areas of high probable gas reserves through the detection of seabed seeps. And these activities in a very depressed oil and gas market are rapidly growing. Despite the severe challenges that are faced in the oil and gas markets, we're conducting on the order of in excess of 1 million square kilometers of mapping a year in support of these seabed seeps. Another example is this project NOAA Penobscot Bay. We're working with NOAA for a hydrographic survey in Penobscot Bay. It's a very busy area with a lot of small fishing vessels and recreational boaters, but it's also riddled with literally thousands of islands and shoals. Very dangerous, and we're implementing an integrated approach that utilizes satellite-derived bathymetry, laser bathymetry, and multi-beam bathymetry to create a more effective and efficient and cost-effective approach to mapping this very challenging environment. And it's interesting that this methodology was actually pioneered and proven by Fugro in the Arctic first, and is now being used in other complex and challenging environments. Lastly, I'll speak here on an example with the Arctic Domain Awareness Center. Again, presentation this morning referenced this study. It's a satellite-derived bathymetry study. We're involved with working with ADAC to, or will soon be involved with working with ADAC to try to identify where in Alaska satellite-derived bathymetry may in fact be feasible, and test the feasibility of using this, this technology for mapping the coastal areas of Alaska. So just, I guess, to reiterate some points that have been made relative to Alaska, coastal communities are clearly facing some changing ocean and weather conditions, making the need for accurate coastal mapping data increasingly urgent. Additionally, a significant portion of Alaska's economy is driven by the maritime transportation and marine resources, which also need accurate and updated coastal mapping data. Though the rest of the nation is served by the National Coastal Mapping Program, Alaska is not. So the lower 48 actually has a program to map the entire coastal waters on a regular interval. Alaska at the moment is not part of that program, and as a result there's really no coastal mapping that exists at a regional level in Alaska. And then lastly, I'll comment here, the Digital Coast Act was introduced in January of this year, co-sponsored by Senators Murkowski and Sullivan, and it seeks to fill these data gaps. The benefits of a well-mapped Arctic, again, probably reasonably well known to this audience, but firstly, safe navigation, provides domain awareness, first responders, Arctic shipping lanes, and insurance rates, driving insurance rates down for these vessels operating in the Arctic. Resource development, mineral leasing, exploration, development, as well as fishing, commercial sport fishing and subsistence fishing. Efficient infrastructure siting, fiber optic cables, pipelines, power cables, ports and harbors, all obviously require bathymetric data infrastructure. And then lastly, rate of change monitoring for coastal erosion, coastal protection, marine science and research purposes. So that's my last slide. If there's time for questions, I'm happy to take some questions.
Thanks, David. There's plenty of time for questions. With respect to you, I have a question for the previous speaker.
Okay.
And he doesn't have to answer it right away because it's your time, but I'll put it out there. And the question is, how come Russia can afford nuclear icebreakers? So let's open it up to questions from the audience.
Why is Alaska not part of the mapping program?
This is a Corps of Engineers National Coastal Mapping Program, and the primary purpose of it, from the origins of the program, were related to, I guess, beach replenishment and shoreline monitoring. So the Corps has a program which is involved with finding sand sources and replenishing beaches. And obviously most of the beaches and most of the tourism that drives that program is in the lower 48. And unfortunately, as a result of that, that's where the program has been focused to date. But it is a concern, and as a result, Alaska is not getting the coastal mapping that the rest of the nation is receiving.
Thanks. Online again, can phase 2 and phase 3 of the Quintillion effort contribute to the need to provide additional mapping for some of the oceans? I guess Elizabeth or you could address that, but.
Yeah, so the question was, will phase 2 and phase 3 also?
Yeah, by default will contribute as well in the collection.
Yeah, so there's literally probably a dozen surveys that are occurring at any one time for these transoceanic cable routes. And they were participants in the Seabed 2030 program, and they are part of the program. I think there is a recognition that the submarine telecommunication, submarine cable industry, and the surveyors that support it can make these data publicly available, and Quintillion was very good to step up and do that as probably the first example.
Fantastic.
Yeah.
Any other questions from the audience? There's one more online, and this one could be answered probably by Larry, but again, can you think of any incentives to motivate Russia to publicly release more of their bathymetric data to improve IPCAO? Can you think? You may not be.
No, I think in general it's not just Russia. I mean, there are many nations and there are many organizations that hold data currently globally that could be sharing this data for the good of mankind. And I think it will start with community education and outreach. That's a significant component of Seabed 2030, is to make really humanity aware of this massive challenge that we face in terms of an ocean and a planet that we really haven't adequately mapped, and trying to create some guilt in that process, and hopefully ultimately create stakeholders that are willing to share for the benefit of all.
Thanks. And not to put you on the spot, but since the next talk is about divining, this question is about divining. How much future bathymetric charting will be done by autonomous vehicles, particularly in shallow waters? Can you divine that?
I can say in general that full resolution, high resolution, full coverage mapping in the ocean has been expensive, and it's even more challenging in the shallower water. So it gets increasingly expensive as you get to the shallower waters. I would say that the technology that comes out of XPRIZE's Shell Ocean Discovery XPRIZE Challenge may crack this nut. I mean, the goal here is there's going to be 20 teams competing with potentially game-changing offerings that could be deployed successfully and cost-effectively for deep and shallow water mapping. And we haven't seen those yet, but over the course of the next 4 months, we will have visibility on what those solutions might look like.
Fantastic.
Yeah.
David, thank you again.
Yeah, thank you.
And you do wear...
I do, yes.
All right, we're going into our last standalone presentation before the panel. Just want to remind you there's going to be a panel on Arctic marine transportation led by Dr. Lawson Brigham. So I hope that since the weather is so bad and terrible out there, we're not going to lose any of you. Hope to see you back at the panel. Next presentation is going to be given by Dr. Alison Azara. She's an international trade specialist with the U.S. Maritime Administration. Ali's going to be talking about defining the future, how Arctic shipping projections stack up to reality. I'm pretty good at divining the past myself, but the future is more difficult.
Hi, folks. Thanks for sticking with me. I know it's been a long session, so I'm honored to be batting cleanup, but I do realize that I'm between you and cookies. I do like cookies, so I'm going to do my best to get you there. This presentation is really a first look presentation. It's some new analysis that I'm doing. It's a reanalysis of a projections report that was published in 2015. So you guys are all actually the first people to see any of this. So I look forward to your comments and your questions. This is my legal disclaimer. If you need an actual copy, please let me know. So I'm going to do a couple of things. I'm going to review the 2015 projections report. I'm going to compare it with some actual data that we have from the Coast Guard, look at some of the assumptions that we used in our projections and see if they're still valid, talk about some of the differences, and then some thoughts for where we can go in the future. So the report is the 10-year projection of maritime activity in the U.S. Arctic region. It's a report that was done under the U.S. Committee on the Marine Transportation System. It was submitted to the White House by Secretary Fox of the Department of Transportation, and it was in response to one of the implementation tasks from the National Strategy on the Arctic region. The beauty of the document is that it's really a scenario-based document, so you can mix and match the numbers from any of the different assumptions to sort of meet what your questions are. We did use some modeling for ice forecasting, and we used that as a basis to figure out if you could even operate in the region. And then we also used AIS, Automatic Identification System data from 2011, 2012, and 2013 in order to look at areas of high concentration of shipping activity in the U.S. Arctic region. The middle image shows a red box, and that was the area of interest for this particular study. It's from just south of the Bering Strait, a little bit into Russia, and then over into Canada. So there were three major assumptions that we used for this report. The first one is that shipping will grow in the U.S. Arctic at a general rate that reflects a global economic and regional growth. So we had low, medium, and high scenarios, and we used it based on a number of different sources of economic data. The second assumption is that vessels may divert from other traditional routes to use Arctic passages. So we looked at potential diversion from both the Suez and the Panama canals. We focused on 4 types of vessels: bulk vessels, container vessels, tanker vessels, and general cargo vessels. And for the short period of July to November, we looked at 2%, 5%, and 8%, which is about 1%, 3%, and 5% for the total year. The projections we did included both container ships, and we did projections without container ships because, as many of you know, that's a fairly contentious issue. The third assumption had to do with oil and gas exploration. Continued oil and gas exploration will increase vessel traffic. And so we used the required numbers from BOEM and from NIMS and some of the industry projections for what might happen in the region. And we had projections that ranged from essentially no additional oil and gas activity with a baseline year of 2011 all the way up to several different exploration activities in the Beaufort and Chukchi. We didn't have development scenarios because the time horizon for development scenarios is about 15 to 20 years, which is beyond the time horizon for this report, which was only to look at the 10 years out to 2025. So we applied those assumptions to specific groups of vessels. The annual growth rates were applied only to container vessels, which did include general cargo vessels that would carry containers, to general cargo vessels, but not to the bulk carriers that are going to the Red Dog mine. Those were held constant for reasons we can discuss. We also looked at tugs and tankers. Other vessel classes that included research vessels, adventure, ecotourism, government, unknown, we held those constant at a 2013 level. And the last piece I think that's particularly important given what we've been discussing is that cruise vessels for the low and medium scenarios were held at 4 vessels. And for the high scenario, we used 6 vessels. And so we'll talk more about that. When you put all of those together, we have a conservative. The low combined estimate was for 420 vessels and about 877 transits. And so this image shows the 2011 business as usual, and then this is what it would look like in 2025 with that low. So you can see the areas in red are high, areas in blue are low, and there's fairly significant change. So the question for the reanalysis is, are the projections still reasonable? Did we do a good job? Did we totally miss the mark? Did we way screw up with our assumptions? And to answer that question, we started looking at actual data, which is my favorite kind of data. From the U.S. Coast Guard District 17 in Alaska, they've been keeping track of vessel activity in the region since 2008. Their area of interest is sort of up in the diamond in the map, and you'll see it doesn't overlap exactly with the area of interest that we used in 2015, but it's pretty close. I guess you would say it's close enough for government work. So there are 3 things to pay attention to on this particular slide. The first thing are that cargo and tugs, which are in black and red at the bottom, have pretty regular year-over-year increases in the numbers of vessels that are operating in the region. The other thing to pay attention to is for research science vessels, which are sort of at the top in yellow, unexpectedly, incredible increases in year-over-year activity in research vessels. If you look at the general trend, and you start in 2008 and you look at 2012, you could say it would be exponential growth. However, if you look from 2012 to 2016, you'll see that it's more of a flat line of growth. It's more regular growth, but it's more linear growth. And so as we go forward, a lot of what I'm going to focus on is sort of that more conservative approach using the 2012 to 2016 linear growth, because I like to be conservative in my estimates. So when you compare our growth rates, you can look specifically at the orange line towards the bottom and the dotted line that's right above the orange line. If you compare our 420 vessels, 420 vessels from our conservative estimate, and you break out and continue that line from 2012 to 2016 with a linear regression, we're almost bang on, which is super exciting because it means I did a good job. But it also leads to questions about, whether or not we could do better things, because you'll see that the other lines are kind of all over the place. So there's some questions about what we could have done better there. The really interesting thing is that our underlying assumptions for that low scenario didn't really hold. We had some oil and gas in there, but we also had some diversion from other routes in there. And as you all probably know, we didn't really see any diversion from other routes in the past few years. A little bit, but not much. So the question is really, what's going on? Where are all these vessels coming from? The three lines that are solid at the bottom are our low, medium, and high growth rates based on the GDP growth rates that we use for 1.3%, 3%, and 3.3%. The dotted lines show the regression analysis, the linear regression analysis using the 2008 to 2016 and the 2012 to 2016. So they're way above where those lines we thought would be, which suggests that the rate of growth that's happening in the U.S. Arctic region, to include some things that go over to Russia, is far above what we thought it would be. It's an area that's growing faster than the rate of the global growth. You can also look at vessel numbers by type, and I think that this is particularly telling. The two lines at the top are for cargo and tug vessels, which the cargo vessels are almost exponential in growth, and the tug vessels show very consistent growth in year over year. You can also look at research science vessels, which again, important for this group, are growing more than we thought they would. We thought that they would be constant. So when we think about cargo and tugs, those are the two areas that are growing. We can see it in both diagrams, and it's really a question of what's driving this and how much is being driven. The dotted line along the bottom is if you use the mid-range projection. If you use 3% of global growth, which is really what we kind of thought we were going with, we're way underneath where we are actually at in the U.S. Arctic region. The straight line is the linear extrapolation of the rate, and the curved line is the exponential extrapolation. So to go back, you can see that this is more of an exponential rate. This is more of a linear rate. So you've got exponential and linear. So who cares? Well, some sectors grew unexpectedly, and this is what's really neat about this. If you look at 2013, and I'm not sure that it shows up, but this dotted line is basically our baseline. We thought that these lines would be flat, all of them. They're not flat. So something's happening here that we didn't think was going to happen. The really cool thing is that our high estimate for cruise vessels was 6 vessels. We exceeded that last year. So when we think about where we thought we would be 2 years ago to where we are now, it's far above where we anticipated using all the best available information from the cruise industry itself. The research section could be, theoretically, all the way up here by 2025 if it continues at the same rate that it's currently going at. And you might say, well, do we have that many research vessels that are ice hardened that are capable? Globally, we do, and it's a possibility. So where are we now? If you take all of the information from the slides that I just showed you and you add it all up, you get 469 ships, which is really exciting for me because I thought there would be 420 ships. I did pretty good. But it doesn't include oil and gas, and we know that that's a possibility, particularly with the new administration and some of the things that have been going on the North Slope, some of the exploration, some of the discoveries. It doesn't also include any possible diversion, and if you've been following the news and listening to China and Korea and some of the international folks, they really are focusing on the Northern Sea Route as a potential way to move goods across the Arctic. It also holds the bottom categories constant. And we know from the past that when I hold things constant, it doesn't always work out so well. So this is truly a conservative estimate going forward. It's also interesting to look at the number of vessels versus the number of transits. You would think that the number of vessels, you'd have maybe about double for transits. What goes up has to come down. It's not always true. And what's more interesting about it is that you can have a really small interannual variability in the number of vessels operating, and that can create a large variability in the number of transits vis-a-vis the amount of activity. If you're thinking about risk planning and you're thinking about response planning, it may be that the activity and the number of transits is actually more important for your planning than what the number of vessels tells you. So this is important to keep in mind when we think about modeling for the future and assessing the needs in the region. It's not just the total number of vessels, but what are they actually doing up there and how much are they doing up there? So some of the factors that impact projections, we've sort of gone through this. Oil and gas and resource development are huge. One of the major assumptions in the 2015 report is that there would be no deep draft port in the U.S. Arctic within that 10-year time period. So that's something to consider. If there is a deep water port, how does that change what's happening? If there's a deep draft port, how does that change what's happening? How's the location of that change what's happening in the region? We also know that changes in tourism are happening at a different rate than we thought that they would. And the same is true for science. There's a lot more activity up there, which means that we need to be prepared for what that means in terms of response capabilities and support capabilities and infrastructure. So what's a better approach? I know what we did in 2015. I know what I can do looking at a quick look at how we did with those numbers. So how can we do it better? Well, we need to be able to better characterize and categorize the vessels. Knowing who's up there and what they're doing and how long they're going to be there for is super helpful in trying to figure out what that activity is going to look like. The same thing is true for different sectors in the industry. You need to be able to understand what's happening with oil and gas, what's happening with natural resources, but you also need to understand what's happening with tourism and cruise vessels and everything else that's going on in the region. And this is really underscored by having a benefit of better and more complete historical data. The data that we used for the 2015 report was right on the cusp of where AIS data was just getting its feet under it. So the accuracy and the availability of data going forward is going to greatly exceed what we were able to use just a couple of years ago. And that goes to be true for access to more complete data sets. So now that we have more partners that are globally looking at this, we have the ability to look at broader data sets and information that may not have been available. And we have more eyes on the issue. You can have a broader conversation, you can have more context for what's happening, and you can have better partnerships. And I think one of the most important things is to remember that we have to continue to look past red herrings. It's really easy to get caught up in the sexy thing that's happening this year, whether it's a giant cruise ship that's going through the Arctic or it's a groundbreaking oil and gas exploration activity. But there are day-to-day regular operations that are happening in the region. They're going for community resupply. They're going for all kinds of other commercial activities, and understanding those and really having an awesome handle on what it is that those operations are doing is going to make it much easier to plan in the event of an emergency situation. I use the conservative numbers because I'm really not interested in what might happen in a pie-in-the-sky scenario. I really want to know what we can count on having to deal with going forward. And so with that, I will take your questions and your comments and possibly your complaints.
Thank you, Ali. We have about 5 minutes for questions. There's one up there. Paul, wait for the microphone, Paul. Oh, were you yawning or raising your hand? I'm sorry. Okay.
Oh. You got busted, sir.
That's the reaction I get from my wife.
So, are you going to revise the report?
So I think
based on the fact that you have a lot of new information.
Yes, so I think the goal of this reanalysis is to look more in depth. This is just sort of scratching the surface, and to provide a shorter reevaluation of what we did well and what we think might change in the future. Yes.
Hi. Did you break out your analysis by month? Like, is it all for September, or is some of this August, July? What's the seasonality of it?
So we used the time period from July through November, and we took a look at the total vessels in the area. when we were doing the overlay for the AIS information, it was a patchwork because of the incomplete data availability. So for some years we had all 4 months, and then others we had like the first 2.5 or 3, and then we had some overlap. So we were looking at total numbers as reported, but the maps that you see with the heat maps are based only on AIS data as it was available. And that's something we'd like to really work on, making that a better analysis.
Thanks. I have an online question. Why did you exclude ships to Red Dog in your annual growth rates in the model?
So the Red Dog mine has been consistently serviced by somewhere between 23 and 25 bulk carriers every year. Based on their plan, their business plan, that's anticipated to stay at a steady state. So while we need to understand, that's one that we have a pretty good handle on, and so we know we don't anticipate growth for those vessels.
Thank you. One more. Did you categorize the multiple NOAA-funded Healy cruises, ECS, Extended Continental Shelf Mapping Expeditions, as research?
They would either be research or government vessels. I'd have to go back into the data and work with the Coast Guard to figure out where they categorize those specific vessels.
Thanks. And finally, adventurers equals recreational, question mark?
Yes. So I think the more adventures, and those are pretty steady state, are the smaller vessels as opposed to the cruise ship and the cruise industry. I think that's how they divide them.
Thanks. Any other questions? This one up here.
Thank you. Nice job, Allie. Were you able to factor into this reanalysis the news about the LNG shipping that's beginning from the Yamal Peninsula down through the Bering Strait and down to China? I can't remember the number, but I think that the announcement for this indicated that the Koreans are planning to build at least 10 of these carriers in order to serve this demand in China.
So thank you. One of the changes in our assumption was that we thought that tanker vessels originally in the 2015 analysis would grow at about the same rate as the global growth, and they actually declined over that period of time. So going forward, we looked at basically an average number of vessels and held that constant. It's a good point because they're sort of building vessels and we don't really know what's going to happen with that. Sort of the quote conservative way to go is to hold that steady and then in a couple of years reevaluate what's actually happening. There's also a lot of discussion about how the change from construction to extraction is going to shift the type of vessels that are along the Russian coast. And so that's something that we need to think about too when we're looking at the cargo numbers versus the tanker vessel numbers, that could shift in the future because of a change in activity and just what's happening in the region.
All right, thank you. And thank you, Ali. I believe the guys and gals are, with glasses are winning. Yeah. All right, we're going to take that 20-minute break.
put it on your belt, or you can put it in here. So when you guys are ready, just hit the on switch.
Do you remember which ones you pulled?
Can I get a number on this? This is 6.
All right, so which one is that one?
This is 1.
Okay, let me. 8's not gonna use.
Questions from the audience? Yeah, sure. Well, we're going to have some from this audience. Yeah, sure. Yeah, I know, probably more than the audience. Yeah.
2-minute warning.
Probably going to need the commander to.
This week I didn't check because we didn't have a car.
Well, you can get to National Stadium.
Could get to National Stadium.
Yeah, I want to keep this function here.
I've
So that's where we gather OFCM.
We got to get Vladimir's correct presentation.
Okay, hold on. Or not? Yeah.
Better than
Is that the one?
More than 3. Do you know which 3?
No.
Are they in there?
Oh, you're galloping.
Okay.
Well,
So it's number 3. Number 3, number 9.
Okay, 3 nights.
You want to make a duplicate? Just copy it. PowerPoint's on the fly. Everyone's mic?
Everyone's mic. Okay, great. You're about to start, but you turn them on now.
Sure, why don't you just tell them we'll turn your mics on.
Okay, Oh, yes, please. Move or turn them on.
I want to make sure they're off.
I will put mine in.
Yeah, then you don't have to worry about it, right?
3, 9, and 10. 3, 9, and 10, yeah.
Otherwise, here we go.
I think they want.
She's
Any fine they might get. I'm not sure they care.
Yeah, I'm watching. You got 3. Upload their cat. Oh, I can tell you which one this is. Since they had to provide presents and loss of value of the cat. So
go blow.
They said this is how much money they made.
Inez.
So you can.
That's what they want to do.
Oh, that should be.
Somebody there needs to get creative right now. Quickly.
Just do 1, 2.
Blow it.
It's working. Do I see 8 pages? Oh, panels.
I think we should put glass on that way. First one. You get,
Much better. Keep it.
glasses.
Yeah, I'll start. Can everybody hear me on this lapel mic? Hopefully? Yeah? No? Can't? Look, it's green.
Do we need a microphone?
No, I don't want to use a mic.
I can hear you.
Walk around.
Glasses if I want to see that.
Now working? Working? Move it up. Move it there. Yeah. Good afternoon, everyone. I'm Lawson Brigham from the University of Alaska Fairbanks. I also am what they call me is a fellow at the Coast Guard Academy's fledgling Arctic Center for Arctic Study and Policy, trying to gear up a center of excellence at the Coast Guard Academy. We have an excellent panel today to talk about what we in PAIM and the Arctic Council call now marine operations and shipping. Arctic shipping for many people is a lot of different things, but for 99% of the people I deal with is trans-Arctic shipping when it's all destinational. So even the terminology, and I'll just say as an introduction that the word transit in the maritime world is from port to Milwaukee to Sturgeon Bay or wherever, Miami to New York. The proper terms are trans-Arctic voyage. It's a hard one. But the word transit, when you look at numbers of the Northern Sea Route, there's a lot of misinformation, even published in The Economist and others, that revolve around this word transit. So even terminology of this topic, complex topic of Arctic marine transport, what does it all mean? And we have Captain Ed DePage with us from the Marine Exchange of Alaska, the visionary of this marine exchange and surveillance and monitoring system, prevention system, right? Sure. And Drew Pierce is well known in Alaska as a long-term legislator and lawyer in Alaska, and she's going to report on one of the studies of the Arctic Circle's working group, I think, on marine transport. And Captain Hawkins heads a division, directorate at Coast Guard headquarters that deals with design of ships and standardization, but he also goes to IMO and is going to say a few words about the Polar Code. And Professor Vladimir Plavlenko, you've seen this afternoon, and is well known in the community. It's nice to have you here to talk about the Northern Sea Route a little bit, and not least of which is Molly McCannon, one of the country's leading experts on observing systems and the director of the Alaska Ocean Observing System. So I think we'll start first with Ed. And we have a couple, some of the speakers have just a couple slides, and I'm supposed to keep everybody on time. So Ed?
You got my timer on.
Yeah.
I'm with the Marine Exchange of Alaska, which is a nonprofit maritime organization in Juneau, Alaska, and I got two of my board members here, so I have to behave myself, both my board. But I've been involved in marine safety operations for about 45 years, between my Coast Guard experience 30 years, and out in the pirate industry for 15 years. There have been a couple of wake-up calls. I know there's concern about potential for accidents in the Arctic, and it's a very fragile environment. May I have the next slide, please? And I've been involved in several cases over the years, and most significantly, most impactfully for me anyway, and many others, was Exxon Valdez oil spill. And so I've become an evangelist for prevention. Spent 3 years working that oil spill, and then I've subsequently been involved in events like the Celadang, what have you. And I became a believer that the challenge is we don't have maritime domain awareness. You can't fix or address problems you don't know they're out there. If the fire department doesn't get the alarm, they're never going to be very effective. And so you really need maritime domain awareness. And then from there, you need to do something with that information. You need to do maritime domain management. Next slide, please. So Celadang, that picture just up beforehand, which I shouldn't have forwarded on, is an example where we didn't know the vessel's in trouble until too late. You can back up one. If you can even go backwards, that's great. That we didn't know it was in trouble, didn't know it was breaking down, didn't have any risk mitigating measures, stay offshore, what have you, notify anybody when you're in trouble. None of that happened, and therefore, that's one vessel split in two. 6 people died. The Coast Guard tried to rescue the crew, and of course, they're doing so. Their helicopter crashed, and the people they rescued perished. Major oil spill, loss of cargo, major impacts. So, mainly because we didn't know what was going on at the time. Next slide. So, fortunately, a lot of people in this room and people we've talked about several days are working this issue. And there's a shared interest and commitment in maritime domain awareness. You've heard some of those presentations. Right there is some of the folks that we deal with. Clearly, the Coast Guard in the state of Alaska, but also the Arctic Research Council, the Arctic Domain Awareness Center, Alaska Ocean Observing System, and we work very closely with the Alaska Maritime Prevention Response Network, an organization that stood up a couple of years ago to address the risk of vessels and casualties. Next slide, please. So what we've done, together with those group and contribution to the whole Coast Guard, state, and the maritime industry, is built one of the largest, in fact, the largest vessel compliance monitoring system in the world. And we're using satellite AIS and 130 AIS terrestrial stations, and we're also transmitting stations and weather stations throughout Alaska. The red dots represent the automatic identification system, terrestrial sites, and also some of the transmission sites. Next slide, please. And this is today. I just took a screenshot this morning of what we're looking at this morning of traffic in Alaska. Next slide. Here's the traffic the last 10 days in the Arctic, the Bering Strait in particular. Next slide. There's traffic last year. So this maritime domain awareness has given us information, which we've heard some of our senators talk about, the importance of information to make good decisions. We're giving information, we can identify the risks. Next slide. And then this information is being managed. That's the key thing, is managing this data and doing something with it. And we're managing in Juneau, in our operations center, 1.5 million square miles. The next largest system of that nature is Australia for the Great Barrier Reef, 100,000 square miles. So this is substantially larger. Next slide. And then what are we monitoring? We're monitoring those vessels and ensuring vessels are complying with the risk mitigating measures that have been established for Aleutian Islands and the Arctic. Next slide. That's distances offshore, it's authorized passes. When a vessel breaks down, I got the timer on, that we actually know about it early on. Next slide. Here's a change. Before, vessel with serpentine, the top left, serpentine, Aleutian Islands, high risk. Same exact vessel. After we implement the risk mitigating measures, is doing the standard of care, Great Circle route, distance offshore. Next slide. And if they go the wrong place, we call them, they turn around, go the right way. Next slide. Polar Code talks about priority in monitoring tracking ships and also the Arctic people. Next slide. We pay attention, we read that stuff, we work with the Coast Guard, the Next Generation Navigational Safety Information System. We're working them as virtual aids in navigation. We're actually putting buoys in ice virtually, because you can't put them physically in there, like in Cook Inlet. We're doing that and testing that. We can disseminate dynamic marine protected areas and ATBAs with AIS. We can notify vessels of whales. We can monitor compliance automatically and set up alarms. Next slide. And we're also tracking the local natives, so we know where they are and where the big ships are to minimize conflict. Next slide. And giving the communities access to this information so they know the vessels in their backyard. Just get on their iPhone, they got the information. Free. Next slide. So how's this applied? A couple days ago, you might have heard the comment, the comment mentioned this the other day about the Maersk vessel that broke down. Next slide. That's a 900-foot container ship, 20 miles of containers, on instant passage going to Alaska. Our watch watched it, sent this graphic to the Coast Guard and said, this vessel's not in the command, and it's going 0.4 knots. It's like watching a car on a highway going 5 miles an hour. Something's wrong. Yeah, it's broken down. They contact the vessel, say, we're okay. Next slide. But we said, well, it's drifting from 13 miles to 5 miles offshore. Doesn't look like it's okay. Coast Guard engaged some tugs. It was towed in Dutch Harbor. 3 days later, they made repairs. That could have been a Celadang U had that not been intervened, detected, monitored. By monitoring, just like the police on the highway with the radar guns, influences behavior. Monitoring vessels influences behavior and detects incidents before there are major incidents. Next slide. Joint interest in this. I mean, we're collaborating with our Russian colleagues. The Coast Guard's working on access routes, so we're not completely there, but we've implemented a lot of things over the last 5 years to manage risk and identify problems early on. So it's still work to be done, but we made a lot of progress. So it's not like the Wild West, which it was a couple of years ago. Now it's no longer time's up. Done.
Great. Thank you.
How's that? Good grief.
Go ahead, Drew. We'll call up your slides. Thank you, Ray.
Great. So I'm here today to talk about the Arctic Circle report on shipping and ports. Those of you who aren't familiar with the Arctic Circle, it was founded by President Grimson of Iceland. Go ahead to the next one, please. And the chair of the Arctic Circle board is Alice Rogoff. Next slide. Authors of the Arctic Circle report include Meade Treadwell, who would have given this presentation today, except he climbed on a plane headed to Japan last night. Myself and Paul Foos, chair of the Alaska Marine Exchange, and I sit on the board. We all got involved in marine safety after the Exxon Valdez, just as did Captain Page and many others in Alaska. In fact, most of us just have changed hats a lot of times, but have stayed involved. Next slide. The Arctic is central to global transportation and aviation today, shipping and surface modes tomorrow. Go ahead. And then to the next one. We already have 10,000 people a day and numerous flights, lots of cargo that is transiting the Arctic in the air. Next, there are at least 3 Arctic rail links that are in some sort of a planning stage. The Russians coming out of Archangel. The Finns are building rail to connect to the coast of the Arctic in Norway. And there are 2 separate projects that I'm familiar with that are looking at trying to connect the Alaska Railroad to the lower 48 through Canada via rail, coming down to connect in probably Alberta. So what's left? We have opening seaways. Next slide. And that's what we want to talk about today. Next. Working with Dr. Brigham, the Arctic Council Arctic Marine Shipping Assessment in 2009 looked at what the safety agenda should be, and that was updated in 2013. Next. The 3 basic questions that Meade, Paul, and I have been asking is, can nations work together to establish safe, secure, and reliable seaways in the North? Can a League of Arctic ports help global shippers benefit from new and shorter shipping routes? And how do we pay for sustainable Arctic shipping infrastructure? We recognize that Russia certainly has the Northern Sea Route structure and that the Canadians have the Northwest Passage, but we're looking at a polar transit and how to set up an actual seaway that is a polar transit that would be an international effort. Next. The International Seaway, we believe, could cooperate across administrations and support trans-Arctic shipping with an international fleet of breaker escorts. Next. Our approach is to draft legislation. No, next to the our approach. No. There. Next is to draft legislation to study, do a study plan for sea ice conditions and icebreaker assistance and what's going to be needed and when, obviously, it's going to be needed, to estimate the costs for basic seaway services, figure out what sort of number of transits you would need to cover those costs, figure out what your tariff rates might look like, and whether or not you could have a competitive position doing some sort of an international cooperative effort. Next. Paul Foos has been working on putting together a League of Arctic Ports. He, by the way, was the mayor in Dutch Harbor when the Exxon Valdez happened, and the mayors who weren't part of the oiled mayors group all wanted the same sort of basic protections in their seaways, particularly Dutch Harbor, as the Prince William Sound and Cook Inlet got after the Exxon Valdez because of OPA-90 and our state legislation. So our approach in this case is to invite Arctic ports around all 8 nations to convene, to create a constituency for a seaway, to have coordinated infrastructure planning with all of them, and also to have a unified voice to work with the financing community. Next slide. Looking at how you might finance this sort of infrastructure, going to the development banks, and actually that's one of the tasks that Meade has on his plate in Japan, even as we speak. Looking at infrastructure investment banks, intergovernmental initiatives, anchor projects that could facilitate Arctic shipping, and global maritime insurance, because we're seeing the insurance industry drive some of the requisites in the Polar Code and others of our laws and regulations. If the insurance companies won't insure your cargo, you are not going to be using any route through the Arctic. So we're looking, next slide, at the St. Lawrence Seaway as a model. It's a great international model. It took legislation from both the United States, also from the Canadians, to set up an international entity. And you have basically one-stop shopping as you approach the St. Lawrence Seaway, and you go through, regardless of which side of the border you're on, which ports you're going to, you go through using the seaway. So we'd like to apply that model as much as we can to the Arctic. We have been looking at parallel legislation or an international agreement where we can make that happen so we could offer the service. We've been looking at revenue and regulatory models that could support icebreakers along with navigational aids and also safety aids. We are looking for support from insurers and salvers, and frankly, that's where we've gotten the most support so far. We also are looking at the legal differences, and we have to respect those, of course, because the differences in water status, depending upon where you are. And we're looking at perhaps invoking UNCLOS Article 234. Next. Next, please. The Russians, of course, are very interested in increasing the viability and the use of the Northern Sea Route. They've undertaken, as we all know, a huge infrastructure build-out, which is important to making that a viable option on a long-term basis. At the Arctic Economic Council meeting in February of this year, they made a presentation talking about their view of the Northern Sea Route economics. Next. They looked at world seaborne trade and the Northern Sea Route and where they thought they could take actual cargo business away from other transit routes. Next. Looking at projects and how they could leverage the advantage of the shorter distance of the Northern Sea Route and the quicker time between hubs. Last slide. So you can sign up. I hope it's better shown back there. You can sign up to read the working papers and also to comment, which we'd very much like, at Arctic Circle Seaways Report.wordpress.com.
Thank you, Drew. Excellent. Great. Different models, different views, different kind of themes of how to approach this marine transport systematic look. I think the League of Ports is kind of an intriguing and different view. Ben, do you want to say some eloquent words about the IMO Polar Code and other issues?
Thank you, Lawson. I'll certainly do my best. I don't know about eloquent, but I will certainly endeavor to give you a high-speed, high-altitude pass on the Polar Code and spare you the PowerPoint presentation in the meantime. So, in summary, the international community, prompted by the opening access in the polar regions, particularly the Arctic, as well as the actual and anticipated increase in traffic, became, appropriately so, concerned about the unique risks that the vessels were going to be exposed to that they weren't necessarily going to be protected by the existing international standards and conventions. Similarly, they were concerned about the environmental sensitivities that were now exposed to this rise in the traffic. So they started to come together with this idea that we needed to create a new regime for the polar regions to protect against these risks and protect the environmental sensitivities. So the result was work by the IMO to develop the Polar Code. This started with the development of international guidelines for the Arctic, but it eventually evolved into a mandatory two-part code that was intended to close the gap between the existing international conventions and the risks and sensitivities that there were in the polar regions. So this is where it's an important time to take note of what the Polar Code was intended to do, because what the Polar Code does is it builds on conventions that the International Maritime Organization had already promulgated, namely the Convention for the Safety of Life at Sea, as well as the Convention for the Prevention of Pollution from Ships. And so using that as a baseline, the understanding that all the vessels calling on those polar regions would already comply with those, what was the delta that needed to be covered? And that's what became of the Polar Code. I mentioned that it's a two-part code. So part one addresses safety. Part two addresses the environmental concerns for the polar regions. For the safety, it takes a risk-based approach to address both operations, equipment, and vessel design. What it requires owners and operators to do is to actually do an operational assessment of the types of operations they're going to do in the polar regions. So this includes what kind of vessels they're going to be using, where they're going to be operating, when they're going to be operating, as well as what kind of operations they're going to do. And then out of that risk assessment comes more specific standards for the operations and equipment and design, but also what they call a polar water operations manual that addresses the capabilities and limitations of these vessels, and it's used by the crew in making decisions. Conversely, on the environmental side, it's a bit more prescriptive. The Polar Code actually comes out with very specific prohibitions and or restrictions on discharges, and then for the newer vessels, actually has specific standards for design and construction. With that in place, the Polar Code entered into force in January of this year, so we're well into the implementation phase, and the code is out there for those vessels that are sailing internationally in the polar waters to comply with. But the implementation is ongoing because there's still some other aspects to it, and it's very multifaceted in that regard. Each of the member states of the IMO now have to come back home, look at the Polar Code, look at their domestic legislation, and try to figure out what parts of the Polar Code they're going to have to promulgate through national regulations and standards. Along with that, there's a requirement for, more than likely, for policies. There may be some interim policies required until they can actually promulgate their national legislation. In addition, there's a need for policy that articulates what an administration's point of view might be on specific parts of the code. And so that's ongoing. And in that regard, the Coast Guard is already, the U.S. Coast Guard has already promulgated 2 policy letters, one on training and manning, and another on the safety and environmental provisions of the Polar Code. And that's out there for owners and operators to use as they pursue a polar certificate. Finally, I go back to the operational assessment, and this is part of the implementation. In order to do the operational assessment, owners and operators really need to understand the risks that are out there. And the risks vary depending on what kind of operation you're doing and where you are in the polar regions. And so through the code, local governments, local captains of ports, industry, they all have to kind of, harbor safety committees need to come up with the information that they need to provide to the industry so that they can make informed and insightful operational assessments. And in that regard, it's worth noting that the Arctic Council, through the Working Group for the Protection of the Arctic Marine Environment, has underway an effort to support a harmonized implementation of the Polar Code by trying to identify authoritative information that might be used in an operational assessment and kind of find a central location where owners and operators can go, take that information and use that in their operational assessment. So that's just like I said, a very high-speed, high-altitude summary of the Polar Code and how we got to where we are today for the implementation. Hopefully that provides a little bit of context for today's discussion.
Thank you, Ben. Excellent overview. Vladimir, please.
Yes, slide, please. I would like to show some information about past, present, and future. Third slide.
Third slide.
Yes. Some information about past, present, and future of our atomic icebreaker fleets in Russia. And next, please. 9. And development of the Northern Sea route in Russia as an integrated task within the framework of Russian Arctic policy. It's a rather serious strategic document in our country and extremely important for understanding place of Northern Sea route for our economy, social system, and environmental, by the way. Integrated development United Russian Arctic Transport System formed by the Northern Sea route and the development of the Northern Sea route based on the meridional rail and road airport network, the transport system of the Russian Federation. It's all this transport system implementing of coastal and marine special development models in Russian Arctic. And I would like to emphasize that development Northern Sea route and coastal zone along northern part of Russia extremely important for our country because share Arctic zone Russian Federation in national income about 12%, with population less 1%. And in Russia, in the coastal zone, in northern part of Russia, we have 15 freezing ports. And through the sports, we work and extract some of extremely important resources for our industries and for export. And third one, if you heard maybe, that's after 2020, will involve to exploration gas deposits in the Yamal-Nenetsk Circle, and common extraction oil gas in this region will be more than 30 million tons. It's a need for a real transport system, and some of institute, next please. Some of Institute of Russian Academy of Sciences involve these projects by interest of Northern Sea Route and the Federal Scientific Center for Integrated Arctic Research. One is a scientific center which involve projects to develop infrastructure in Northern Sea Route. And I would like emphasize for us, in our country, extremely important that we work together with local authorities. Yamal-Nenetsk region, Taimyr Peninsula, and some of companies which involve in this process. And you can see a number of scientific projects we elaborated, and now we are going work under this problem. Thank you.
Thank you. Just go back to Vladimir's first slide, because there was an interesting number on it. No, not the first one, second.
Which one?
Third slide. See the number? 3,741 ships piloted back in 1989 at the time of the Soviet era and the Northern Sea Route. So this
you
transport
mean the icebreaker Lenin?
With the icebreaker Lenin, so that, you know, we were talking about 800 ships in the Bering Strait, so puts it in context that this kind of transport marine transport took place during the whole of the Soviet era. Very interesting.
You are very active discuss about built in U.S. icebreaker, and I think that you know about it.
Yeah. Thank you.
I'm not stopping because
great.
I was sure that you know our history for built icebreakers in Russia. Excuse me.
Thank you. Molly, we'll get your slides up here.
Yeah. And while the title slide is coming up, I'm Molly McCammon, Director of the Alaska Ocean Observing System, which is part of the Integrated Ocean Observing System, a national program. We are state, federal, and private. We're a quasi-nonprofit. We operate under the kind of the mode of stakeholder-driven, science-based, and policy-neutral. So I'm going to talk about observing systems more from a local perspective. Next slide. So for navigation safety, we look at observations. We don't look at, these folks are all dealing with ports and icebreakers. Those are megabuck kinds of things. I work with Ed Page and others on a lot smaller kinds of observations. So one of them are high-frequency radars. These are shore-based radars that do surface current mapping. They're used for search and rescue operations and oil spill response. They've been shown that when you have an HF radar system, that you can actually reduce your search area by more than 1/3 to 2/3. So that would be huge along our west coast here of Alaska. So we've been trying to get radars along in key choke point areas on the North Slope, Bering Strait, Aleutian Passes. Right now we have them on the North Slope. We've been putting in wave buoys in the Bering Strait for the last 5 years. The challenge there isn't deploying them, it's getting them picked up before the end of before the ice comes in. We've almost lost a couple of buoys in the past couple of years. Now we're bringing them closer to shore and working with the Port of Nome and others trying to put those wave buoys closer into shore. The other operation we're doing is working with Ed to put weather stations on a lot of the AIS stations so we can have more localized, tailored weather products and also have the ability to deliver two-way communications and do alerts and warnings, as he mentioned earlier. Another project that we've been trying to do, one of our big challenges is ice, and how do you keep instruments in the water till the very last minute? You want that very late fall information. So we've piloted a freeze-up detection buoy that when it detects, it has a a MET station on top that when it detects fragile ice, you can send by computer a signal. The MET station falls off, the buoy goes down, and you can retrieve it the next year and put another MET station on. Next slide. So these are all relatively inexpensive types of observations that really add to our maritime domain awareness. If you talk to people in Western Alaska, their big issue, a lot of it is coastal erosion and storms. Without that shore fast ice, communities are really facing a lot of issues there. So we've been funded by the National Weather Service to test a number of pilot projects. We have 3 inland tide gauges on the west coast of Alaska for 3,000 kilometers of distance. Inlands are the kind of the gold standard of water level observations. Delaware coast has 3 for 50 kilometers. So there's a huge disparity of observations. So we're testing all kinds of different things using GPS reflectometry that are shore-based observations, little gauges that go into cages on a shore at a community that they can put right before a fall storm comes in, and testing these various kinds of things, trying to develop a better, maybe less robust, but have broader coverage and a lot more sustainable over time. Next slide. AIS vessel tracking. We've heard a lot about this over the last 2 days. It's the land-based and satellite combined. It's a huge database. Our program has a high-performance compute center based in Portland, Oregon. We're working with ED and a number of partners like ADAC and others to systematize that data collection and put it into a database that can be updated in near real time and queryable for lots of different purposes. These are just some of the things that people want this vessel tracking data for: prioritizing where to do bathymetric surveys, doing oil spill scenario modeling, trying to develop conflict avoidance for subsistence hunters and vessels, trying to develop marine mammal avoidance with vessels as well. So it's a huge need, and I think we finally have the funding support this year to actually tackle this and try to develop some products for this broad user community. Next slide. Environmental intelligence. It's not just the water itself, it's what lives in the water and how people use it. So we are hosting the Alaska Ocean Acidification Network. Lots of concern about ocean acidification and how it's going to affect subsistence resources, food security. It's just a major concern to communities throughout Alaska. Similarly, we have some of the highest rates of paralytic shellfish poisoning and domoic acid incidents. So we're also standing up a new Alaska Harmful Algal Bloom Network. Again, trying to bring together these kind of various community monitoring pieces and information and having a one-stop shop, someplace where people can go for information and network various activities. We've also been working with the university developing ecosystem moorings. So you can't, ship surveys are great, but you can do broad coverage, but only in the ice-free season. The moorings are there year-round. They're in one spot. They do soup to nuts from the ground to the top. Really broad range of ecosystem parameters. And our goal is to have one in the Chukchi, one in the Bering Sea, one in the Beaufort, and one in the Gulf of Alaska. The Chukchi is now fully built out. We're starting on the Bering Sea. Lastly, we're testing the use of gliders for detecting the presence-absence of marine mammals. So acoustic recorders are on them with an Arctic call library developed by Woods Hole. And in near real time, you can track where marine mammals are. This was primarily developed for use in the Chukchi during the oil and gas development there with Shell, but it's also proven useful in other regions of the state and also now in the Gulf of Mexico. Next slide. So, and lastly, you have all this information, and I appreciated Elizabeth from Quintillion, her comment about the challenge of data access in small communities and how challenging it is. We have a data portal that is now NOAA certified as a regional data assembly center, which means we meet all the bells and whistles and standards for QA/QC. But it is data intense. We have a high-performance compute center based in Portland, Oregon. It's geo-replicated like 3 times. We have lots of information, lots of tools, but it is data intense. We can run models on our system. A lot of communities can't do that. So now we're trying to, how can we develop products that are still useful that they can use in their communities? We host all of the industry data that was collected by Shell, Statoil, and ConocoPhillips in the Chukchi, which was a great one of the first data sharing agreements with private sector. And let me tell you, it's not just to our benefit, and it's huge for the science community. It's also to the industry's benefit. If they come back in 10 years, they know we have that data. They don't have to go hunting around in boxes in various places and basements in Houston trying to find the data from 10 years ago. So these are the kinds of things that we look at when we talk about an observing system and how to address the marine transportation needs in our region. Thanks.
Thank you, Molly. Great, great. You could see that we had good synergism between what Molly had to say and Ed, and what Drew had to say and Vladimir about integrated transport systems. And then across all of this is this new governance system for the oceans in the Arctic and the Antarctic, and what Captain Hawkins had to say. I'm going to just take my prerogative to ask a question of Captain Hawkins and put him on the spot a little bit here. The Crystal Serenity is coming up. Drop the hook off of Nome. Below the polar code boundary at 60 north, but nonetheless headed up. What do you think might happen from the Coast Guard standpoint when that ship comes to Nome?
Well, what's going to end up happening is a foreign flag vessel is going to be subject to port state control. As a vessel that sails into the polar regions, it's going to have to comply with the polar code, and therefore, you'd expect that there would be a port state control boarding. Our officers would go on board. How that boarding would go and what we would be looking at has already been promulgated in policy that we've put out there. And so we go on board, make sure that they're in compliance with the polar code.
What are they looking for?
Well, they're going to start mainly first with the Polar Water Operations Manual, because that's what they need to know. If they've got the Polar Water Operations Manual, they've done the operational assessment, they've assessed the risks, and they've done something to mitigate those risks. That's the primary importance of that boarding. There's other, they can start getting into other details, but that's the very first thing they're going to look at.
Great. No, just to give most of the American citizens here, a few from Canada, what's going to happen in the implementation, but really the enforcement of the Polar Code. And it's a good example that the Crystal Serenity, being this huge ship, the first thing that if I was going aboard as a lieutenant inspector, I'd chat with the captain, have a cup of coffee, and ask for the polar certificate. Let me see the polar certificate. And then, of course, have a long dissertation about the Polar Water Operations Manual. Thank you, Captain. Great. I think I'll take one of the questions here from online. For Ed Page, how does the Marine Exchange AIS note the location of whales? Is it solely based on reports from mariners or through some other method or mechanism?
It's a good question. I mean, right now we have areas that we've known from scientists, whatever, they're high concentration whale areas. So we call a watchdog on it, where we have speed limit, and we'll have automatically send off emails of vessel exceeding the speed limit in that particular area. So as it turns out, it's kind of like a policeman. Everyone knows at the corner with the radar gun 24 hours a day. Nobody speeds in those areas because they know they're being watched 24 hours a day. Our next step is to an example is Glacier Bay. They use the hydrophones so they can know where the whales are, similar to what Molly's been doing, locating where the marine mammals are. So we can actually have a dynamic area to be avoided, or marine protected areas, where we can send information to vessels real time to the bridge via AIS, say there's a whale concentration, or whalers for that matter, and give it a wide berth and stay out of this area. We can cross-hatch it on the chart, or just say a diameter around this point, stay 5 miles away, what have you, or reduce your speed. That'd be working with the science community and with the Coast Guard. Really more the technology can send and transmit information. Someone else is going to make the policy calls, the Coast Guard or environmental protection agencies, identify what action is needed, whether you need to stay away from a walrus fallout area, whatever. That's where the communication, other information, domain awareness from ADAC and AOS and whatever, helps us get the right information in and out to the system to the mariners to minimize environmental.
Yeah. Well, thank you, Ed. Molly, has a question online for you. You said that AOS is quasi-nonprofit. But folks want to know, what does that really mean? How much is the government involved? How much is private, or whatever?
Yeah, we're governed by I call it a fairly loose memorandum of agreement. We're housed, our fiscal sponsor is the Alaska Sea Life Center, which is a nonprofit, so they do our administrative and grants management for us. And the reason I say it's quasi is that we would be an official nonprofit, except that you get into these, we have a big federal presence in Alaska, and so our founders were a lot of federal agencies, and we want them to be actively involved and be able to be involved. A lot of them, their lawyers, when they start looking at things, don't want federal agencies to sit on boards, and because you have dual, who do you report to, the board or the federal government? So anyway, it's a MOA housed within the Sea Life Center. We do get a lot of our funding from NOAA, from the federal agencies.
Thank you. Good. And I think you may have said it, but Ed may have said it, but of course the Marine Exchange is the ultimate public-private partnership. Got industry really driving it, but input from and funds from the Coast Guard, from the state of Alaska. So it is a true public-private partnership, which we hear in the Arctic all the time, kind of glibly thrown out there. And there are not too many of these, and this is a working one, and it's a world-class system. So we have a quasi-nonprofit, but formally set up, and we have a true public-private partnership here. Are there any questions that the panelists would like to ask each other? And then I'll move to the audience. But anything that you all have from anybody else that there's a question? Vladimir, you have any questions of all of us, since you're the resident Russian expert here? It's okay. No, we'll open it up to the audience.
No questions, just thank you very much.
Oh, yes. Oh, go ahead, please.
Me?
No, I'm going to. Drew has a question.
So for Molly, how do you take the information you have and let the people in the coastal communities around Alaska, the smaller communities, know what's available? And we've always found that's very difficult.
It's very difficult. I think the primary way is by working with kind of our super users. So it would be the agencies who work in the hub communities. It's the Coerics, the Manilics, the North Slope Borough, the Northwest Arctic Borough, kind of those larger groups that we work with most closely. I can tell you that somebody told me that if you could put a MODIS satellite image of ice on a cell phone and have it high enough resolution for subsistence hunters in the spring, you would be God in Western Alaska. So that's the challenge to all of us, is to be able to get that, available on a cell phone. But yeah, it is a challenge. But we have had a series of coastal resiliency workshops in the last year that have really brought a lot of community members together. And I should note that Alaska used to have a coastal management program. The legislature let it lapse, and we do not have one now. And so there is a gap there that I think, in terms of community interaction and engagement, that has been kind of filled by folks like Coeric, Manilic, some of these groups, the landscape conservation co-ops that are funded by the Department of Interior, groups like myself, Alaska Sea Grant agents, stuff. So those perform a valuable service.
Thank you. Great. Questions in the audience? Yes, Helen.
Hi, thank you.
Identify your affiliation. Not everybody knows you. Almost everyone.
Hi, Helen Brohl, Committee on the Marine Transportation System. Thank you so much for the panel. My question is, you're pushing out, Ed and Molly, you're pushing out information to the industry, which I know they appreciate, and especially weather-related information. You don't have a NOAA panelist, but I wondered to what extent you knew of, or there was some corollary to NOAA's vessel observing ship program, where vessel operators provide real-time weather information back to NOAA, since large areas in the middle of the ocean are very hard to monitor. I wonder if you know to what extent there may be that participation in the U.S. Arctic at least, or if there's a corollary in which you're engaged. Thank you.
I could say something that, of course, the Coast Guard cutters, any Coast Guard operation, they report all the weather back to NOAA. as a government part. But
so the Weather Service puts out its weather forecast, and then they do get lots of observations that are called in from ships of opportunity, a lot of them from the commercial fishing fleet. That's huge in the Bering Sea. And you will see their weather forecasts are all annotated, and then they're improved. Sea ice forecasts the same way. They're all annotated based on observations and kind of that knowledge that's coming in. We've been doing a couple of pilot projects about putting instruments on fishing vessels and trying to get some more oceanographic information. We just outfitted one of our state ferries with ocean acidification sensors so we can start getting some observations that way. There's a continuous plankton recorder that's been put on a container vessel from Long Beach that goes up to Anchorage once a week, once a month, something like that. So there are different ways of doing it, but it's a challenging still to do that and then have it meaningful.
If I could add, we're also putting weather stations in places where there haven't been weather stations, so it helps for forecasting purposes, and it's consistent data, 24 hours a day, updated every 2 minutes, as opposed to a vessel, it's various different locations, what have you. So that whole Bulu base, all that information together, is very valuable. But no one of those pieces of information can really save the day. You need a combination of different sensors and what have you. We even do current sensors, for that matter. Send the information to AIS to vessels, so in their port, and approaching the port area, a tight quarter situation, they know the current, what have you. So there's several different ways we're going, expanding that capability.
I think it's worth noting, too, that the operational assessment that's required under the Polar Code envisions taking this kind of data and maritime domain awareness into account and doing that risk assessment, both leading up to voyages and in situ during the voyage. And that's part of what the Arctic Council, and I mentioned it briefly, the PAIM working group is trying to find these pockets of authoritative information and provide a portal by which they can quickly access, and we're not sending owners and operators off to find this by themselves. We can put it in a central location for them.
Yeah, good point.
Excellent.
Another question from Henry? Harry, excuse me.
Hi, I'm Harry Stern from the Polar Science Center. I want to get hold of shipping data for research purposes as far back in time as possible. Should I get it from the Alaska Marine Exchange? Should I get it from AOOS? Is it free? Do I have to pay for it?
And it depends, and I mean, people ask for it all the time and say, I just want this bit of information. It's 2 million lines of data, so it's a lot of work. So for a month in a particular area. So it's a matter of how much effort it takes. Some of it's free, and some of it's not. Depends on how much data you want. But we go back, not as far as Amundsen, obviously, but we go back about 6-7 years, what have you, of data that we can accumulate in different regions. So I'll give you my card later, and between Molly and myself, we can figure that out for you.
But the Canadians have in data for the Northwest Passage. Some of it's on websites. In Russia, the Northern Sea Route Information Center has data for at least full transits, transarctic voyages, and other internal voyages. So there is data, but there's no one site. People ask me all the time, same question, how do I get the database? Well, it's spread around the world. And the only real database, it goes back to 2007 in the AMSA, where we did the first world-class kind of integrated, and we included fishing vessels. But it's a little outdated now, so we do need to have, but now there's much more data by AIS. I mean, it's proliferation of data, but nobody's chewing on it and looking at analysis other than Allison here that gave the presentation. She's looking regional. Circumpolar, it's a harder thing to come by. It'll come.
But there are a number of efforts that are doing that, because the Arctic Observing Network, I'm on a working group on AIS databases, and there's at least 4 international efforts that are going on separate. People hadn't even known about the other, which is kind of common, but now they're all talking together trying to integrate these kinds of activities. So I think it's going to improve in the next couple of years.
I should also add that the Coast Guard just this last March, that is, not this March, the March before, expanded the carriage requirements on vessels. Here before, they didn't require many of the vessels operated in the Arctic to have AIS because they really didn't have a capability to receive the information. It wasn't really fair. But so the carriage requirements have expanded dramatically. So some of the skewing of the data can be attributed to the fact that people now have AIS. Beforehand they were invisible. Now they're visible again, or for the first time for that matter, not again. So that those are things that have influenced the data to some extent. The larger vessels have been required to have it in international trade since around 2004, but the domestic vessels have not been required to have that capability. So those are things that kind of influence the behavior, and people need to understand. And also the richness of the data is a lot of misrepresentation. A lot of vessels are called wing and ground in the Arctic, which aren't wing and ground at all. They're 200-foot vessels. They're offshore supply vessels. They're not flying above like aircraft. So we're always constantly vetting and correcting the data, dimensions, type of vessel, what have you. So it gets kind of complicated when you want to have good data versus raw data, et cetera, et cetera.
Next question. Okay, David. Not projecting.
Jackson from the Canadian Ice Service. It's not really a question, but it's more of a comment and an augmentation on the weather question that you had asked. Any ship that makes synoptic weather reports, you can follow them on SailWX website. And any ship in the world that makes synoptic weather reports, you can follow. That was it.
Yeah, good. Thank you. Anyone else? Oh, sure. Since you got your hand up.
Could you just comment on the PAIM effort to compile shipping data that's supposed to come out in 2018?
Oh, well, I can tell you about the old PAIM, but maybe Molly
No, that's
might.
one of the efforts we're working with. I don't have the details on it yet. We're trying to actually just put together a spreadsheet that shows who's doing what, at what resolution, what's their data source, what's their future sustainability, things like that. So, yeah, I don't have the
What we
details
did in
on
the
it.
first AMSA, though, was have the Arctic states themselves provide the data. We gave the electronic survey to the senior Arctic officials, who were quite surprised, but then they passed it to their maritime administrations, and everyone was kind of forced before the AAS era to cough up the data. Your national official data, whether it's complete or not, we make no judgments. And so the new effort isn't quite that way. There'll be a central, but it depends. What's Arctic shipping? But really, for the PAIM and for the Arctic Council, and for most of us, it's what vessels are emitting and discharging. So we in the AMSA took 100 tons. It doesn't cover everybody, but it covers a lot of vessels. And so to get that data back 7, 8 years ago was challenging.
So it'll be available in 2018?
Maybe.
It's supposed to be,
Hopefully.
yeah.
Yeah, good effort by PAIM and the Arctic states to pull it together. Another question? We got still a few more minutes. Yes, sir.
Thank you. Kudos to all of you on your work. Part 2 of the Polar Code is silent on air pollution matters. So I have a question for Ms. Pierce in particular. What, if anything, can you and Mr. Treadwell and others do as you promote a League of Arctic Ports and potentially trans-Arctic shipping, quote unquote, to address the concern raised by Niels Bjorn Mortensen from Maersk in the Sea Blind movie that I happened to catch today regarding the concerns for good enforcement of the 0.5% sulfur standard that will take effect in 2020 for global shipping outside of ECAs, and the concern that poor enforcement in many regions of the world and potentially growing opportunities for trans-Arctic shipping will actually work against the competitive well-being of the good guys that are running ships across the oceans, because they can't compete if they try to comply by using the compliant fuel, and you don't have good enforcement elsewhere. So I'm just curious, what, if anything, can you do long-term, working with insurers and others to try to help the Coast Guard and EPA and others address this issue? I know this is really on the margins. I'm happy to discuss it with you afterward, but Mr. Mortensen had a point that I thought was pretty intriguing.
So what we would like to institute is an international cooperative effort that would basically require ships, obviously, that are using the seaway that we set up to meet the standards that we want them to set. And this whole effort started, frankly, after the Exxon Valdez. We put great prevention and spill response co-ops on the North Slope, Alaska Clean Seas. We've got SERVs in Prince William Sound. We've got CISPRI in Cook Inlet. We legislated the hell out of all of them and forced that. But then we watched, and Paul, because of his longtime residence and the different positions he held, living and working in Dutch Harbor, other communities in the state were saying, well, where's ours? And then we watched all the transit of the commercial vessels, Innocent Passage, using the northern route, the Arctic route coming from the Pacific Rim to the United States, and coming through the pass just outside of Dutch Harbor, and they had no protection. They weren't members. They had no coverage. So how could we possibly get those ships to join some sort of a co-op? How could we require them to? And as a state, unfortunately, and I was in the legislature at the time, as a state, of course, we didn't have the authority. And Admiral Barrett used to tell me often, well, that's a great idea, but the state of Alaska can't make that happen. The Coast Guard might be able to, but in Innocent Passage we can't. So we started looking at what can we do to ensure that all the ships that are passing through our waters close to our communities are members of a co-op so that they have coverage. Do they have a contingency plan? And we want them to have that. That led to the discussions as we started looking at the Arctic, and the communities coming around to the north of Alaska all wanted coverage also because they wanted to know who was out there, who are those people, why are we seeing cruise ship passengers coming onto shore in Barrow, and we didn't even know there was a cruise ship was coming, and where's customs, by the way? Who are these people? So we were looking for something that we could put together that would provide for safe Arctic transit with the bells and whistles that are needed, that would make the insurance companies feel comfortable that the cargo that they were insuring would be safe. And at the same time, how could we require that the ships that use the service meet the standards? They meet the standards of the Polar Code and whatever other standards the entity decides it wants to put into place. So I see all those things as coming together and frankly being the reason. And I understand what you're saying about the good guys and are they going to find themselves in an uncompetitive atmosphere, but that's what we're hoping we can stay away from and find a way to make everybody want to be good guys and use this low sulfur fuel. There also has to be a cost-benefit analysis because who's going to bear the costs? The communities on the North Slope from Nome coming all the way around, they're very concerned, gee, all these new regs, what's it going to do the costs of bringing the materials to us in the village? And the only way we can get those materials is the once-a-year sea lift that we have. They don't want to see their costs go up that make their communities uneconomic to live in. So that's a balance we have to look at.
The air emissions will be covered at IMO in the future with an Arctic Air Emissions Control Zone, for sure. Yeah. And likely, highly likely, oh yes, it's coming, for sure, because there's an air emissions control zone around North America. There is in the Baltic, too. Well, let me finish, if you don't mind. All of the ships in the future of the Arctic clearly will be driven by technology and be powered by gas. In fact, Socomflot, the director, Sergei Frank, briefed the Prime Minister of Russia a week ago, and he said to the Prime Minister that all of our ships by 2022, all of our tankers and LNG ships will be powered by gas. So, I mean, Russia probably lead on this, and they were going to cut the emissions, air emissions. Anyway. But when you look at integrated systems around the globe, when we did the Arctic Marine Shipping Assessment, the atmospheric chemists told us that all the contrails, all the aircraft over the Arctic really was a tremendous impact compared to a handful of ships at the surface. And so I would say that, that if we're going to take a look at the Arctic Ocean, it's not just ships, it's aircraft. So you have to, for climate change and for emissions, take the global picture. And, you know, a lot of people flew here, right? I don't know if anybody flew over the Arctic, but I do all the time. I'm contributing to the, you know, to the environmental impacts in the Arctic, likely, highly likely, more than a handful of ships. And maybe more than a handful of ships in the future, of course. That's what folks are talking about. But nonetheless, the air emission issue is a challenging one. I wouldn't put it number one on my list. I'm sorry. You know, heavy fuel oil. There you go. I mean, but it is an issue, and I think from the AMSA, we looked at that and knew that it was coming, but probably not part of the first iteration of the Polar Code.
Time for one more.
We got well, maybe a couple more minutes, or what do you? Yeah, Martin, please.
Thank you very much.
Sure. First.
Yes, I'm glad that we got to the emissions part. Ships not only have air emissions, and thanks, Brian, for bringing that up. They have lots of other waste categories. They're all in MARPOL. Polar Code is part of MARPOL. Of course, they are amendments to MARPOL. Some of those provisions in MARPOL that apply to all of the oceans, including the Arctic oceans, basically make the Arctic Ocean a no-discharge zone. Ships have lots of wastes that they generate and that they have to get rid of. What are ports and terminals in the Arctic, as they get developed, are they going to be ready to handle that? Big, important issue, I think.
Excellent point. Thank you. Martin?
Thank you. Martin Jeffries, Office of Science and Technology Policy. I have a comment that amounts to a plea, I guess. And it's prompted initially by something you said, Lawson, in your opening remarks. I'll come back to that in a moment. But then I might not have said anything in response to what you were talking about using correct terminology. But then Drew Pearce used a figure that Chris Hladek used also yesterday morning that got me a little bit agitated, and I feel I need to say something. The figure in question is the map to illustrate this possible railroad connecting Alaska to Fort McMurray, Alberta. Now, when Chris showed the map yesterday, I just sort of looked at it and thought, oh, that's interesting. But I'm sitting a little closer today, and when Drew Pearce showed it, I looked at it under the boundaries between the provinces of Alberta are shown in that map. And I realized that in that map, Fort McMurray has migrated about 1,000 kilometers to the southeast, to south central Saskatchewan. I lived in Alberta for 4 years, so I feel qualified to comment on the geography. So that railroad is going to be an awful lot more expensive than it already will cost should it ever be built to the true location of Fort McMurray. But this gets to the point that was brought up yesterday, that we need facts to inform policy. We better get our maps correct. As an example of that, that is Saskatchewan, not Alberta. Coming back to the comment you made, Lawson, about transit, and in the marine and maritime sense, that has a particular meaning. As a recovering sea ice researcher, I'm constantly reminded of the misuse and abuse of sea ice terminology. We have heard more than once in this meeting the Arctic sea ice cover referred to as an ice cap. Please, it is not an ice cap. An ice cap is a terrestrial ice feature that forms from the accumulation of snow. It is a kind of glacier. If we can't use the correct terminology amongst ourselves, how can we communicate to a broader audience that we're trying to influence, to explain to them and convince them that the Arctic matters? I'll stop ranting. Thank you.
Good points. I mean, language and the words that get me going are, maybe somebody can explain to me where the high north is. And the high north, I can explain to you what it is. It was a domestic internal Norwegian term to cover the north of Norway, which is hardly Arctic. Svalbard's Arctic, but not the north of Norway, because you go to Tromsø in January, it's not ice covered, right? I mean, it's ice-free because of the northward drift and Gulf Stream, et cetera. So even in the political world. But I see in this town sometimes the use of high north. And I've asked a few times, of course nobody knows where the hell the place is, and so, but it's the Arctic. You know, I mean, we're geographers, Martin and myself, supposedly geographers of sorts, and yeah, terminology and this marine transport issues, and there are a lot of nuances to it, but thanks for bringing that topic up. Hey, Molly, please.
Well, maybe just to end on a little lighter note on this, too, terminology. So the first time I heard the phrase marine domain awareness was about 15 years ago. So I turned to my experts, a retired Navy captain and a retired Navy admiral, and said, I don't get it. What is this marine domain awareness? They looked at each other and went, let's Google it.
Good.
So
let's
we've come a long ways in 15 years.
Let's have a round of applause for all the panelists. Thank you.
Well, thank you very much. Really appreciate your contribution. In terms of terminology, when someone said that where's ICE, I thought they were talking about immigration control and enforcement, but then I thought maybe they're talking about ICE. Where's the ICE? So thank you very much. We're going to be here tomorrow with a similar program, so hopefully we'll see many of you back. Thank you for attending and sticking around.
Hey, if anybody giving presentations tomorrow has any concerns or wants to do a dry run, I'll be down here for a little bit.